Welcome everyone, this is Michael Gibbs and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers, and I'm super excited to be here with you on day 7 of the free Cisco Certified Network Associate Bootcamp. Again, this is a completely free CCNA 200-301 program so you can pass the Cisco Certified Network Associate exam. My name is Michael Gibbs and I've been working in technology for over 25 years. I'm one of the original Cisco certified internet experts. My CCIE number is 7417. I've spent about a decade with Cisco, and I've been in technology, specifically networking, for over 25 years, and I absolutely love it. So in this course, we're going to talk about the CCNA, which is obviously the Cisco CCNA 200-301 exam. We'll be talking about Cisco networking essentials, and whether you call this network administrator training or network engineer training or cloud architect training, it's essential for any of you in these roles. So I like to view this as networking for cloud computing, and I like to view this as cloud computing technicals. But the reality is, whether you're a network engineer or a cloud architect, you're still dealing with networking. And what is the cloud? It's a network in a data center that's been virtualized. So this Cisco CCNA course or the CCNA course for beginners or this free network training will help you as a cloud architect, a solution architect, network engineer, an enterprise architect, or even a network admin. And that's why we're teaching these things. So we've obviously covered everything from what is a computer network and an intro to networking course to networking and cloud computing. And we're going to have lots of fun with this free CCNA training. So let me know you're all there by typing hashtag CCNA in the chat box. And we know that you're going to be there. So keep all these things. We're super excited to have you back. So let's just talk about a few things. Make sure you all know to download your completely free version of our AWS Certified Solution Architect Professional book. Definitely want you to see this book for the following reason. It covers everything from the beginning foundational stage of the cloud all the way to passing that AWS Certified Solution Architect Professional exam. It's a completely free book. And not only is it a completely free book, it will help you get your first cloud architect job, learn the cloud, and I really want the best cloud architect careers for you. So I just wanted to let you know that. Also, if you're working for cloud computing, on our channel, and Chris will provide links to it, we have a completely free AWS Certified Solution Architect Associate course. And even though it's super basic compared to this, we also have an AWS Advanced Networking course, and that is, again, completely free. And we're out there to guide you to build your best career. We have multiple free events per month, for example, or free events per week where you come on our channel and we'll answer any questions you have. You can see us on YouTube. We've got thousands of videos for you. And guess what? You can see us in the press almost every day of the week. We're out there to help you build your best career. Today, as a matter of fact, we were featured in a magazine that only interviews CEOs, and they interviewed us and was talking about how to help people get their first cloud architect jobs, how to leverage the Great Resignation, how to keep employees' best talent. And I got to tell you, it's going to help you get hired. So I'm going to pop a link to that article. We posted it on LinkedIn this morning. So you can go out there and grab it if you desire, because I want you to have, by far, the best cloud architect careers. And there's a lot of information in this free article that you can receive that's in the chat box to help you go out there and get cloud architect hired, build your network engineering career, build your network architect career, just have a better career in general. So go out there, check that article out. It even links back to our YouTube channel. So there's lots of cool things that you can learn about the future work and how to get that first job. So let's go back and we'll start talking about networking, because, networking is really where it's at. Without the network, we've got nothing working. So let's talk about some networking things. Yesterday, we worked on some routing, we worked on some access. Let's talk about securing network devices now. So how do you secure them? So here's the thing. Do you see how every time so far, we've actually put a password directly on the device? Password, Cisco. We put the password on the device. Did you notice that every time I did a show run, you could actually see the password? And then I entered the service password encryption command, and guess what? Then it was an encrypted password. But guess what? The password's still stored on the router. Does this seem like a good idea? Hack into the router, hack into the passwords? No. So if we want to make our devices secure, it's better to take the authentication or authorization and accounting and put it somewhere else. Okay, let's kind of think about that and keep that in our mind. How would we do that? Well, if we were to telnet our SSH to a router, and then the router would go ask somebody else, like a radio server, is Mike Gibbs allowed onto the network? Yes, he is. What is Mike Gibbs allowed to do? He can do anything he wants. Okay, that's it. So when we're dealing with securing these things, one of the things is just to secure the passwords. And let's face it, if you keep your passwords on an encrypted radio server, or your passwords are stored in an Active Directory server, you don't have to put it in the router. So that's a lot more efficient. Much, much, much more efficient. So, if you're doing it on the router, guess what? We can still do it by place the passwords in certain places, but if we can take it off, we can. But even on the router, we still want to encrypt the passwords. So I know I showed you this before. Let me make sure that I still have it up and running. I'll show you one more time. Let's go back to one of our servers. We just did an OSPF lab. We'll open it up. I just want to show you what we did yesterday, and I want to show you what I mean by the passwords being clear text and the passwords being not clear text. So let's go back to our server. Let's go to this device. It's never been here. We've not used it for anything. No, we don't want to configure this dialog box. I'm just going to show you what I mean by passwords and securing these passwords. Now, the reality is, for the most part, you're going to use a TACAX or a radio server or an Active Directory server, but, let's just walk through it. So in this particular environment, we got our device. Configure this. Big terminal. Let's say password. Cisco. But now when we do this, let's see. Oh, wait. You can actually see the root password by looking at this. That's not so good. Let's fix that. Now look at that. All I did is I typed service password encryption, and now there's my new password. So that's really what we were trying to show you. That's how you make it a little more secure. Even better, don't store it here anywhere. Store it in a radio server. So just kind of keep that, and we can do that anywhere we desire. Let me just make sure this is shut off. Apologies. Okay, so now you know what we're dealing with regards to that. So let's make sure we give you stuff that are. So we also have the ability to just set it up as an enable secret with an MD5 hash. So let me show you another way that we can do this to basically do some service password encryption. And I haven't done this one in a little while, so let's see what we got over here. Control C, config T, no, enable password 7. No, get rid of this. No service password. Service dash password. There we go. Okay, so now what you'll see if we look at the running configuration. Let's see. You should see it anymore. See, you can't see it. Now let's try doing it a different way. Let's type enable secret Now, what's this going to show us in the running configuration this time? And now you can see we used an MD5 hash. And by using an MD5 hash, we've still got the same password in here. Now, the password is still Cisco. And if you don't believe me, look, I'm going to log out, exit. Now I'm going to type enable, and I'm still going to type Cisco. It's just that you're not going to see it.
Mike, you're not sharing your screen.
Huh.
There we go.
Well, that's
everything for the past minute or so.
let's redo this. I really miss my Mac. Let me tell you, I'm going to get a new Mac so I can know exactly where everything is. I'll have a Windows computer to do work on and a Mac to use the rest of the time. So maybe I'll switch back to Red Hat or something. Config T. Let's get rid of this enable secret. Ugh. Control A. Takes you to the beginning of the line. No enable. Okay, so if we look at the running configuration here, we can see there's no service password encryption and no enable. Instead of doing the set a password, enable password Cisco, and then after I did the enable password Cisco, I typed service password encryption, I could actually use an MD5 hash on my password to make it unreasonable. And what is a MD5 hash? It's what's called a one-way hash. So here's the thing. If I put the word Cindy into a one-way hash, it's always going to produce the same output. But you can't go from that output and then figure out the name Cindy. So kind of keep that in the back of your mind. So if we just typed enable secret, like instead of password, and then over here we tell it, for example, the name of what we want to call it. So let's say it's called Cisco. Now when we look at the show running config, because I use the enable, let's see what it shows us. It shows us the enable secret. See, you've got it over here. You can see it's got this 5, which stands for MD5, and you can see that it's got a one-way hash. So that's kind of what we're trying to show you here. And really what we're dealing with is if we wanted, we could also create like a username and password local on the computer. So let's see what this would be for instead. So config T, let's do no enable secret, etc. So we can use another form of it. Now let's say we wanted to use a stronger encryption algorithm than say MD5. Maybe we want to use script, which is used by certain blockchains and cryptocurrencies. Maybe we want to use SHA-56, which is used by Bitcoin and other encryption technologies. So let's say we want to do this. So I'm not sure if this iOS will support it, but let's say we wanted to say, let's say we wanted to do a username.
Make sure to share your screen, Mike.
So let's say we decide to create a username and password, something more than a password. So let's do this. We'll do a username command, username. Now after this, we're going to name Cindy, because Cindy likes routers. She loves to break networks. And then after this, we're going to tell it the algorithm type. Okay, so let's say we want to do a really good one. Algorithm type, do we have SHA-256? Yeah, we sure do. Okay, so now we've got a good, now let's type the secret, which is going to be the password. Secret. And then for the password, what are we going to type here? What are we going to type? Let's type it Cisco. Cindy and Cisco. Now we've got this. So now we do a show running config. Show run. It'd be helpful if I could type. What do we see here? What are we seeing over here? Ah, look at that username, and it's got a password. Oh, that's looking really ugly. Why is this thing so ugly looking? Why? Why is this thing so ugly? Because it's a 256-bit encryption algorithm. So we're going to get a lot longer, and it's going to be much harder to hack than MD5. That's why it looks longer. Well, not sure why this router is frozen, which is not a good thing. Let's Let's see if we can get back into it. That's the thing. Sometimes these devices actually, so we can see that it's up and it's running, and we're good. Let's go back to our content. So what you've seen, what have we done so far? We created a username and a password with heavy-duty encryption. Then before that, what did we try to do? We created a username and a password with a local database. We created a password. We encrypted the password. So, this is kind of what we're really talking about. Now, let's look at what these security architectures would actually look like. I'm going to do that in the architecture section. So let's talk about some port security on the switch. When you're dealing with stuff on the ports, if I plug my cable into the port, I'm attached to the network. I want you to think about this. If I plug into the switch, I'm on the network. So I can hire 50 Navy SEALs. I can have three Marine Corps Scout snipers doing overwatch around the Navy SEALs. I can have firewalls, IDS, IPS systems. I can have dogs roaming the hallway. And if I've got a switch or a router like this, which is plugged into the network, and somebody plugs into one of these ports, every part of my security is gone. 100% of the security has been violated because somebody plugged in. So do we feel that this is robust? Security? The answer is no, not even one bit. So, we got to make sure that you can't just plug into the network. Exactly. So now let's look at this. What can I do to keep you from going into the network? Well, there's a lot of things I can do. How can I keep you from causing problems? Well, for one thing, if you go to plug in the network and I don't want you on my network, can I just say no, thank you? Remember yesterday we had this identity and access management. We had Eva Doikia that left Bulgaria, who went to England, who's now living in Hungary, and she jumps on a plane and she's going to stay with us to have a good time with my cat, Cindy. Eva Doikia and Cindy, they like each other. So Cindy plugs into the network with her computer, and it says, Cindy the cat, going to have a conversation with her friend Eva Doikia. Cindy the cat is welcome. Awesome, right? Now, Joey plugs into my house. Joey is a bad actor. Remember, Joey's the mean cat. I don't want that mean cat talking to Cindy's friend Eva Doikia. Joey tries to plug into the switch. An alarm goes off. Switch port shut down. Switch port shut down. Nobody's getting on the network. So that's called port security. Port security. And we can do it in a couple ways. We can basically make a switch and we can give it rules. If this MAC address comes in, open the port. If this MAC address comes in, close the port. Wow, think about that. Open it up, close it up. Wow, isn't this nice? So in other words, I can only allow the people on the network that want to be. Admission control. Think of it about this way. You got a highway. You want to get on the highway, you got to ask permission. You getting full that way? No, not at all. So when we're dealing with these things, we've got options. And each option gives us the ability to do things. So we can determine, how many users are going to be on a switch port. We can determine them. So basically we do it as follows. We go to the switch port and we get into the sub interface. I'll show you how to do it. And then we determine what kind of things we want to do. So we can set the maximum number of people or MAC addresses that come in inside of a port. For example, we can tell it to sticky learn, for an example. So I'll just show you some basic port security configuration, which we can do on any one of our switches over here. So let's take our switch over here. Let's get out of here. Let's turn on a switch. We've got a happy little switch over here. Hopefully, enable. We got a switch. So let's do a show IP interface brief so we can figure out the ports that are on this. Can you guys all see this? Okay, good. So let's say for gigabit Ethernet 1/3, we want to do some port security. So config let's do a show run. We can also look at this. Show run int G1/3. Let's look at this. Okay, so this is what we've got on this. We can see the port is not shut down. Or at least we don't see shut down. Although we see it over here as status down, down, but it doesn't say administratively down. So let's go to this port. Let's configure it. So we'll go to config T. We'll go to interface G1/3. Now we're in the sub interface command. Let's tell it what kind of switch port we want it to be. We want it to be an access port. Mode access port is where you plug in the users. Let's say we're access. And now let's say we wanted to turn on port security. Easy. Switch port. Port security. It. We could tell it a certain MAC address or what to do in a violation, but that's it. That's how we turn on port security. That easy. So kind of hope that works. Wanted to walk you through that so you can see some of these things. Again, when it comes to things, the challenge is almost never configuration. It's always what are the things that you need to know to be great at your job. And I want you all great at your job. I want you all having miraculous careers and having just, the best time of it. So kind of keep that in the back of your mind while we're doing some of these things. Let's make sure we got all these things over here. So let's go back to, okay, so. Okay, just make sure you guys can all see me. So now let's go back to our content over here. Now that we talked about that, let's talk about some violations. Like I said, we can shut down, etc. So how will we look at it? So when a port gets shut down, how are we going to know? Well, we're going to look at it, the switch, and we're going to look at a show port security, and it's going to tell us what's happened. Everything with these things is about a show. So for example, if I want to show this, a show port security, we're just going to look at it. And it's going to be real easy for us. I'll show you what I mean. So we'll go back to here. We'll do a show port security. We can see which ports have it, and we can see what the action is. Shut it down. With a violation, shut it down. And here you can see if we wanted to get really, really careful, we can really lock these systems down. I'll show you a way if we really wanted to lock it down. So let's say in this particular case, go back, config T to show you if we wanted to get really heavy duty, this is how much. So let's go back to the port so you can see it. So if we do a show run interface G, was it 1/3? Pretty sure it was 1/3. Okay, so if we go to the switch port, we can do more. We can really lock it down. If I wanted to, I could do a switch port. Go back int G1/3. And under here, what could I do? I could do a switch port. Then I could do port security. Then I could give it a MAC address. And I could tell it whatever I want it to be. Oh, wait, I think they like to do it this way, if I remember correctly. Now we did it. And then when we tell what do we want it to do, we can do, for example, a violation protect, switch port mode, switch port, port, security, violation protect. So what I'm just showing you is what we can do is we can literally build a policy to make the switch port do whatever we need in terms of security. Now, when people say in the cloud it's extra secure, I'm like, are you kidding me? We can't do any of that. We lose all these things in the cloud. So the cloud internally becomes less secure because we've got our layer 3 stuff, which we'd like. But in the data center and the network, you can do our layer 2 and our layer 3 things. In the cloud, we lost all the layer 2. So anytime we get out of our data center, guess what? We're finding ourselves in a position. So now you can understand the concept of what we're doing. And then now if I were to look at these interfaces, we can see so much more. But, that's really what we're talking about. So let's talk about DHCP, or Dynamic Host Configuration Protocol. Actually, before we do, let's do this. Let's see if anybody has any questions. Let's take a couple minutes of questions. And then after a few minutes of questions, we'll come back and we'll start talking about some more content about DHCP and how do we implement it. And why is it such a challenge on a router to implement DHCP? And why is it a much bigger thing to do than it would be on a router when we implement DHCP? And there's lots of good reasons why. So let's make sure we understand those reasons. So let's bring in some questions. Chris, I'm trying to find StreamYard. Bear with me. I know it's here somewhere to see where the questions are coming from. But there's something with this Windows 11 with all of its virtual desktops and things. I can never seem to find anything. So let me try and find that. So I can, is it this one? Okay. Got it, Chris. Okay, let's bring in some questions that I can answer. Any recovery options for a lost password? Absolutely, Angelo. I think we'll probably talk about it. But what has to happen is you have to plug into the console part. And normally the register, I think the memory register is 2102, and you have to change it to 0x2148 or vice versa. And then what happens, you can recover the password. So yes, absolutely. But you have to be manually attached to the router to do it. Kaigoiso, is it dedicating authentication to a radius server or an Active Directory server best practices? Absolutely. That's what people do. Because when you've got 3,000 of these routers, you can't manually update 3,000 routers' passwords. And having 3,000, 4,000, or 5,000 routers and switches is nothing in a big network. If you have 3,000 locations, you have 3,000 routers. And if you've got a data center and things, you could have literally 20,000 routers. So yes, absolutely. It's a great idea, and it's always something you want to use whenever possible. Outsource the authentication to a TACX Plus server or radius server or an Active Directory server. Good question. Well, we shut down the NAC with port security. DHCP is something totally unrelated, and that's basically how a host gets its IP address. So we use the port security command to actually set up things like 802.1x and port security. DHCP, we really aren't using the routers for DHCP. We could potentially make the router be a DHCP server, but nobody would really do that in production. Now, there is some special things we have to do in DHCP, like with regards to helper addresses, which I'm going to explain why in a minute. But they're not related to LM. Chris, if you want to bring in the next one. Sarah Ahmed. Yesterday, we did layer 3 access list. Protect 192.168 from reaching 1.2.3.4. Port security is layer 2. The actual physical card. You plug in a hardware card and the MAC address isn't recognized by the switch, it won't allow it on. So layer 1 would be not giving you access to plug the wire in. Layer 2 would be not recognize your MAC address list. And then 3 is basically filter your packets. So think about it this way. If you can't get to plugging a cable in, you're really restricted from the systems. Then if you plug something into the network and you get shut down the second you plug into the network, if you're not allowed to be on the network, now you're secure. And then at layer 2, we can also make an access list as further security. And then we go up one lever to IP packets, and now we can do another set of filters. So really it's layer by layer. That's why the data center is always so much more secure than the cloud. Because we can do all this layer 2 and layer 3 stuff. And also, we're less of a high value target. Hack Azure, get access to all the customers. Hack Cindy the cat, you get to see Cindy the cat photos, which are really beautiful to see, but obviously less valuable than hacking into AWS or Azure and getting a third of the internet's customers. Looks like you got it there, Sarah. So let's go to the next one. Douglas, the packet has a header, and it'll either be a ICMP, TCP, UDP, and it'll be very, very obvious. Our teaching is great. Thank you so much. You and the guy doing CCNA on Storm are the best networking teachers. Thank you so much. I don't know who Stormwind is. I know I used to teach networking to Cisco people while working at Cisco, to people at WorldCom, which are now Verizon, to people at Comcast, which are still Comcast, and for people at, which was a company I loved working at, was called Riverstone, which became Alcatel-Lucent, which then got sold off to Nokia. So I'm thrilled to be here, and thank you so much for your kind words, Douglas. I love teaching networking, and cloud too, for that matter. Chris, if you want to bring in the next one. Great question. You can pretty much do it either way. Great question there. Pretty much either way is an option for you, based upon what kind of authentication mechanisms are there.
That's it for right now.
Okay, well, this means we're doing good. So if everybody out there is here, if you could type hashtag CCNA and hashtag Cloud Architect all at the same time, it would make me smile. I know you're all there. Okay, so now let's have a little fun and talk about DHCP, or Dynamic Host Configuration. Good, I see the CCNAs, the Cloud Hireds, and Cloud Architecture coming in. Makes me smile. I love it. So while that's coming in, which is going to be a bit delayed before I see it, let's talk about what is DHCP. Dynamic Host Configuration Protocol, also called DHCP, provides one of the most commonly used services on a TCP/IP network. The ability to get your host address automatically without manually configuring it. And by using DHCP, we don't have to run to every computer, manually put an IP address. Imagine running to 200,000 computers and giving them IP addresses. And then wait, you want to change the address. So you're going to go over to 200,000 computers and you're going to change all the addresses. Well, my world, that doesn't scale so well. So I'm looking for more scalability. What can I do to do a better job here? We're going to use DHCP. So DHCP, or Dynamic Host Configuration Protocol, is a means for hosts to pick up their IP address. That's it. It's a mean for a host to pick up their IP address. So that's what it is. Without it, remember, we'd have to ask for it. So what happens? With DHCP, we've got these 4 messages. We've got a DHCP discover message, and I'm going to show you what that means. We have a DHCP offer, then we have a DHCP request, and then we have a DHCP acknowledgement. So let's act them out. Give me an IP address. That's called your DHCP discover. And literally what happens, the host comes up and it screams, give me an IP address. That's called the DHCP discover packet. Next thing what happens is DHCP server or servers say, I can give you an address. I can give you an address. And then the client says, I see 2 DHCP servers. I see one from Alexander. I see another one from Ruth. I'm going to request the one from Alexander. And then Alexander says, ne, echo, which means, yes, I have it. And here you go. So that's what goes on. So DHCP, as soon as the computer comes up, it sends a broadcast. DHCP discover. And the server's like, I heard your DHCP discover. I can give it to you. I can give it to you. And then the server says, I only want it from Alex. And then you got it from Alex and you say, I got it. I got it. And that's how this works. So the DHCP discover, big broadcast. And that, so there's going to be these 4 messages. And what are they really going to look like? You're going to look like this. You're going to see this DHCP discover message. And then the server is going to respond with that offer, and everything is going to be good. So that's how it works. So this all sounds great, right? Okay, but give me an IP address. That's called a broadcast. Now, what do routers do with broadcasts outside of their interface? They drop them. So I want you to truly understand the problem, and then you'll understand the solution. So let's walk through the DHCP problem. Here we are. Let's draw it out. We got over here, we've got Noni. think Abigail's on this call. Abigail's got this beautiful cat named Noni. She looks just like Cindy, but she's Noni. And Noni and Cindy, they decided to be really good friends. They want to talk to each other. They get on the network. They hit, oops, I didn't mean to do this. So let's go from here. Let's make our drawing a little better. Noni goes into the Noni switch. Switch plugs Noni into a router. We're going to walk through the whole routing. Now, the router also has another subnet off of it. And this is where the DHCP server is. So the router is connected to this on one subnet. This is obviously on a different subnet over here. Noni's plugged into this little switch over here. Now we've got another router over here. And this router is over here. And this router is connected directly to Cindy's computer over an Ethernet segment. So Cindy's over here, she's here, but Noni comes onto the network. And Noni wants to reach Cindy. So Noni plugs in and says, hey, give me an IP address, DHCP discover, DHCP discover. And what happens? That DHCP's discover packet is sent to the switch, propagated out all ports except for the one it came in on, reaches the router, and now it's on this subnet in the router. And the router says, this is a broadcast, don't forward broadcast out of my subnet, trash, and it throws the messages away. Now Noni's upset. Give me an IP address, give me an IP address, give me an IP address. I want to talk to Cindy. So she sends another request. Another request, and the router drops it because the routers don't forward broadcast. So Noni says, give me an IP address. I want to talk to Cindy. Please, please, please. And her packet's lost. But Noni's a smart cat. Noni knows that there's a way to get on the network, but she doesn't know. So if any of you guys have seen the movie Born Free, Noni calls her friend Elsa the lion that she saw in Born Free, and she says, Elsa the lion, how are you getting an IP address? And Elsa the lion says, Noni, routers don't forward your broadcast. And Noni says, meow, what do I do? And the lion screams and roars, and the lion says, you have to tell the router to forward your broadcast to the server. And Noni the cat says, how do I do that? And the lion says, here's what you need. You need something called the helper address, and you need to tell the router exactly where to send it to. So Noni gets on the computer. She telnets or SSHs into this router, and she told the router, forward all DHCP packets to the DHCP server. And that's something called a DHCP relay. So what this is called here is the DHCP relay, which says, take this broadcast request and forward it to this server. If this server is 1.1.1.1, we tell the DHCP relay to send it to 1.1.1.1. So we take the broadcast, and I don't know what the heck happened there. Okay, so we take this broadcast, and after we leave the broadcast, we say, hey, go over here. So now let's try it. Hold on, let's figure this out. Let's grab this thing. So now it gets to this device, it hits the switch, it sees the router. The router says, woohoo, I know what to do with your DHCP discover packet. Send, because I've got a DHCP helper address or a relay, send it to here. Now, the DHCP server now sees Noni's request and says, here, I've got something for you. I've got something for you. Here's an offer. Now, she sends the offer back to Noni. But remember, Noni has to say that if they want it, or didn't mean to do that. So now what Noni does is she sends a request and says, okay, I found you, you found me. Can I please take that address? Can I please accept that one? And Noni says this to the DHCP server. And then the DHCP server says yes. Now Noni's on the network. Now Noni's here. Now Noni wants to communicate with Cindy.com. So what does Noni do? She says, I know the IP address of Cindy because I went and got it via DNS lookup. Cindy is 2.2.2.2. So Noni goes to reach out She's got an IP address. And does she have a route to Cindy? No. So what does she do? She looks in her routing table. She's got a default route. What does she do? ARP, who has the MAC address for Cindy. Now the router is a proxy and it answers, I have the MAC address for Cindy. And the router says, I don't know how to get to Cindy, but I know if I go here, I'm one step closer. This router says, I know how to get to Cindy because it's connected. ARP, who has the MAC address of Cindy. Cindy says, I have the MAC address of Cindy. Cindy then sends her packet here. It goes here. It goes to Noni. Now Cindy and Noni are taking selfies of each other's pointy little ears and their whiskers, and they're rolling around and they're having a good time. And they're collaborating on how they can take my network down, which Ethernet cables they can chew through, and all kinds of fun that they have. Now you know what they work. So that's called a DHCP relay service. And all that really does is you're telling the router to forward it to the next thing. So what's this gonna look like? It's gonna look like as follows. So let's assume we wanted to do this. I'll show you what it needs to look like in a minute. Let's say we're on a router. I haven't done one of these in a while, so bear with me.
Do you mean to be sharing your screen?
Yes, I do. Thank you, Chris. Let's say we'll go to this router. Let's just config T, interface G0/0, IP address. Let's just pick something we haven't used. I don't think we've used 172.1 IP, ADDR, 172.16.2.1, 255.255.255.0. It's an Ethernet link. We'll do a no shutdown on it. As an IP, I think it's a helper dash address. So now if we do look at this port, and you can see the helper address. So what's really going on in this situation? So Noni's is plugged into gigabit Ethernet. When she does that, DHCP discover, give me an IP address method, it would hit this interface. And now the interface says it's a broadcast. Routers don't forward broadcast, but forward this broadcast to 1.2.3.4. So now you know how that works. And that is exactly what a helper address is and how we make DHCP actually work. Now we're going to briefly talk about some kind of device management systems. I am not a network management professional. Network management used to be its own CCIE because those of us that are system designers focus on routing and switching and architecture design. Some people focus on management. They're sysops people. I am not a sysops person, so I'm going to do the best I can with these sections. So, but I will. Some of these things like Syslog, I know real well, and other things like SNMP and MIBs and things like that. That's not my world. So the key is these devices send a lot of messages. You saw them: neighbor adjacency change, BGP change, port up, port down. By default, it goes to the log. It goes to the console port. But guess what? You can also send them to a server. It's called the Syslog server, and then you can track all these messages. Now, why would we do this? We basically have 10,000 routers, and they're all spewing their logs to a server. Make a change on one router, you can see what it did to all 1,000 routers all in the same log. So we're logging so we can see the correlation between different events going on in our systems at different times. That's what we're using. And you've seen it. You've seen these messages. These syslog messages look like this. Interface change state to up, down. That's a syslog message. Excuse me. This is what happens when you're allergic to cats and you sleep with a cat every night. Or a cat decides to sleep on your head. So let's talk a little bit more about these kind of messages. When you get syslog messages, they have layers of severity. Now, some of them are minor and some of them are there. So let's talk about, and thank you so much, Sharon and Angelo. Let's talk about the levels. So we've got 7 levels. Remember I did yesterday a debug IP OSPF hello? That's debug. It's a number 7 thing. It's not real serious. Why? Because I initiated it. We also have levels 6 and 7, 5 and 6 notifications that are normal. They're somewhat important, but not critical. Then we start getting level 4 levels, which are warnings, which are a problem. Then we get to layer 3 issues, which are or number 3 issues, which are errors, which become pretty important. Then we get to number 2 issues, which become critical events, really seriously. And then we get alerts, which are immediate action required. And then we've got emergencies, which nothing is working. And that's kind of your systems are unavailable. So in either case, none of these things are good. So how do you actually set up syslog on one of these devices? Well, I guess we can show you. Let's show you how we set up syslog. Again, it's relatively easy. So let's see where we've got this web browser. Okay, bear with me a second. So let's talk about how we would set it up. So let's go over to here. Let's share how we would set up syslog. So let's go over here. So we've been logging to the console. Keep it this way. Let's keep the non-critical stuff going to the console. Let's say logging, monitor. We can see the debug stuff. And let's do a logging buffered with a, we'll keep a certain amount of things in the memory space for things that are moderately important. Now, what are we going to do? We're going to send big stuff to a host dedicated to a specific server. This is going to be our syslog server. It's going to be a 1.2.3.4. We're going to send all critical stuff there. And then what we'll do is we'll send the logging. We'll tell it logging. So this next thing is called a trap, which we'll talk about. A trap is when something happens and you send an informed notification, and we'll send warning levels anytime they occur. So now what you can see is that's really all it takes to change the logging. So we see a show log. I'm not a sysops person, so this is not my world. But you can see in the logging, we've got what we're logging, what we're debugging, et cetera, et cetera. Now that we've talked a little bit about syslog messages, let's talk about network time protocol. So I want you to think about this. Let's assume you have 20,000 routers in your network. Let's assume something happens on Monday, and you've got another. And let's assume you got a cable cut, and this cable cut affects the routing tables on 10,000 routers. Now, if this cable cut took the network down, you'd want to know about it, right? You'd also want to be able to correlate it to see what happened. So imagine if you had a log, and let's take the precision out of the logs. Let's say it's midnight, 12 p.m. midnight, and one device sends you some information at 11:30 and says it's broken. Another device sends it to you at 11:45. Another one at 10 o'clock. Another one at midnight. Another one at 12:30. And it's all the same problem, but spread over 2 hours. Can you find it? No. Now, if all your devices were synchronized to the nanosecond, and if every device that you had a problem at 11:56 with 30.0707 seconds, and you can correlate that this one thing happened and within 5 seconds the whole network went to heck, you can figure out what went wrong. So we have to have synchronized times on our computers. That's why your computer usually syncs itself to Apple's time or Windows, Microsoft time. And what that is, it's something called Network Time Protocol. It's an IP protocol designed to give times to IP-enabled devices. And that way, all your timestamps and all your logs are going to be the same. So, realistically speaking, we connect to an NTP server. Your computer is connecting to one, I promise you. Your iPhone is. When you get on your iPhone, it's got a clock. You know, how does my iPhone right now know that it's exactly 12:52? It's pulling it from somewhere. That's what's going on, is it's pulling it. And because it's pulling it, I can see it. And because I can see it, I know what it is. So these are kind of those things that are super important. Now, could you just set a clock? Sure, you absolutely could. You want me to show you how to do it? What we're going to do is we're going to set the clock. And we're not going to put the time. We're going to give it the time zone, etc. And it's pretty easy. How do we do that? Well, I'm going to show you in a minute. Here's what we're going to do. We're going to go to our router. We'll tell it the clock time zone. Now, let's say I'm EST. Now, what is the world centralized time zone? You know, we Americans like to believe it's New York, but it's not. It's Greenwich Mean Time, which for the most part is UK time, except in the summertime. So we're going to work off of UK time pretty much and everything. And what is it going to be? We're going to be looking for hours from UTC or GMT. So we're off by 5. We're -5. That's why when it's 9 o'clock for us, it's 2 p.m. people in England. Now, do we want it to include daylight savings time? Yeah, we do. So clock, summertime, EDT, I think it's reoccurring. Now our device is going to be set. It's going to know where it is, when it is, and when it is, and all things are going to be good. So I hope that was pretty clear to you why we did it. We want our devices to be there to give us times. And now let's say we wanted to pull from the time server. That's okay. All we're going to do is we're going to tell it where to go to, which server or servers to go to. And of course, we could use more than one server. Why? In case one server doesn't work. So NTP server, we're going to give it an IP address, right? There's 1.2.3.4. Add another one. These are obviously made up. Done. That's how you configure NTP. So as you can see, you know, it's never, the challenge is never configuring these things. It's just knowing what you need and when you need it. So let's walk through some more things. Okay, let's now talk about another protocol called Cisco Discovery Protocol. Now, it used to be when I went into networking, all these routers ran something called Cisco Discovery Protocol. And it was a layer 2 protocol, and routers identified itself. And it is the coolest protocol in the world, unless you're concerned about security. And then it becomes a very uncool protocol. So let's show you what CDP is, or Cisco Discovery Protocol, because it's a very, very useful diagnostic tool. So let's get off of this router. Let's get off of this device. Let's get off of this device. Let's go to this device over here. And we're going to enable CDP so you can see it. So right now I'm going to do a show CDP neighbors. And you should be able to see, oh wait, I already turned on Cisco Discovery Protocol. I usually turn it on, but it's by default it's shut off. So look what happens. I now know I am sitting here on router 1 over here, and I know that I am connected to this device on this port, to this device via this port, and to this device via this port. So that protocol is actually showing me who I'm connected to. Now, if I want to see really good, look at this. Show CDP neighbor, and I think there's a detail command I can do after this. That I can now see my neighbor. This is I mean, this is why we shut it down now. I can see the neighbor that I have. I can literally see what kind of software they're even using on the router. I now know the weaknesses and vulnerabilities in the router by looking at it. I can see their IP addresses. I can see them what's port. I get all kinds of information about my neighbors. This gives me all kinds of ability to map out my network, to troubleshoot it, which it does. But it also gives me a whole lot of information if I wanted to be a hacker too. So, with any of these discovery protocols, look at them. Now, by default, CDP is disabled. I turn it on because when I configure my networks, I like it on. And when I'm done configuring them, I shut them off. And if I need it, I can turn it on for troubleshooting. Realize once you do that, the hackers can see if they're on your devices. They get a lot of background to what's going on. And that's not my favorite thing. So because of that, that's not really the ultimate goal that I try and do things that way. I try, much harder to make sure what we're doing and think, et cetera, et cetera, et cetera. Now, next, let's see what else we want to talk about over here. Now, the CDP was a Cisco protocol, but of course, the IEEE, or the Institute for Electrical Engineers, came up with a version that would be useful for all network devices called Link Layer Discovery Protocol. And what is that? A layer 2 protocol for network devices to find other network devices. So guess what? Same kind of concept, but you can use it with Cisco and Juniper stuff. So we're going to get into NAT next, which is a pretty important topic. But before we do, let's see if any of you guys have any kind of questions that we can answer for you. So if any of you guys have any questions, great. By the way, if you're having a good time, if you can hit the like button, subscribe to the channel, tell a friend, et cetera, et cetera, et cetera. That enables us to grow. Let me see. So those kind of things are always appreciated by us. Likes, comments, subscribes, et cetera. So does anybody have any questions? Before
we don't have any questions just yet. So let's see if we get some that come in the next few seconds.
Okay, if any of you guys have any quick questions, I'd love to answer them. And if not, guess what? We'll keep going to content. We'll have some fun. Today's content's not super complicated. So
So this is not a question, but I'm going to put this up here because it happens every day to us. Somebody, it's not a job offer, but you know where this is going to.
Hi, Mike. I just got an email from a company that emailed you 2 weeks ago asking, question 1, how much notice to provide? Eugene, typically speaking, you should give at least 2 weeks notice. Question 2 is career aspirations. Love to help you with that. And salary requests, etc. I'm happy to answer your questions if I actually know the depth of what you desire to do.
But
first and foremost, Eugene, congratulations. I got to tell you, every single time I get one of these messages, I am blown away and extremely excited. And I know I get one of these every day. But the key is, Eugene, I'd love to guide you and help you. So how much notice? Typically speaking is 2 weeks. Congratulations again, Eugene. I'm just so happy for you. I get at least 1 or 2 people every single day that says this, but I'm just so happy for you. So what I would say is definitely 2 weeks. If they've asking your salary request, what is your current salary? What is your past salary? What is the average salary? What is the average salary that company pays? Do some reconnaissance and figure it out. 3 is, I don't know what kind of job it is. If I knew the kind of job, although I think I know what kind of job it is, because Eugene, your name is pretty darn familiar to me, I could easily guide you in the right direction. So I don't exactly know which job. I don't exactly know which employer to help you with that. But typically speaking, at least 2 weeks notice of your previous employer is very good. Most importantly, though, congratulations, Eugene. I don't know if it's a network job or a cloud job, whatever it is. I'm so happy for you. I'm just so happy for you. I'm beyond thrilled. So Eugene, congratulations. Super, super, super excited for you. And just thrilled. Congratulations. Go and enjoy your new life. But if you've got some questions and you want to ask a more specific question, we'd love to be able to help you. Jim, are we going to make a buck like the cloud buck? I don't know. Our world, realistically speaking, is cloud architects. Do I have a desire to do something in the networking space? The answer is sure. Go back and do networking. It's really where my heart lies. I'm kind of busy, and I don't know if I have any time to write a book. I think our team is definitely focused on writing one book on another cloud in the next year. At least it's a goal of mine. I do plan on creating a leadership book based upon my 25 years of leadership. And regarding that, next after that, maybe networking thing, but it's not on my extreme to-do list by any stretch of the imagination right now. We're kind of bogged down. Right now, I'm more concerned with taking care of veterans and making sure every one of my students gets a great job. Because for us, it's all about, it's a family. Go Cloud Careers is a family. My students, they talk to each other across continents, and they're really great. So it's definitely something I'm considering. But right now, my biggest focus is on getting all of our students graduated and hired. Jazz, it is so good to see you. I'm thrilled to see you here. Also thrilled to see you with your Blue Wrench. And of course, great day for networking. Absolutely. Eugene, DevOps engineer and cloud operations. So Eugene, that's where it's going to get tricky. When you go to the operations side, the salaries are typically a lot less, but DevOps is still really there. So realistically speaking, a good DevOps engineer should be in the range of, $90,000 to $180,000 a year based upon how good you actually are. Eugene, what will determine what you're going to be paid is both your technical skill, but beyond that, really it's about your emotional intelligence, communication skills, presentation skills, leadership skills. That can double your salary or more just by being good at it. So what I would say is 2 weeks notice. I don't know your level of background or experience, so look at your level of background and experience. Look at what you do compared to the other person, and then and then you should be able to do something. But first and foremost, congratulations. DevOps is a fantastic career. It's not one of my more careers that I specialize in more because I tend to specialize more on the architectural side or the leadership side, but I'm so happy for you. So go search what the DevOps engineers are being paid by other similar sized companies. So for example, let's pretend it's AWS. What is Azure paying? What is Google paying? What is Cisco paying? What is Dell paying? That's going to be where you're going to get your information. Then from there, what you have to do is you have to figure out, are you better or worse than average? And if so, where? Are you more emotionally intelligent with better soft skills? Ding, 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 ding. Wow, you're going to really do good. Or are you more technical? Okay, show how you can win technically. The real key is for you to find that special strength. For me, it's my leadership, my communication skills, my executive presence. That's what makes me stand out. That's what I do. It's also my business acumen, but whatever that is, find out what it is, and then find out how to position that to show that you're better than the rest, and you'll get paid much more. So with regards to negotiating your higher salary, the Harvard negotiation project came up with the concept of a BATNA, which I agree with. Basically speaking, you have to figure out what is your best alternative to a negotiated agreement in terms of salary-wise. What is that? If you have 3 offers, you can figure out if this one doesn't come in, go somewhere else. If you've got 1 offer, can you afford to lose that job? If so, what do you need to do? Those are the kind of things that would be there. That's the kind of training we have. So Chris Voss has some good negotiation work. The Harvard Negotiation Project does. Getting to yes has some good information. The book, Getting Past No, also has good information. So there you go. Okay, this is a good question, Asaya. So you get on your computer, you got an IP address. For some reason, it's not working. You maybe your computer just happens to be on the wrong subnet. If you accidentally tell your computer to give up its IP address and ask for a new one, sometimes you get lucky. That's what the DHCP release says, and the refreshes say DHCP releases say give up an address. DHCP requests say give me a new one. Great question there, Asaya.
And we had someone ask about the leadership program.
That leadership program is open and available and ready for purchase on our website.
And the live class part will begin Friday, February 18th.
Yes. So the main version that's all self-paced is available today. The live version begins on February 18th.
That is currently the last question.
Okay. Well, we got through these questions. Let's do some more network training. So while we're doing all these network trainings, let's talk about NAT. So here's the problem. 2 to the 32nd minus 2 addresses seems like a lot. It's a few billion. But you think this is a free? Okay, I'm not even sure what that question is. So we ran out of IP addresses a long, long time ago. So what happened was the Internet Engineering Task Force said, hey, wait, because we don't have enough public addresses, we've got to find some way to basically come up with something that's going to work. So what they did is they created a request for comments. What is a request for comment? Quite frankly, a request for comments is a specification from the Internet Engineering Task Force. So they came up with the concept of RFC 1918, which is the specification 1918, which was called address allocation for private intranets. So private addresses that you use inside of your organization. And by using internal addresses internally, you're good to go. And by using external addresses externally, use public addresses. So what is this private address space? It is 10.0.0.0/8. The next set of private address spaces that we have is we have the 172.16.0.0/12. What does that mean? It means 172.16.0.0 all the way through 172.31.0.0. The last set of IP addresses that we have are the 192.168/16. What does that mean? It means it covers 192.168.0.0 all the way through 192.168.255.255. So we've got a lot of private addresses that we can use. Now that's perfect private addresses. Now, let's assume this for a little bit. Let's assume that we were going to buy another company. What are the chances that company 2 is using the same private IP addresses that we are? Very high. Why? Because the Internet Engineering Task Force told everybody inside of your organizations, use the 10.8 address space, the 172.16/12, or the 192.168/16 address space. So every organization in the entire world is using the same addresses. So what are the chances that you're overlapping with someone else? Really great. Really great. So Cindy the cat has an address. Cindy the cat wants to talk to Jazz over there in New Jersey. Cindy the cat now needs to leave her Port St. Lucie home and be seen on the public internet to go over to reach Jazz in New Jersey. So Cindy has to take her private IP address, which might be 10.1.2.3, and turn it into something public like 75.1.2.3. By doing that, Cindy has a public address. So Cindy wants to go to the internet, she needs a public address. Oh, wait. What if Cindy works for Go Cloud Careers and Noni works for Go Cloud Architects? Same company, by the way, but that's neither here. So they're working for two separate companies, and Go Cloud Architects uses the 10/8 address space, and Go Cloud Careers uses the 10/8 address space. Now, how are those two cats going to talk to each other? They can't. So they've got two options. Either the one side says, I'll no longer be 10/8, I'll be 172.16. They change their address, and Noni and Cindy are talking to each other, having a great time. Now, Noni decides to translate her address to 192.168, and Cindy translates her address to 172.16. Now they've got beautifully unique addresses. So network address translation is used to translate one address to another. It's commonly used to connect to the internet. It's very commonly used to connect external organizations that have overlapping IP addresses. In fact, that's usually the most common use of it. Where did NAT come from? Well, it's an IP specification, so that means there's a request for comment. So, you ever want to learn about something? Don't go to the Udemy video. Go to the source. What is the source? The request for comment. Ask any CCIE. that's got a CCIE number of less than 10,000 back when the exam was really hard, and it was a 2-day exam, we read these RFCs. We read the actual specification. That's how we know these protocols so well. Want to be great? Read the specification. You know how much the specification costs? Free. It's free. Go to the Internet Engineering Task Force. Look up your RFCs. You'll find it. The RFC for NAT is 3022. 3022. So now with NAT, we're going to have a couple concepts in NAT. We're going to have static NAT. What is static NAT? Send you the cat always equals 1.2.3.4. That's static NAT. One-to-one mapping. Always the same. So let's think you had a web server in a private subnet. You give it static NAT. Why? Because the public address is always going to be the same thing that goes to that server. It's static. What do we know about servers? They have static addresses. What do we know about static network devices? They have static addresses, manual, because we can't have our stuff moving around. So for stuff that you need, like a server, you use static NAT. And relatively speaking, it's a one-to-one mapping. Map this address to this address. Constantly, one-to-one mapping. One address to another address. Now, dynamic NAT's going to be a little different. Dynamic NAT's going to change. Dynamic NAT will what? One address, two address. It could be for 5 minutes, or it could be for an hour. It could be for a long time or a short time. So kind of keep that in mind. So static NAT, constant, consistent. Dynamic NAT, not static or consistent. So let's talk about the third kind of NAT. This is called PAT, NAT overload or port address translation. What is NAT overload? If I got 1,000 servers and they want to be public on the internet, I need 1,000 public IP addresses. If I've got 50,000 employees and my company that want to connect to the internet, they really need 50,000 IP addresses. So, not a good thing, huh? So if I use static NAT, one-to-one NAT, and I've got 50,000 computers, I need 50,000 addresses. Oh, wait, we ran out of addresses a long time ago. So what is NAT overload? NAT is one-to-many NAT, and that's what most organizations use. So when you get 1 or 2 or 3 public IP addresses and you stick them on the firewall, and you translate 50 addresses into a single public IP address, that's NAT overload. So what happens is it uses an address and a port number. And that's why it's called port address translation. So by doing the things, it's going to be in a situation. So this is a great article, a great slide that you can find in that book. I liked it so much, I wanted to borrow it, but this comes straight out of Cisco. So get this from your Cisco documentation. You see how you've got these 3 devices? 10.1.1.1, 10.1.1.2, 10.1.1.3. They're all able to reach this thing because you've got the address, but they're using a different port. They're using different port numbers. And by using different port numbers, in each case, we're able to segregate them and separate them. So they look unique from each other. So that's what we're talking about with regards to NAT overflow. So how do you configure NAT? Well, let's show you. Very simple. With NAT, we've got something inside, something outside. Inside and outside. So what do we mean by inside versus outside? Well, let's do it. Let's configure static and dynamic NAT. Let's have some fun with it. Let's show you how kind of systems work, etc., etc., etc. And we'll show you, and it'll be fantastic. So let's go back to this device. We'll go back to our EVE ENG server. We'll pop it up. We'll configure some static and dynamic NAT. Let's close this lab. Let's create a new lab. Add a new lab. Let's call it NAT. Okay, we'll open up our NAT lab. Let's add a node. Wrong one. Let's add an object. Let's add a node. Let's add a nice little router over here. Happy, nice router. Let's turn the router on. We'll do some NAT on it. It'll be all kinds of cool. Let our devices boot. They take a few minutes. while we're waiting for this to come up, I'm going to give you some advice that I've learned the hard way. If you have a 64-core workstation with a couple of GPUs in it, and you've got an EVE NG server running on a 24-core system with about a half a terabyte of RAM, and you've got 6K video cameras and studio lighting, by the end of the day, it gets pretty hot in your office, no matter how much air conditioning you could possibly use.
You like that hot yoga though, Mike.
I do like hot yoga, so I do have a special room in my house that I heat to 130 degrees to practice yoga every day because it's good for my neuropathy pain and my reflex sympathetic dystrophy pain. But I will say this, my office that's 96 degrees all day long does at some point get a little hot. Of course, my arthritis feels better in the heat, so I guess there's both sides of it. But computers generate a lot of heat for those of you folks that have not worked in data centers. All right, come on, you slow router. She'll be up in a minute. Okay, here we go. Happy router now. So we're just gonna have a little fun with this. I'll show what we mean. We need some reggae music when we configure these things. So let's give it a host name. Let's make it clear to us. We'll call it a host name. We'll call it NAT router. We've got our NAT router. Let's do this. Let's go to interface. Int G0/0. Under here, let's put an IP address on it. Let's say 10 IP ADR. Let's say 10.1.1.255.255.255.255.252.2.0. Let's say over in here, let's do another one, int. Let's do a no shutdown. Now what we're going to do is we're going to go to another one, int G0/1. IP address, let's put another subnet, 192.168.1.1, 255.255.255.0. That's what we need. We need some reggae music in here. Haven't heard any since this morning when I was practicing yoga.
We need some reggae version of Jeopardy music. That's what.
Yeah, that would be good.
I'm sure I can find that.
See if you can find some reggae Jeopardy music for the next project. That would be really great. So let's get out of here. Now let's set up our NAT. We'll do an IP NAT inside. Now what we have to do over here, we have to tell it the source. So we're going to determine what we want to be the inside. Now remember, the inside was the first thing we did, the 10.1.1.1. So let's tell it what the source address is going to be. Let's say 10.1.1.2 will be one, and we're gonna map 10. So we're gonna map. Let's say we've got a 10.1.1.1. Make sure I got this right. We've got the 10.1.1. Let's say we're going to translate .2, and let's say we're going to translate .2 into something on the exterior 192.168.1.2. Now let's say we're going to also take a .3. .3, and let's turn that into another one, a .3. So what we've done here is we've set this device to translate 10.1.1.2 to 192.168.1.2, and then I just messed up. Okay, so let's look at our running config and make sure I don't have too many funny NAT things in here. What we should see is, okay, we've got a mapping of 10.1.1.2 to 192.168.1.2. And then over here, what you can see is we've got a mapping of 10.1.1.3 down this. Now, the only thing we haven't done yet is we actually have to tell the interfaces who's inside and who's outside. So if you'll recall, we had the interface gigabit 0/0, which has that 10 address space. And over here, we're going to tell it to be the inside of the net. That's the inside interface. Now, we did this. We actually crashed the router. We got a memory error, which, this should not happen, but everybody's got bugs. So, kind of keep this in your mouth. So, but we also have to make sure we do the interface. Remember, we also did the external interface. So show IP int brief. Make sure we get the external interface. Okay, the external interface is going to be a config T. Now, when we go over here, what we're going to have to do is interface G0/1, and then we'll do IP NAT outside. Now that's going to work. We'll do a no shutdown on this. So if I do a show IP interface brief, can anybody tell me in the chat box why these interfaces are going to be down? Can anybody tell me why these interfaces are down? Now, these two are administratively down, which means manually shut down. But can anybody tell me, this is the NAT interface, but can anybody tell me why these things are down? In the chat box, tell me why it's down. Anybody tell me in the chat box? Somebody tell me why these two interfaces are down? Ferdy, exactly. There's no cable plugged in and there's no connected switches, albino. It's not connected. So if we want one of these ports to go through, then we're going to have to plug it into something. So let's say we're going to plug in a switch, just to give you an example. I'm going to make sure everybody sees this. I want to make sure this is clear. We don't have layer 2 and layer 1 because we've got no connection. So I'm not sure how long it's going to take for the switch to fully come back. But let's just plug in a switch. Now, at some point when that switch comes up, we're going to, here we go. Interface gigabit Ethernet change state to up. So now we can see that the one interface that we plugged into a switch is up. So now you know why. It's manually there. It needed to be set. So for the people that got that right, very, very good job. Very, very good job. You're starting to get it. You're starting to feel it. If there's no cable plugged in, there's nothing going to work. Why? Because there is no network. So woohoo, you guys got it. I'm very, very, very excited every time I see these things. Because you guys are getting it, no cable. You understand the layer 1, the layer 2. You guys are doing great. So now let's get back to our content that we're talking about over here. Now we've talked about some NAT. Let's talk about quality of service. So what is quality of service? You know, when you go to the airport and you want to get on a plane and they're busy, and then you bought a first class ticket and you don't have to go in the big line, or you pay for the frequent traveler number and you don't have to wait so long, it's quality of service. When you go to the store and you're a VIP and they give you access to things, that's quality of service. So quality of service enables you to treat different traffic differently. And there is a lot of reasons why you would do it. For example, let's say you've got a network. Remember when I made that access control list with OSPF and intentionally broke it? And all of a sudden we lost the routing, we lost the control plane. So how important was that OSPF traffic to our network working? Critical. It's the control plane. Now let's say we've got a network, and in our network we've got people that are downloading music from Collie Buddz, Damian Marley, Ziggy Marley, Bob Marley, UB40, and Bobby McFerrin, which is not reggae, but the song Don't Worry, Be Happy is pretty popular in Jamaica, as well as reggae music. So now we've got all this stuff. What if Cindy the cat was listening to reggae all day long, and Cindy the cat decided to download the entire reggae library from the internet? My cat loves reggae. So well, I practice the yoga with listening to reggae, and she's in there with me in yoga, so I assume Cindy the cat loves reggae. Anyway, so the cat and I are listening to our reggae because it's important to us. But Cindy the cat wants to send a message to Noni the cat that there's a wolf around and they need to hide. So when Cindy the cat needs to send that message to Noni the cat about the big scary wolf and dog that are together as friends, if that message doesn't get to Noni from Cindy, Noni could be fighting a wolf, which is not a good situation. So that message from Noni to Cindy or Cindy to Noni that says, stay in your house, cuddle up with your owners, don't go out, there's a wolf. That's a pretty important thing. So I want you to think about this. Think about what traffic matters. So when traffic, if we've got all of our phones on voice, hey, yeah, and we can't place a phone call, we are in trouble. So we have quality of service to let us prioritize the kind of traffic that we need. Prioritize voice, prioritize video, prioritize signaling. Why? Why does this matter? Well, let's talk about some constraints that we have. We can have a constraint with bandwidth. What is bandwidth? I've got a 10 gig link. I'm sending 10 gigs of data. Guess what? The link is full. That's a problem. Now, if I can prioritize voice, if there's congestion, voice always gets through. OSPF always gets through. Cindy the cat's data always gets through. Mike's data always gets through. Everybody else's traffic gets through only if it matters, if there's capacity. That's QoS. So think about this. Think about the security impact of the QoS. I've been advising people to use QoS for 20 plus years, mostly for network security. Why? I advised a bank. It was a global bank. I said, you must put QoS on your networks. And they said, Mike, you're an idiot. We have gigabit Ethernet to the desktop. We're never going to fill up our gigabit Ethernet ports. This was 15 years ago. I said, you have voice over IP, and when you get one worm, that worm's going to replicate, and it's going to go gigabit Ethernet to every desktop, and it's going to shut down your entire phone network. The customer said, Mike, science fiction. Nobody can fill up a network that's got 14,000 gigabit Ethernet ports. I said, I promise you, one worm and you're done. 3 weeks later, customer gets hit with a worm, filled up 1 gig to every one of their 15,000 financial advisors that were using that system. All down. They come back to me and said, Mike, you got a security problem. I said, no. We told you if you don't use QoS and you get infected with a worm, your network will be down. They said, yeah, but I said, you didn't use QoS. You got infected with a worm and your network is down. I'm here to help you. Now let's set up the QoS policies we talked about in the past. And then they did it. So QoS, I like to think of as security. But let's talk about the constraints we have for data. So bandwidth is the amount of stuff you can send. Delay is the latency. So Eva Deutke is over there in Hungary. I'm over here in Florida. We decided to buy a wire between her house and my house. And that way, she can do video watching and taking care of my cat Cindy. We can talk. She can help me with a blockchain project that I'm working on. I can talk to her. Everything's good. We've got a wire between us. It takes 6 milliseconds for me to reach Eva Deutke over the wire. 1 millisecond for me to reach Chris. 6 milliseconds. That's delay. Now, if it's always 6 milliseconds to reach Eva Deutke, it's probably okay. But what if packet 1 is 6 milliseconds? Packet 2 is 3 milliseconds. Packet 4 is 50 milliseconds. That's called jitter, which is variations in latency. That's a problem, and voice and video applications don't do it. Why? Imagine sending a conversation. and one word arrives before the previous word. It's not good. So bandwidth is the amount of stuff we can shove in a pipe. Delay is how long it takes to get there. Jitter is variations in latency. And the last is packet loss. What is packet loss? You lose data. We do a ping and we lose some packets, packet loss. So just kind of keep that in your mind. So we're using QoS, or quality of service, to make sure that our important stuff gets through. By making sure our important stuff gets through, we don't lose it. So we don't have packet loss of critical things. We minimize the jitter of our critical things because we always allow the most important stuff first. So you got a platinum card. You get on the airplane first. QoS. You try to get on the airplane. They form a queue. First class goes first. People that go next goes second. That is the same thing. It's killing quality of service. Trying to see what we got over here. So what do you think is latency sensitive? Real-time traffic. What is real-time traffic? Voice and video. That stuff, highly sensitive to variations in latency. So let's talk about the kind of things that we're talking about. With voice, realistically speaking, we got to deal with about 150 milliseconds or less. Any more than that, we're going to have problems. Jitter, 30 milliseconds or less, and that's pretty bad. And packet loss of 1% or less, that's at minimum. So some video can go from as little as 384K all the way to about 20 megabits per second. Jitter again, the thing, but video again, you can't deal with more than 1% packet loss. Like 0.1 and 1% is pretty much about the same thing. Now, there's one other thing that we can actually do. On the routers, we can actually come up with a classification. We can mark our traffic. So we can have a packet come into the traffic. We can look at it and say, woohoo, pretty important. Set this packet as high priority. Now, that's really not something we're going to talk about in the Cisco Certified Network Associate a lot, but that's something called an NBAR, Network-Based Access Control Recognition. And basically, you can use that to match a packet, and you can basically configure the packet to be of higher value, et cetera, et cetera. So let's talk a little bit about queuing. Now, if you're not American, queuing is easy for you. If you're American, you have to think about it. So for the Americans there, the rest of the world calls a line a queue. So when you're in an airport in England and they say form a queue, basically means a line. Now with queuing, we're going to have a lot of ways that we can schedule our data. For example, we can, let's just draw out what a queue is to make it kind of, I'm going to draw out what a queue is. I want to show you what it is to make it clear to you. So let's say over here, let's say we've got our router. And this router has this connection to another router. Get rid of the fill out of this. Let's do this. Okay. Let's pretend this is a 1 gig link between yourself and AWS or Azure. Let's assume some of our traffic is really critical voice. And we decided to prioritize that. And we give 50% of the capacity to the link, to the voice and video. And then we say, Cindy the cat's traffic is really important. So Cindy the cat gets 25%. And then everything else that's not voice or video or Cindy the cat can get up to 25%. Now, if there's no traffic from Cindy and there's no video, the other traffic can use it. But if there's contention for traffic, voice and video goes first, Cindy goes second, and somebody else's goes third. That's queuing. Now, the kind of queuing I'm describing here is something called priority queuing, meaning prioritize 1 versus 2 versus 3. But, that's realistically speaking what we're talking about. It's just one form of queuing. So queuing is about making sure your devices can get there. So, maybe we should draw on one more thing and talk about queue scheduling. So while we're at it, let's add a queue schedule. So you can think of this because you're going to see queues in applications. Basically, you look at this as a router. We can look at this as a server because we'll see queues outside of networking, which goes to a queue like an IBM message queue or an Amazon SQS queue, whatever. I think you can use Apache Kafka for a queue. And then we've got another server. If we've got a server that wants to send messages to another server, we can stick a queue. And what can happen is the server can send all of its messages into the queue. And all these messages are going in the queue. And then ultimately what happens is the queue can be drained one at a time when the server is ready for it. This one message comes out, gets drained, goes through, out. So we can use queuing for lots of reasons to make sure we don't lose traffic. Queuing is used in the cloud. It's used with servers. It's used with databases. It's used with routers. So we're talking about something that's pretty common stuff. I just wanted everybody to understand what is queuing and why. So how do we schedule this queue? Well, I just showed you priority queuing, but we could do it a lot of ways. We could do a round robin. We could basically have 4 queues and just 25% to each one. We can basically set up percentages like I just showed you in a class-based queue. We could do priority where only you go and then you go and then you go. But we can do several different kinds of queuing things. Now, since we talked about queuing, let's talk about policing. Policing is a little different. Policing is about admission control and access. So let's look at this. Let's look at this and let's look at access. So let's draw this out so I can show you. Let's go over here. So now let's pretend you've got your, let's call this a router. Got a router 1. Router 1. Router 1 has a 10 gig connection. So let's come up with something that looks pretty thick. We've got this 10 gig connection between these devices. Now over here, I've got a big server. In fact, the server has 64 cores, got a terabyte of RAM. You know what my server has? My server has a 100 gig network card. And here's the worst part of this. This server is plugged in to this switch with a 100 gig connection. Now this one server, let's say the server is sending 30 gigs of traffic to router 1. Now router 1, when it gets 30 gigs of traffic, can it send 30 gigs to router 2? From router 1 to router 2? Can router 1 send 30 gigs per second of data over the link from router 1 to router 2 when it's only 10 gigs? No. So what I can do is I can create a policy that I can say drop. And what policing is drop greater than 1 Gbps or 10. I can create a policy, and this is called policing, that will only allow a certain amount of traffic onto the system. That's called policing. So have you ever seen when you're on a highway and the highway's congested and the police go to the exits and they don't let you on? That's admission control. What's that called? It's called policing. It's the same thing. Identical thing. That's called policing. Shaping your traffic. So if you don't let it in the router, it can't fill it out. So policing basically tells the routers to basically just see this, just drop it. Okay, so before we get into first hop router redundancy protocols, which is a topic I absolutely love, I feel like we should bring in some questions, because I feel like we're going to go into something that gets pretty complicated pretty quickly. And with that, we should be we should make sure we get some questions. So Chris, are there any more questions for me? Ferdy, I'm not completely sure what you're saying there, but yes, I'm assuming you're referring to QoS, and that's exactly. We do voice first and then data. Exactly, that would be the thing. That's why we're using these QoSs.
And no other particular questions right now, so we'll see if any come in.
If you guys have any questions, let me know. I haven't seen any, but it's hard for me to believe we're covering this much networking stuff and there's no questions. But if there's no questions, we're always happy to keep going. Reggae router, yes, absolutely. We need that. Earl, I would love a reggae router. That's something I totally love. Everything is going to be all right. Angelo, yes, QoS. Well, Angelo, the point is you're going to need both. Remember, a VLAN for voice is layer 2. And yes, we've got layer 2 things, but ultimately we're going to be on a layer 3 network. So we're going to need both QoS and VLANs for voice, Angelo, both. It's not an either or. Good question, though. And then, Chris, you can bring in the next one if there's not another one.
Not anything right now.
Okay.
Oh, here we go. Now they're starting to come in.
Yeah, Albino has a question. Bandwidth is basically the same as max throughput. QoS does not control the bandwidth. QoS determines what traffic can be sent ahead of what other traffic. If you've got a link that's got 10 gigs of bandwidth, it's always going to have 10 gigs of bandwidth. Where QoS comes into play is when you've got 100 gigs trying to shove itself out the 10 gig pipe, and you determine which 10 gigs goes versus which stuff you drop. That is a good question there, Brian. Very good question. Can I explain about dropping? I don't know what you mean about dropping, Albino. I mean, because dropping could be anything. The only thing that I think you can assume is regarding dropping frames. Like if you've got 100 gigs trying to come in and you blocked it at 10 gigs, the rest of the 90 is dropped. So kind of look at it this way. Let's assume you had a cup that can hold 300 milliliters. Once you pour 300 milliliters in the cup overflows and it all gets dropped out. That's exactly what's going on when we apply a rate limiting policy. If we say 10 gigs can get in, it's like a cup that's got 300 milliliters or 300 cc's. Once we fill up more than that, it just gets tossed and thrown on the ground. That's exactly what's happening here. Good question there. Any others? Okay. So now we're going to talk about first hop redundancy protocols. Now there's really 3 of them, and pretty much they all do the same thing. There's a Cisco proprietary one called Hot Standby Routing Protocol, which we don't use anymore because it's Cisco proprietary. Then the industry came out with something called Virtual Router Redundancy Protocol, which was specified via RFC 5998, which is a great thing, which we all use. And then Cisco came out with another version to use the same thing called Cisco Gateway Load Balancing Protocol, which is all kinds of cool, but it's Cisco proprietary. So that means we go back to Virtual Router Redundancy Protocol. And realistically speaking, what are these routing protocol things? It would be really, really great if we could track an interface. Now with routers, this stuff's easy because the routers have routing protocols, and the routers recalculate like the GPS in your car, but not necessarily this way. So let's talk about what we mean. Imagine you've got this environment, and I'm going to draw it out for you because sometimes I feel like whiteboarding these things out in real time is so much easier than trying to just talk to you and show you pre-made slides. So let's go to this environment. In this environment, let's get two routers, router 1, how that happened. Router 2, we've got these two routers. Now, we also have a switch, and everybody's in the same VLAN for right now, so we're just going to say switch. Routers are plugged into the switch. We got a bunch of servers. Server 1 or systems. All plugged into this switch. PC 1. PC 2. PC 3. Add another PC here. Let's say both of these routers, they're connected anywhere. Heck, this could be the AWS cloud, for example. It could be your internet. It could be Azure. It could be a remote WAN location. It really doesn't matter. Okay, so let's pretend all these PCs. So the PCs, does your PC run OSPF or eIGRP or BGP? No. When you want to leave your current subnet, what does your PC do? It checks its default gateway. So, realistically speaking, on this LAN segment, we can point these PCs to router 2 or to router 1. So let's think about what happens. We point all our PCs to router 2. This link goes away. Every one of our PCs is going here. Nobody's getting anywhere. Now, if we could see if the WAN link goes away, send all the traffic dynamically to router 1, wouldn't that be cool, everybody? So right now we've got two active links. Link 1, link 2, link 1, link 2. Everybody's happy. Traffic's going out 1. That link goes down. I want to know about it. I want this thing to be removed completely. And I want this to take over. So how do we do this? Well, what if we could create a virtual router and this virtual router was connected to both of these devices? So let's say this router, its actual IP address ends in a .1. And this router, a real router, has an IP address that ends in a .2. But what if I made this virtual router .3? And I told all my PCs, this virtual router, that's your default gateway. So I point all my PCs to this virtual router. Now let's say router 2 is the primary. Here's the normal flow right now. Data comes in, goes to router 3, out router 2, back to the cloud. PC 2 goes to the fake router through the cloud. This one goes to the router through the cloud. This one goes to the fake router through the cloud, fake router through the cloud, fake router through the cloud, the virtual router. Everything's good. Now, AT&T's cable gets cut. That's okay. We weren't crazy enough to use a single service provider. We used two. Router 1's on Verizon. AT&T's down. Now the PCs send their data to the virtual router. But this router is done because the link's down. So now it goes this way. Now the traffic goes this way. Now the traffic goes this way. Now the traffic goes this way. Now this link comes back. Poof, this is back up. Virtual router shuts over. And now the traffic goes this way. And it's the same thing. We're directing our traffic. Everything's hitting the virtual router. So hot standby routing protocol is this. Cisco proprietary. Virtual router redundancy protocol is this. Gateway load balancing protocol is this. What are they? There are 3 ways to do the same thing. To basically make 2 routers work together to have a virtual router so it doesn't go down. What do you think this increases? High availability. So that's what these first top protocols are. We can literally track an interface. If this interface goes away, it goes down. If this router goes away, the router dies, guess what? The other virtual router picks up the virtual address. So the point is, this is a first top redundancy protocol. Routers don't need it. Why do routers not normally need it? Hello, hello, hello. Some LSAs, some MEO LSAs, but PCs don't participate in routing protocols. So your PC has a default gateway. Have your default gateway pipe to this, and we're good. Now, what we could do if we wanted to load share, which we can do, is we could potentially, and we can do this, we could have 2 virtual router addresses. We can have a virtual router 3, and what we can also do if we wanted to get cuckoo here, we could have another virtual router, which we would put at .4. And again, both of these would be virtual routers. And what we could do is we could point half of our users at this router and half of our users at this router. Now, in either case, if this link or this router would occur, both links would be switched to the other router. But we have the ability to send half of our traffic on one link, half of our traffic on another link. And if one of the links or routers goes away, just shift. And by doing that, we're just creating 2 virtual routers. So one virtual router uses 1 link. 2 virtual routers shares 2 links. That's how we're doing load sharing across PCs in a high availability context. So when we're dealing with HSRP, or the Cisco proprietary one, we've got an active standby because HSRP only allows 1 to work. 1 active, 1 standby. Now, there is something called SNMP, or Simple Network Management Protocol. And Simple Network Management Protocol realistically is a protocol to manage devices. And this is where we start talking about network monitoring, etc. And what happens is every device has something called a management information base. And I'll explain to you briefly. So there's something called the Simple Network Management Protocol. And the way this works, you're going to have a network management station. And this is a server that basically sends requests to the devices for information. Now, every device has something called an agent on it. An agent is what serves the server. So we've got the network management station that reaches out to the agent that sits on the routers, and it asks them for information. Give me information about your CPU. Give me information about your memory. Give me information about your interfaces, etc., etc. So if we want to request information from a device, it's called an SNMP GET. We can also set devices over this Simple Network Management Protocol. And for the people that are your operations people, your SysOps people, they're very good at these kind of things. For architects like me, this is a totally different career and a totally different world where we tend not to be there. But Simple Network Management Protocol is there. People have got to manage these devices. So what happens is each device has something called a MIB, which is called the Management Information Base. And it's basically a little database or a store that has key variables that tells the manager exactly what's going on. Now, let's do this. Let's walk through the way that we would do certain things on the cloud. So how do you, let me find my EVE-ENG server, and then we'll come back to it in a minute. Bear with me. Okay. So a couple things that I wanted to show you. What we do, the way we get our operating systems to a router is typically via TFTP, etc. So what we would do is we'd tell it copy, we would tell it the TFTP, and then we give it a name or the address, let's say 1.2.3.4, and then we would tell it what we find in the TFTP server to flash. We'd give it a location, and then we'd hit enter. I don't want to do that because we don't have a TFTP server 1, 2, 3, 4. But the TFTP server is where we're going to pull our information. So we talked about a few things. We showed you how to do a few commands. We're actually at the point now where we can actually start to get into some architecture kind of stuff and explain some of these things, which I'd like to do. But before we do that, it might actually be worth, what's the word I'm actually looking for? Seeing if anybody has any questions. Does anybody have any questions, Chris, before we go to the next section and start doing some architecture work?
Yes, we've got some questions.
Hold on one second. Let me go find StreamYard. Rishab Jain. OSPF calculates the path based upon the bandwidth of each link. So with OSPF, realistically speaking, depending upon the bandwidth, just specifies the cost. Now, ever since Gigabit Ethernet came out, all the costs were one. So what you're going to have to do under OSPF is you're going to have to set something called the reference bandwidth. And by doing that, you can specify the link speed, which will specify the link cost. Meaning, if I've got a path that includes 100 gigs that's 5 routers away, the cost of that is less than a path that's 1 gig that's 1 router away. Why? Because I can send so much data. So OSPF, or Open Shortest Path First, is going to calculate the best path, which is going to be the shortest distance in terms of bandwidth or cost to reach the destination. It's not going to be router hops. It's going to be the path that gives you the most bandwidth and throughput. Good question there, Rishab Jain. Excellent question, actually. Chris, if you want to bring in the next one. When connectivity goes down, what backup is needed so voice over IP calls won't get rejected? It depends on how you do it. If you've got 2 sets of WANs, one goes down, it doesn't matter. Your voice over IP is still good. If you've got a server locally that's a call manager that syncs up with a voice over IP server in a remote location, and it goes down, again, you're good because you're survivable. So the key for any high availability is 2 things. Never, ever, ever have a single one thing, and never leverage a single provider. So whether that means if you're going to WAN, you're not going to build all your WAN on AT&T or Vodafone or Verizon. You must use 2 service providers. Must. If you're connected to the cloud, you must use 2 clouds. Same way we've always used 2 service providers. So the key is this: more than 1 servers, doing the call managers, more than 1 path, and good routing that makes sure that your connectivity never goes down. And then you won't have to worry about this. Voice over IP does best when your servers are actually in the same facility as where your users are. So if you stick your servers in your campus and your campus WAN goes down, guess what? You never have these problems. So I generally like to put my call manager servers, at least the majority of them, in the main campus. But good question. What other questions are here, Chris? Angelo, for MPLS networks, absolutely. We've got our own form of QoS, the degree of service, the fragment offset. Oh, absolutely. We've got QoS service, quality of service at layer 2, layer 3, MPLS, all of it, because it's that important. Good question there, Angelo. Margin, this isn't really a load balancer. A load balancer, figure is a server with some hardware that just goes server 1, server 2, server 3, server 4. Now, we can load balance via OSPF, via equal cost routes. We could load balance by telling, or traffic engineer by telling BGP to leak a more specific subnet over one link versus another. We could load balance with policy routing that looks at the source address and goes somewhere else. So I wouldn't call it a load balancer. I would consider a load balancer to be a device that just shares the load between routers and firewalls and servers. This to me would be a first hop redundancy protocol, but I guess it does do some form of load balancing, but no, it's not considered a load balancer. In fact, load balancers aren't even considered networking. Networking and networking people are basically routers and switches, and that's it. Good question, though, Marcia. Sarah Ahmed, what's a TFTP server for? So typically we would take copy running -config to TFTP, which would take the configurations on the router and back them up to a TFTP server. Now, when we need to update the operating system, we often use a TFTP server. Copy TFTP to flash, and that's how we pull down the operating systems. TFTP, Sarah, is also used by if you've got a cable box in your home. When your power goes out, the cable box or your satellite box reaches out to your satellite provider, pulls a configuration which determines what channels you're allowed to. TFTP is widely used for that as well. Great question there. Mike I, where do you use a spine and leaf architecture? I've not used one in 25 years, and every spine and leaf architecture I've ever seen, I picked it up, ripped it out, and replaced it with a core distribution and access layer. So I don't use spine and leaf architectures ever. What is the spine and leaf architecture? Where basically you've got your core routers and everything plugs directly into those, which means you've got no scalability, my guy, which means that if you've got a problem in one of those switches or a bunch of servers keep rebooting themselves, they can take down your entire network. So where do you use a spine and leaf architecture? For a mom and pop shop that's got 5 routers and switches and never anywhere else again. So you don't use core, big, strong routers. And the function of the core is high performance. Then you've got a distribution layer, which feeds in the access layer into the core. And if there's a problem with the access, anything, and it hits the distribution layer blocks it from hitting to the core. So when you do a spine and leaf, it's basically you put everything all in a single basket, and you've lost all your scalability, you lose all your availability, you lose all the performance. So where do you use spine and leaf? I don't. Small businesses might get away with it. The jack of all trades hobbyists would use it, but I've not used it in 25 years. Now, Mike, I have seen a lot of spine and leaf architectures that somebody just thought they could throw their switches and plug them into the core routers. I've removed about 150 spine and leaf architectures because each one of them basically had outages day in and day out because they didn't constrain it. Because what would happen in one of the leafs would just impact the core, and then you don't want that. So you really want it to be that you've got a structure. You've got the main thing that's your high performance. Kind of like the military. You've got a commander-in-chief, right? That commander-in-chief has generals that separate them from the commander-in-chief. Why? The generals are military experts. The president may or may not be. So the president's at the core, the commander-in-chief. They've got generals and admirals and people that advise them. And then those people reach out to the military community. You don't have military people speaking directly to the president, the commander-in-chief. You've got those generals there that are experts. That's why you have them there. Because a military person calls another military person, they speak the same language. Now that general can then translate it to the non-military person, and everybody knows. So same thing, decoupled architecture scale. Why do we take our websites and do a web tier, a database tier, and an application tier? So that each tier grows. Why do we do the same thing with a core distribution and access layer? Because it grows. A spine and leaf is like a one web server environment. We've got the whole LAMP stack on a server. Doesn't scale. So I haven't had a use case for a spine and leaf architecture in 25 years, and I've ripped out about 150 of them. But it's a great question there, Mike, and I'm so glad you asked it. Chris, if you want to bring in the next one. Actually, while he's at it, let's draw the two architectures out so that I want him to understand the difference and why, because it's a good question. These are my blank architecture slides that I wanted to get into. So before I do this, let me just, here's the way we design them. Core. And I'm going to show you the difference between a core distribution and access and a collapsed core. and I'll show you where the problem is. So this is your core. All right, so let's just hold this real quick. Let me copy this. We need to do, hold on. So, okay, so this is a spine and leaf. In this particular environment, you've got these servers or computers, whichever you want to call them, are going to be plugged directly into this switch. So these are servers. These servers got it plugged in this switch. Every time one of these servers reboots or gets shut down or gets unplugged, a port goes down. And if it's on a separate subnet, that's going to send recalculations through all of this stuff. Every time a port comes up and down, this whole network's going to know about it. You put 500, 1,000 servers in a couple of switches, and you've got a nightmare. Now, by comparison, if we did it a little different, if we did a core, and off of the core, what we did, which is the way I designed it, we have a distribution layer. And this distribution layer feeds into two different switches in the core. And then the distribution layer then has the access layer plugged in. And the way it works is this. Now, if anything happens on this switch, which is the access, it's going to get filtered by the distribution layer, so the core is not going to see it. So by doing it here, anything that happens here can crush this. By doing it here, anything that happens here will most likely be blocked by here before it hits the core. So by using a three-tier architecture or a core distribution and access, we can isolate these problems here so the rest of the network doesn't see it. Now, once we go collapse core or spine and leaf like this, anything that happens here can destroy the entire network. So I strongly, strongly, strongly recommend staying away from the collapse core unless you're dealing with like a house or a mom and pop shop. Now, what happened was these routers and switches got really powerful. And people got sloppy because the routers and switches got really powerful. And here's the thing, because these routers and switches are really possible, you can get away with this idea for a period of time, but it will break. And when it breaks, you're going to have to start all over. So it's best just to design it right in the first place and not have to worry about it. So it's funny you actually got to the thing that I was going to refer to. So what does your basic LAN architecture look like? Your basic LAN architecture looks like this. Switch. Switch. And our switches, what do we have? VLANs, right? VLAN. So let's make sure we can find our text. Let's give our text another color. Okay. So we've got a switch. So now we've got this cable between the switches. And we want to carry multiple VLANs. Okay. Let's say VLAN 1, 2, 3, 4. Carry these VLANs over. We've got them on both sides. Now, both switches are in the same building, but they're separated by a single piece of fiber. So I want to get all 4 VLANs across this single wire What is that special kind of port that enables me to put VLAN 1, VLAN 2, VLAN 3, and VLAN 4 all on a single wire? What's this called? What is that special port that has multiple VLANs? What are they? In the chat box, please. Do 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 bump ba da 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 bump ba dum bump bump bump. Bingo! Trunk port. Angela, you got it. It's a trunk port that enables us to push multiple VLANs all on a single port. Fantastic. Fantastic. You did it. You got it. All kinds of happy. You did it. Good, 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 good job. So super exciting stuff. You guys got it. You put a trunk port. Good job. Oh, I'm loving it. You guys are getting it. It's trunking. So the trunk port enables you to capture multiple VLANs. So let's talk about core access distribution again. Hey, you guys are going to get it by the end of this session. Core access distribution. Let's go back and steal some of my stuff so we don't have to do it again. Now let's think about this. Let's talk about why this core access distribution is so good. So now we do this core access distribution. These are all layer 3 links. So let's make sure that we make this really survivable. Real strong. Now, if this was OSPF, does anybody have remember the name of this special area that has the most knowledge of our routing? Which is the core of OSPF as our primary interior gateway protocol. What's that area called? That's the core or the center of the network that's designed for the high performance routing that needs all those links data advertisements. What is it called in the chat box? Do 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 boop. Woohoo! Area 0. LM, Area 0, Angelo, Area 0, Anya, Area 0, and Area 0, Mike and Mark. Woohoo! You guys are getting it. So high-speed routing, critical ports, all the routing here, Area 0. So these devices are fast. Now, what do we know about all the routers in Area 0? Every network change that they see happens. Everything happens. So these have to be big routers, strong routers. The routers that walk around look like Arnold Schwarzenegger in his prime. Big, strong routers, big cables, powerful devices. Now, well, here's what we need to do. These are your biggest, baddest, most expensive high-performance routers. Now, by decoupling this, these distribution routers, they should be layer 3 devices, high-performance switches, layer 3 switches, routers. Why? Why are these layer 3? Now, do routers forward broadcasts out of their segment? No. Remember, that's why for that DHCP discover, give me an IP address. We had to have that helper address called the DHCP relay. So we're doing that. Now with layer 3, routers don't forward broadcast. Can I do an access control list on a router that says only this traffic can go in a certain direction? Yes. Can I put QoS on my router to make sure the bad traffic never gets to the core in the first place? Yes. Can't do this as much the same way with the collapsed core, but I can here. So now I can run QoS. I can run encryption on my routing. I have more packet filters, more ACLs, more everything. Now, by doing it this way, if it's a layer 3 link, I can make sure the changes that happen here aren't seen in the same way. I can hide it. I can route summarize. Now I've got a set of these little mini access switches. I can plug a couple of these little devices into this device. And you want to see how cool I can get with regards to availability? I'm going to show you. In this particular environment, it's not supposed to go this way. So let's drag all this stuff over. Now let's pretend this is a high availability environment. Say I'm dealing with stock traders. Stock trader. Let's say I've got 4 stock traders here. We're going to have a lot more. But I want you to see how cool we can get and how high availability we can do with this core access distribution layer. So we've got 4 stock traders. Here's how we do it. This is high availability, high performance systems. What I'm going to show you right now, very few people in the world will ever get to experience in their life, and very few people will get to do this. So this will make any of you that are taking this free training already better than 2/3 of the population that are working in networking for years of experience. So let's talk about this. You've got traders. What do traders do? They buy stock and trade it. They sell it. Companies make a lot of money on this. Imagine this. These 4 traders, trader A sits next to B, sits next to stock trader B. Make these boxes a little bigger. I want you to fully appreciate how high availability we can get with this. So this is going to be stock trader C. We'll show you why we love this approach. And I use this approach for everywhere. And let's say this is stock trader D. Now they're all sitting at the same desk. Stock trader A is sitting next to B. So if we send stock trader A to this switch, and then we send stock trader B to this switch, and then we send stock trader C to this switch, and then we send stock trader D to this switch. I want you to think what we did. If this switch dies, big problem, right? Stock trader A can just walk over to stock trader B's desk who's next to him and say, process my trade. Stock trader C can do the same thing for D. Now this router comes back on, and this one goes away. The traders can go next to them. So by doing it this way, this switch fails, this distribution thing is going to fix it. We don't even have to see it. It doesn't have to affect the core. This thing fails, we don't have to see it. So by decompartmentalizing, everybody can see it. We can really lock these systems down. Now, Cisco loves to teach this spine and leaf or collapsed core. I hate it. But because of this, it brings us back into this situation. So now we're here. Imagine if this is a layer 2 switch instead of a layer 3, which is typically what you see in these collapsed core. Anything that happens here will literally affect every one of these devices. Now, how's that going to scale? It can't. Even if this is a layer 3 device, this guy gets a worm. It hits this thing. Chances are this thing's not designed to be a big, strong distribution layer to protect the core. Again, it goes down. So I tend not to like this. So let's talk about what a small office is going to look like in reality. Well, here's what it's going to look like. In a small office, architecturally speaking, you're going to have something you're going to connect to. And it's either going to be AWS, Azure, Google, or a data center. It doesn't matter. It's all the same. All these clouds are nothing more than a data center that's been virtualized. That's all it is. So what is your small office, home office? That's what SOHO means. Well, you typically have a what do you call it? Got an internet connection. On your internet connection, you typically have a firewall that also does VPNs. So we can call it FW/VPN/router. Behind that, these little devices typically have, the firewall typically has a couple of switch ports on them. And maybe one of these switch ports goes to your IP phone. Maybe you've got an IP phone. And maybe over here, you've got Cindy on our computer. Cindy does all kinds of computer stuff. You have no idea. So we've got Cindy on her computer. And then Cindy's father's on his computer. So you've got Mike over here. And we got my wife over here that's doing stuff, doing some accounting and things like that. So we've got Lisa. So realistically speaking, this is the kind of thing that you would typically see in a small office or home office. Now, if the small office and home office mattered, they wouldn't just have this one internet connection. They would have a backup internet connection across a second service provider. Why can't you get two AT&T connections? Well, if the AT&T fiber gets cut, you're good. But if the AT&T network goes down, you're not so good. So let's talk about WAN architectures. Pretty much simple stuff. WAN architectures are going to be one of two kinds of things in today's world, and it's all going to be the same. You're either going to get your router over here, router. You're going to have a router on the end, and it could be one of two things. You could be buying a wire across the network. That's called a pseudo wire. You could be buying a real wire, or this could be Ethernet over MPLS. And guess what? It's immaterial to you. All you're going to get is a gigabit Ethernet connection on one side, or a 10 gig or 100 gig, and a gigabit Ethernet connection on the other side, and that's all that matters. It doesn't matter which technologies you're using. The alternative, which is what you typically see in the cloud, is the same darn thing. How does it work? This is the basis of a direct connection, which you'll see with AWS or what they have in Google or Azure. They're similar. What happens? You've got your router. Your router gets, you buy a WAN connection or gig ETH to something that's called a point of presence or a direct connection location. Inside of that, you've got your device. This is called customer edge. Now, inside of that location, you've typically got your cloud router. Call it AWS, doesn't matter. It could be Azure, it could be Google. You ask them to run a wire. It's called the cross connect between yours and theirs. And then AWS will just backhaul your connection. And guess what? If you've got any of these kind of connections to your cloud providers, all it is the same Ethernet WAN. You get a point to your location in the end, and then you just plug in the AWS switch. All of this is the same. Let's say it's Metro Ethernet. Guess what? It doesn't matter. Here you got a big tall building. Who's connecting to another building? What do you think you got under the ground? Fiber. How else does this often work, Metro Ethernet? You go to a phone switch over here, which is buried underground, or another switch which is buried under the ground. You connect to this switch. That switch connects you to another switch, which connects you to your far end building. Does this look just like that AWS direct connection or Azure direct connection or ExpressChat that I just showed you, or the direct interconnect that Google just does in the previous slide? It's identical. Connect to a switch, you connect to another switch. So what are you really seeing? This is the same stuff that we've had for the last 30 years. What's a point-to-point WAN look like? I'll show you. Got a router over here. Router over here. Router over here. We connect the link between them. This is a point-to-point WAN. How many IP addresses? Everybody, how many IP addresses do we need for this WAN? And what is the appropriate subnet mask for this WAN? For this one address here and one address here. What is the perfect subnet mask? Slash what? Slash what to give me 2 usable addresses, but a total of 4 addresses per subnet? Help me, help me, help me. What could it be? What could it be? What could it be, everybody? Well, Jim, we need more than one address because we need one for each side. Angelo, fantastic. We need 2 addresses /30. Sharon J, fantastic, /30. Sarah Ahmed, /30. Tom Arthius, /30. Woohoo! Mike, /30. Jim Weaver, /30. Brian McCool. I'm loving it. You guys got it. A /30. Let's look at the other architecture. This is called hub and spoke. If any of you have ever been to an airport, you know hub and spoke architectures. I'll show you the airplane thing. I'm going to go see Ivadoikya first. Ivadoikya is over here. I want to go visit Ivadoikya over there in Hungary. So I'm in my Palm Beach airport. I'm over here. What do? I go to PBI. This is my local airport, Palm Beach International. I go over here. I have to connect to a hub. A hub is Atlanta. I go to Atlanta. I go straight from Atlanta to Hungary. That's a hub and spoke environment. But let's show it in the network world. Let's just say that Atlanta is our hub. And we've got a site in London. Lagos. Cape Town. Dubai. New York. San Francisco. And I was listening to Ziggy Barley singing Beach in Hawaii this morning while I was doing some yoga, so we'll say Hawaii. So, and I know that's a country or a state, not a city, so where everything else is a city, so I probably should have picked a city, but I couldn't think of it, and I was thinking of Ziggy Marley's Beach in Hawaii song, which I absolutely love. So this is Hub and Spoke. Now, how does this work? Atlanta is the center of everything. London sends its route to Atlanta, which sends it to Dubai. New York sends its routes to Atlanta, to Dubai. San Francisco sends it to Atlanta. Everybody can talk to everybody through Atlanta. This is called the hub and spoke. What do we know about this? Highly, highly, highly efficient because we only need one set of connections. Now, what's the weakness? Atlanta. If Atlanta goes away, nobody can talk to anybody. So if we're going to do hub and spokes, what do we need? We need two hubs. Or if we're using a single hub, this data center needs to be real high availability. Two power companies, two sets of generators, two sets of backup generators, two sets of UPSs, air conditioners, redundant air conditioners. You see what I'm talking about? When it matters, we can't have a power failure take down our environment. So these are the kind of things that we're talking about. So these are the ways we're going to do this. Now, what if we needed better? What if we needed super rapid communication? Guess what? No big deal. We can do this. Now, mind you, we're not going to do too many because we're going to get into this math problem that's called n times n minus 1 divided by 2. And it's going to get real ugly, and I'll show you. So right over here, we've got 4 devices. So to go full mesh, everybody's connected to everybody. And in iBGP, you would be dealing with this. With VPC peering, you would be dealing with this because iBGP and VPC peering in the cloud is non-transitive unless you do something to create rules to break those rules to make them transitive. So this is full mesh. Everybody's got a connection to everybody. Now, let's think about this. This router is one hop from this router. This router is one hop from this router, one hop from this router, one hop from this router. Everybody can reach everybody in a hub. Now, this is really efficient, but look at that number of connections. I've got 6 here. Now, I want you to think about this. Hopefully, some of you guys are good at math. So here's the formula with full mesh, the number of connections. N times n minus 1 divided by 2. So imagine you have 100 routers. So let's do it. Let's do the math for 100 routers. So 100 times 99, 100 times 99 divided by 2. If I've got 100 routers, I'm going to need 4,950 connections. Ugh. So not good, huh? Hub and spoke, we need 100 connections. Fully mesh, we need 4,950. So what you can see is this grows exponentially because the formula is n times n minus 1 divided by 2. So this does not scale. So what are we really doing? Well, let's show you what practicality is. How do you really design the perfect architecture? You combine them. So let's go back to our pretty hub and spoke. So let's do this. Let's call it something different. Let's call this hybrid. So let's look at places where people really need to talk to each other and go play a lot. So we know that there's a huge connection between London and Dubai. We know there is, because we see a lot of people. We also see that people are constantly talking to each other between New York and San Francisco. And we've noticed that our folks in Lagos, Nigeria, seem to be spending a lot of time talking to our folks in Cape Town, Africa. So we draw a connection between them. And what does this do? This means if Lagos, Nigeria goes away, Lagos, Nigeria can go through South Africa and still reach us. But the two cities in Africa the two cities in Africa can reach each other across two countries as well with a relatively low latency because they're in the same place. London, Dubai get to talk to each other frequently. New York and San Francisco speak to each other frequently. So this is kind of a hybrid approach. Why? Better redundancy and better performance when we need it. So I live in Palm Beach. I can fly direct to New York because there's so many people going between New York and Palm Beach, even though New York isn't my hub. So keep that in the back of mind. Now, if we were talking about VPNs, what would that be? Well, there's lots of VPNs. So, we used to have this. This was the first cloud I worked on. And all of these were VPNs. So I just want you all to know how old the cloud is. Cloud is old. This was what I had. And this is what I grew up with. And if you people know networking, then you truly know the cloud. I'll show you why. This was the first cloud I worked with. This was called Frame Relay. And how did this work? We would get a connection to the cloud, like a T1, for example, or a 56K lease line, what have you. It didn't matter. And then on the cloud provider would create this virtual connection between us. It wasn't real. So that was the first VPN. That's called Frame Relay. Then we did ATM, which was the same thing. After this, what we did is we filled this up with BGP. We did multi-protocol BGP. And what we decided to do was keep our customers separate. And how do we keep our customers separate? With multi-protocol BGP, we came up with this concept of a virtual router. And basically, we had these virtual routing interfaces and virtual routes that we'd push through. Now, the underlying technology that made this work was MPLS, but it was no big deal. And then after this, you know what we came up with? We came up with VPLS, which is based on the Martini draft from Luca Martini over at really smart guy over at Juniper Networks. What was VPLS? Well, we decided, quite frankly, to do the following: to just basically build a wire over. We had an MPLS network, and we were submitting wire signals, and that way we could have point to multi-point architectures. Like we could have another router over here, and what we could do is we could just, literally speaking, create connections through the cloud to each other. That's not working so well. Wait, I think I got to do it that way. And that's what we were doing. We're effectively sending things, but they were all VPNs. But what does your normal VPN look like in today's world? Well, quite frankly, it looks like this. It looks like the internet, and because it's the internet, we don't know what it looks like. That's why it's a cloud. A cloud means you just can't see it. It's hidden from you. So let's say here is the internet. Now we've got the internet. Over the internet, we've got a router on one side. Guess what? We'll put a router on the other side. We send some encrypted data through the internet, and it looks just like a wire. That's a VPN. Now, maybe if you guys want, I'll build a GRE tunnel. So let's think about a few more architectures while we're at it. All right, let's say a cloud architecture. Okay, now we're dealing with the cloud. No big deal. Now, what's this look like? Okay, let's think about it. Now we've got our place. We've got our data center. We've got a router. We've got another router. Okay. How do these things work? Pretty simple, no big deal. Our two routers then connect to two different direct connection locations. You see? Actually, I should call this point of presence, but really speaking, it's just a data center that's owned by somebody, but let's call them a POP or direct connection location, whatever. Now you're in the POP, you run a wire back to the cloud. Let's say this is AWS, doesn't matter, could be Azure, who cares, all the same. Only the names have changed, like that song, Meet the New Boss. Same as the old boss, it's the same old 20 to 40-year-old data center technology, which we're using. Now you got your cloud. Layer 2 link back to your VPC. Same thing. None of it's different. It's all the same. It's just the name has changed. And if you know these technologies at the baseline, guess what? It's all simple. So when you're on the cloud, you've got what's called the VPC. Now, okay, you're on the cloud. We got our virtual private cloud. Let's have fun with it. Let's draw ourselves a VPC. So here we go. Now we're on the cloud. What are we going to do in our VPC? Okay, we've got our virtual private data center, VPC. Let's change this to black because, let's see if we can do this. Let's change this to black. Okay, now let's get rid of all this fill in here. We didn't need to do that. How do we do this? Shape fill, we want to get this to 0. Just black again. Okay, so we've got our VPC. So let's think about this. What's in a cloud? We got an internet gateway, right? What's that do? It's a router that takes us to the internet. Okay, no big deal. So the internet gateway is going to need what? A public IP address. Now, when we get past the internet gateway, we're going to have a firewall. But let's just assume we're not dealing with any firewalls and VPN concentrators. We're typically going to have what? A load balancer of some kind? Which is going to have a public IP address on it, which is going to connect ourselves to an internet gateway. Behind the load balancer, we're going to have what? Web servers? Okay, web servers. Heck, let's have another load balancer. Have some app servers. Behind that, we'll have some kind of a queue. On the way to our database, let's say queue. And I know my spelling is trying to fit in here. Now we've got a database. Now people say, how do I manage this stuff? Oh my God, how am I going to manage this? What do I need? Some kind of crazy thing called the Bastion host? Of course not. How do we manage this? And because, you know, some of the cloud providers have made up this ridiculous thing called the Bastion host, which basically teaches you how to avoid all your firewalls, your IDS, IPS systems. It's basically like hanging a sign on your door that says, please hack me. So now let's look at what this is like. We've got our data center over here, DC. Now we've got our virtual router at the cloud provider. And whether this is a direct connection or a VPN tunnel, guess what? We've got full connectivity directly to the cloud through this connection. And we can manage our load balancers, our servers, all this stuff directly through this. So why am I talking about this cloud thing? I want you to see the cloud, which is the future, the network, which is the past and present. It's the same thing. It's all the same thing. So why can't people get hired as cloud architects? They don't know the network and the data center, which means they don't know the cloud. They just know the name of the service and how to configure it. So, these things are really easy. So let's talk a little bit about server virtualization, because all of you guys working in networking somewhere along the line are going to be working on the cloud. So what is server virtualization? Quite frankly, it is the basis of all cloud computing. Quite frankly, server virtualization is 50-year-old technology from IBM that was used to virtualize mainframes. That's how old it is. Cisco came out with the VLAN or virtual LAN, which was virtualization 30 plus years ago. Then Cisco came out with the concept of a private VLAN, which is a VLAN where people inside the VLAN couldn't talk to each other. Wait, in 2021, don't they call that a container, where you've got multiply isolated things on the same operating system? So now it's all the same 30, 40-year-old tech now that you know what it is and where it comes from. So what is server virtualization? Quite frankly, it's a VLAN equivalent of a server. So what is a virtual LAN? Well, a virtual LAN is when you take a switch, like my happy switch that I keep next to my desk, and you take some of the ports and you chop it into multiple logical switches. So what is server virtualization? Take a server, chop it up into logical servers. Now, how do we do that? Well, I'm not the best graphics artist here, but I drew this for you. So here's what we do. We take our server, we smack something called a hypervisor on it, something like VMware ESXi or KVM on Linux or QEMU, and we create a virtual machine. It's got our own operating system and applications. Now, that EVE NG server that I'm using, each one of those little routers is its own virtual machine. So I've got a server sitting there with a VMware ESXi hypervisor that's then doing nested hypervirtualization with KVM and Linux hypervisors. And I've created this. That's how my server is running. But when you go to the cloud and you get a virtual machine on the cloud, this is it. And it's the same thing if it's in your data center as VMware ESXi. It's the same thing with Amazon's creative naming of Elastic Compute Cloud. It's the same thing with Google's creative naming of Compute Engine Instance. And Azure calls it a virtual machine. But guess what? It's the same technology. So while we're at it and talking architectural concepts, this is a type 1 hypervisor. This is what all server virtualization is. But maybe you decided you had a Windows notebook and somebody decided you wanted to learn Linux and you don't want to make Linux your primary operating system. You decided to make Linux run on a virtual machine. So desktop hypervirtualization, your notebook. You're running a Mac and you need to do something in Windows. You've got your physical operating system, and then you've got your host op, and then you've got your hypervisor, and then your things, which is why if you've ever made a virtual machine on one of your Macs, it doesn't work that well. Why? Because it's type 2 hypervisors. Server virtualization, awesome. Non-server virtualization, not so awesome. So our type 2 hypervisors, not so great. So while we're at it, let's talk about what a container is, because it's another form of a virtualization. Private VLAN, Cisco 2000. Containers, Kubernetes, 2010 approximately. Same thing. Physical hardware, operating system, container engine. Now you got your containers. Now look, your container is just your application and libraries. It's not a whole operating system. So this is fast and light and efficient. What time is it? So what is a private cloud? Take a data center, install. Okay, we'll build a private cloud real fast. Got our normal data center. What does our normal data center have? Let's build it up real fast. Bear with me a second. So we've got this. In our data center, we've got this. Let's replace this with server. They're all servers. We've got thousands of servers plugging into our switches. You can see we're planning our servers to these switches. Our servers are connected to the system. Now in this environment, all these servers, if we install a cloud cert on them, like OpenStack or Nutanix, and these clouds are fantastic, OpenStack or Nutanix, what are we now doing? We're now enabling these servers to all be virtualized. And now when I create a virtual machine, we enable the virtual machine created in any of these pools of servers. I need a load balancer. It becomes a virtual device that's literally running on one of these servers. It's the same thing as the data center was before, except instead of having physical machines, or now VMware ESXi virtual machines, we've got virtual machines on our cloud, which is Nutanix or OpenStack. Same thing. Oh, wait. Now I went to AWS. Okay. Now I got the same data center as before. It's the same thing. But now AWS changed the name of these servers to EC2. Oh, wait. I went to Google. Now it's called Compute Engine. It's the same. All of it's identical. It's the same 30, 40-year-old data center technology. Why is this interesting? Why? Because it's a new name of the same thing. So if you strip off all these stupid names, Elastic Compute Cloud, Compute Engine, and you know it's a virtual machine, you now know that when you're in the data center, AWS, Azure, Google, Ivadoiki's home, or Jazz's home running a VMware ESXi server, you can build your same clouds, and it's all the same. So now you know. Nothing fancy, nothing spooky here. It's all just the same old school technology. So while we're at it, let's talk about a few kinds of definitions. I hate these terms. I think they are horrible. But in case you see them on exam, I don't recommend using these terms with customers. They will laugh at you. But the cloud providers have made up these terms. They all use them. And as a network engineer, systems admin, network architect, cloud engineer, cloud architect, solution architect, you got to know them. So we're going to talk about these terms. Infrastructure as a service. Infrastructure service basically means you're using virtualized infrastructure in the cloud. So virtual machine in the data center, virtual machine in the cloud, that's called infrastructure as a service. It is the most common form of cloud computing. It is the most appropriate, and it gives you the most flexibility. The next type of service on the cloud is something called software as a service. And as software as a service is the cloud-based provider basically gives you software. And wherever it's at, you don't know much of anything where it's at. It could be on virtual machines. You don't know. The underlying technology is hidden from you. So basically, it's your code. Or it's basically just somebody's software. It's all licensed and paid. Now, with this software as a service, do you think you have any control over it? No. No. Do you think you can do layer 2 access lists? No. Do you think you can do any packet filtering? No. Do you think you've got any next generation firewalls that you can do? No. Do you think you have any control over anything with the software as a service? No. So what is software as a service good for? Speed and flexibility and agility. I use software as a service. I use the content management service from software as a service. And when AWS goes down, they go down too. Because they're on AWS in 2 regions, in 2 availability zones. When AWS goes down, because they're only using a single cloud, my systems go down too. Because it's software as a service. And every problem that they have, I have. Big business, infrastructure as a service. I'm making my own. Software as a service, I'm placing my bet and trust in somebody else. Now let's talk about platform of a service. Platform as a service is a development platform that's based out of pre-built service. So basically you're getting a virtual machine, a container, but you have no control over it. Realistically speaking, when you start just rolling out your code on those kind of things, that's there. Single point of failure. You can't control your security. And if you start redesigning your applications to work on platform as a service and the cloud provider kicks you out like they have, you are dead. You're done. So platform as a service, very agile. But cloud provider raises your rates. You can't do anything about it. You are handcuffed. You are now a prisoner. So the best architectures probably involve all 3. Infrastructure as a service, it's your same data center. Platform as a service, basically, it's just pre-made for you. Give them your code and just hope it works. Hope everything's perfect. Can you control the firewalls? No. Can you control the QoS? No. Can you control the capacity? No. None of it. You lose it all. But organizations like it because it's simple. But, you lose all control with these elements too. So kind of keep that in the back of your mind. Okay. All right. So I think we've talked about a lot of concepts. Let's open it up for some questions. Tomorrow we can do some lab stuff. We covered a lot of content. So let's see who has what kind of questions for me. And let me know. And then pop in the questions if you have any.
So we don't have any questions just yet. As soon as they come in, I'll make sure to put them on the screen.
Okay, so ask some questions. And then tomorrow what we'll do is we'll have a nice fun lab where I'll put some pieces together. Maybe if you want to even do a little bit of BGP. But please feel free to ask your questions. I want to make sure that we take good care of everyone. I want everybody to have a very good learning experience because I want everybody to have the best career possible. Marjan, thank you so much. Super appreciative. If it does, I love virtualization too. Roger Daltrey, yeah, some good music there from The Who. Meet the new boss. Marjan, thank you. And yes, thank you, Chris, but also Eva Doikia, Jazz, or anybody else that's got a Blue Wrench, we're super grateful. Sharon J, actually, the vendors make up their names well, I think it's for two reasons. So when I used to practice medicine, these pharma reps would come in and they'd have these cool names, Lipitor or Ally. What would happen was companies make up these names because it's really hard to sound like you invented the really exciting elastic compute cloud when IBM invented it in the 1970s. So I think it's, how do you take something old and make it feel new and charge 10 times more than it used to cost? You make up some names and it makes you sound cool. So the vendors, if you notice, the cloud vendors have been using some funny things. A cloud provider, for example, talked about having an outage which took down half of the country because they had a power outage in the data center. Now, I don't know how you have a power outage in the data center because you typically have two power companies, two sets of generators, backup generators, UPSs. So I don't know. But we're hearing these cloud providers often make up terms to try and make the old 30, 40, 50-year-old thing sound so new and exciting. And I love these cloud providers. Their services are great. The problem is we get all these people, they're certified, and all they've learned is the name of the service and how to configure it. They don't know how any of it works. They're unemployable, and it's all based on these name vendors making complicated names. So, in medicine, let's say I've got a drug, an ACE inhibitor and a beta blocker, two drugs that are off patent, that are 40 years old, that are each $2 each for me to prescribe. We then have a drug company that puts the two of those drugs together, and they get a patent, and they call it a new drug. Now, that new drug is $800 a month. And insurance is paying for it because they just changed the name. And it's now a proprietary patented combination when it's two $2 drugs, now $800. So it's that. It's very hard to charge a lot of money for an old technology, but it's a lot easier to charge a lot for something that sounds cool, that's exciting. And Angela, well, I hate to give you the answer. It depends. It depends on the size of the routers. It depends on what you need. If you need to use, for example, if you're running MPLS, you're going to have to essentially use this poorly architected single area network because you're looking for certain information and different types of LSAs to carry the information. If you're dealing with more enterprisey functions, the key is to have your core in area 0 and to create areas, whether they be not so stubby areas or stub areas or totally stubby areas, so you can limit your LSAs. That's that kind of thing is a CCIE scaling strategy kind of thing, like they barely covered in the CCIE program. I didn't learn that until I passed my CCIE and had a couple of years of work. Maybe one day we'll do an 8-hour webinar on scaling OSPF because I think it would be kind of fun. But it would take a full 8 hours to do it. But that doesn't mean we won't do it someday. Chris, you want to bring in the next one? In OSPF, you cannot create a second area 0. You must have only a single area 0. If you were to buy another company that had another area 0, because the rules say that you have an OSPF area 0s, you'd have to create some kind of a virtual link to connect them. But you would never, ever, ever desire to create a second area 0, only one. When are we doing a DevOps course? Rahul Sharma, I am an architect, and DevOps is about automating software release cycles. So I don't plan on doing a DevOps course anytime soon because I train cloud architects, and that's what I do, and they're system designers. And I train people for one career, and maybe networking as well, but not DevOps. It's a totally different career. So I don't plan on doing anything in DevOps. Nike, thank you so much for the clarity. Nike, I'm always happy to do so. Sharon, love it. I can appreciate that so much. Thank you so much. Thank you, Mike. I appreciate those tips for the new song. Marjan, it's good to see you. Love the smiley face, by the way. What about using Packet Tracer for the lab? It appears simpler. Anya, if you've got Packet Tracer, go use it. It's a great product. But I like EVE ENG because I can test Cisco stuff, Palo Alto firewalls, Fortinet firewalls. I can run my IDS, IPS systems. I can generate it and connect it to my cloud. And so, Anya, I use the paid version of EVE ENG just because it's so robust. But Packet Tracer is great. It's fantastic. You could also go to eBay and buy a CCNA rack for $200, use it, and then resell it on eBay when you're done. That would be fine too. But I like EVE ENG because lots of organizations, including big ones, use it to test different things. And I've got students and I've got a school, so people are constantly looking to do new stuff, and I want to make sure that I can make my students do anything they want to use to learn. Williams. Williams, no, we don't give away our internal slides. There's something, we give a lot away for free, but we don't give away our intellectual property. Angela, OSPF doesn't really have anything to do with latency. OSPF has to do with finding the path. There's really no latency component into it until you're dealing with MPLS, and that's very specialized. And again, it's giving you latency information, but it's not using it to drop packets. Chris, you can go to the next one. Abigail Marks, I'm so happy to see you here. CCNA. Danica, okay, all of you. You can type hashtag CCNA in the meantime. Mike, you should be the stunt double for Christopher Maloney on Law and Order. I'll have to see that show to see what you mean. I honestly don't have a lot of time to watch TV. I wish I did. Thank you so much, Ivadoikya. I'm super grateful for Chris and everything he does, as well as Leo, but also all of you guys out there. I'm so thrilled that you're here. And Ivadoikya and one of those amazing blue wrenches. Thank you so much for all your help with everything you do. You do so much to make us, this family, this Go Cloud Careers family, and all the students so happy. I'm so grateful to you, Ivadoikya. Maybe.
Sorry about that. I just gotta. As soon as I saw that, I was like, "Yeah, he could."
I like that.
Yeah. Oh, that's pretty funny.
It really is.
Yep. Oh.
Appreciate that, Sharon. Ava Dyke, thank you so much. I don't even know how to say thank you to you. Angelo, you're so welcome for this session. And we're so happy to spend some time sharing things. Frank, CCNA, fantastic. Mohammed, so thankful you're here. Marjan, so thankful you're here. Nick B, thank you. Mike, Chris, and the Blue Wrenches. Yes, thank you, Blue Wrenches. So appreciative of all of you. If you can type CCNA. Sarah Ahmed, thanks, Danica. I love that. Single point of knowledge. Thank you so much. We try so. And by the way, Chris keeps everything organized and working. I can't thank Chris enough. And he is the point of organization. Alexander, CCNA, Efharisto, Yasu. Sarah, so good to see you. Nike, CCNA. Finney, so good to see you. LM, CCNA. Ivadaikya, we love having you here. Tom Artheus, thank you so much. And yes, Chris is doing fantastic.
Yeah, I got to think quick on my feet with Mike. That's
Yeah.
The good thing is that when I saw that comment, I realized I bet Mike probably doesn't know who he is. So I already started looking it up before.
Yeah, Chris really knows me. So I love to watch TV. I just never have a lot of time for it. So, my idea of TV is when I get to see my wife for about an hour and a half at night, and it's me and our little cat, and we all watch TV together, whatever it is, I'm just happy to spend the time with her.
I like this one. So Christopher Maloney plays a detective. So you're the networking detective.
Yeah, I'll work with that. You know what? For a little while, I ran around with the sniffer, and I had a manager that called me Sniffer Boy. Networking detective would have been so much better than Sniffer Boy. I like that. I literally ran around with the sniffer, plugging into span ports on switches, trying to find out what kind of traffic existed. It was hilarious in those days. Nikhil, good seeing you. Sharon, good seeing you. Thank you so much, Seven Seers Beamer. I've always been wound a little too tight. Let's put it that way. Sarah Ahmed. Sarah, with that name, shukran. Ben Christopher, Cloud Hired CCNA. Robert Welch, good seeing you. CCNA, Nivadoikia, good seeing you. CCNA. Sharon, thank you so much and Brian, thank you as well. Thank you, Mr. Businessman. Williams, I'm so happy to see you. Mr. Gee, I'm thrilled to see you. And I love that name. I don't know if you're a jiu-jitsu guy or you like to cook with ghee. Angelo, haha, that's good to see you. Carlito Way, I love the movie and I love seeing you here. CCNA. And Network Pro, I'm so happy to see you here again. One day we should talk. I really like having you here. Leo Paredes, thank you so much. Leo is exceptional. Leo was one of my best students, and I had no choice but to hire him. He's now a senior manager of operations, making sure that I do what I can and helping Chris, and we are grateful to have you here, Leo. So in any case, I hope everyone had a wonderful day. Tomorrow, we're going to make it a special day to have some fun to end this on a high note. I promise a special lab or BGP or one of those two things, which you guys tell me, whichever you want. Actually, tell me, which do you want tomorrow? BGP or a big lab day? Tell me in the chat box, and I'll make it exactly what you want it to be.
I was going to say, why don't we do both? We can do a BGP session next week or the week after.
Okay. Would you like that? Would you like to?
Oh, there's a lot of BGPs.
Okay, so let's do the BGP tomorrow.
Yeah. Oh, I got one lab. Two labs. It's no comparison to the BGP, though.
So why don't we do
this? Here's a good balance. It sounds like BGP and a little lab.
If we have time to do both, we can. I think I can definitely do a BGP one. Or I could do a lab, and then we could do a BGP one again when I get back from my vacation. If you guys want both, tell me both. Otherwise, we'll do BGP tomorrow.
And they have been for 4 or 5, maybe longer, 6 years. They've been helping us promote it.
You see, I don't think we can do both in the same day, and here's the problem. It's going to take us about 3 hours to explain BGP, and it's going to take us 3 to 5 hours to do a BGP lab, which I'm happy to do with you guys.
So 7 Series Beamer makes a good point here. We've got some BGP content out there. I think it's a good opportunity to get more lab content and lab in front of people.
Okay, so why don't we do this? Why don't we do some BGP lab tomorrow, and I'll teach BGP about with everything we're doing along the way.
And we'll always do more.
Yeah, so that's why.
And I'll come back and do more too. So we'll do a BGP hands-on day tomorrow, and then guess what? I'm going to do the BGP instruction, and then we'll configure. Then I'll instruct, then we'll configure, and then you know what? We'll make sure that we give you guys a big BGP day after we know that you've done the BGP configuration. So instead of this, maybe we'll do a semi-instructional and lab day tomorrow, and then after that, we'll do a 4 or 5 hour BGP thing, or maybe we'll just do an 8-hour session one day. My team and I will look back and see if we can figure it out, and we can do a full day of heavy BGP and call it like a CCIE lab day. So that's potentially in the works of something we could potentially do at some point in the future as well. But let's do BGP instruction with lab tomorrow, because that's what everybody wants. And then we'll go back and have a heavier BGP day in the future, and or a CCIE job day just for fun. So that's what we can do. So super excited about all these things. So let's work off this. Tomorrow, we're going to be doing lots of cool stuff with BGP and labs. It'll be educational in every way, and then we'll bring it back and we'll have another BGP day. So everybody, let's have some fun. Type hashtag CCNA. Type actually hashtag CCNA and Cloud Architect. I want to see it both, because I want to know we're all having a good time, fun. We'll be doing lots of BGP tomorrow, I can tell you that. So, starting to see all these cloud architects and CCNA, this kind of stuff makes me happy. It means you're all awake, alert, oriented. So have a wonderful night. If you haven't done so, please hit the like button, comment, subscribe. Please tell others about our channel if you have not. We want to work really hard to do the community. That's why we're making sure that we have these courses out there so everyone can get a cloud architect job, a network engineer job, a solution architect job, and network administrator job, and network architect job. All of you, I want you to have the best careers. That's why I do all this. That's why I'm here with you. That's why Chris is here. That's why Leo's here. And that's why my wonderful Blue Wrench students are here helping you, because we want you all to have the best cloud architect, network engineer, network administrator. Let's face it, I just want you having a great tech career. I want you to make your vacation your vocation, and I don't want you to ever work a day in your life, and I want you to get paid well to build your best career. So I'll see you all tomorrow. Have a wonderful night. Welcome, everyone, and welcome back. This is Michael Gibbs, and I'm the founder and CEO of Go Cloud Architects and Go Cloud Careers. And we're here for day 8 of our free Cisco Certified Network Associate Bootcamp. This bootcamp is a free CCNA-200-301 course. We'll cover Cisco Network Essentials, and this is network administrator training, network engineer training, and really networking for cloud computing training as well. So if you're a cloud architect like me, this is critical cloud architect skills, this is critical cloud architect training, and this is cloud network training, in addition to being Cisco CCNA networking training, because guess what? Networking is the foundation of the cloud. Networking is the foundation for all communications that we do. So in this cloud network training or Cisco CCNA course or CCNA course for beginners, we covered everything from what is a computer network all the way to actually building and configuring routers and switches. So please enjoy this intro to networking course, because networking and cloud computing, they're just perfect together. So let's go over a few things today. We are going to have some fun. Yesterday, I asked if you guys wanted a BGP day or a big heavy-duty lab day, and you guys said 50-50. So we have a lot of BGP content out there, so we're going to do the following. We're going to have a big day where we go over BGP, and we do some BGP configuration and some traffic engineering. We'll be setting up a website for that. As soon as that website's available, and it may already be available, we'll have that for you to sign up, and we'll make sure you have a great cloud network architect, network engineer day. And we'll go way past the CCNA. We'll go into the CCNP and to some degree even some CCIE fundamentals when we do our fun BGP day. So that should be out soon. The link will be available very soon. And as soon as that link is available, we'll be sending it out to you so you can build your best cloud architect career, network architect career, et cetera, et cetera. So I want you to go out there and build your best career. So also, I wanted to let you know that if you have any desire for cloud computing, we have a completely free AWS Certified Solution Architect Professional book. The link for that is in the description below. It covers everything from intro, what is the cloud, to all the way through the AWS Certified Solution Architect Professional exam. Great certification to have, and that's why we produced that book completely free for you. And also, if you're interested in AWS training, we have a completely free AWS Certified Solution Architect Associate course. The link is in the description below, and a completely free AWS Advanced Networking course. The link is in the description below, although that's way more basic than anything we cover this week. So go out there and build your best career. bear with me. Apparently, I forgot to shut off or mute my phone. This is what happens when you get a few thousand phone calls per day. Let me take care of that right now. So let's go back to the fun and the networking training. So today we're going to go back. We're going to start configuring things. We're going to work with some OSPF, maybe some EIGRP, maybe some BGP. So to get started, let me know if you're here. And you can let me know if you're here and you're awake and alert and oriented and ready to get started by typing hashtag CCNA. And if I see that hashtag CCNA, I know you're going to be ready and we will start having fun. So let's look for that hashtag over there, and we'll take it from there. CCNA, I know you're going to be ready. Okay, so let me see some hashtag CCNAs in the chat box. After I see some hashtag CCNAs, guess what? We're going to start having lots and lots and lots of fun. So let's go out there. Marjan, yes, day 8. It's been day 8, but it's been a whole lot of fun. Nikhil, CCNA, good to see you. Eva Doikia, hi, Mike and everyone. Jim Weaver, hi, Mike and everyone. Frank Metal Jr., Angela, Tom Orthius, CCNA, yes. Anya, CCNA. Nike, CCNA. Brian, CCNA. I'm loving this, MJ, CCNA. And Ransom, yes, CCNA. And Dan, CCNA as well. Sadie, CCNA. I'm happy you guys are here. Elvis, CCNA, fantastic. So these are the guys. Abigail Marks, cat hired. Yes, definitely cat hired. Ravi, good to see you. Yes, my cat is definitely getting a job one day soon. Cindy's going to have her own LinkedIn page and her own business cards because she's definitely getting their cat hired. I want to let you know that at the end of this class today, we're going to introduce you to 3 very, very special individuals. We're going to bring them on screen toward the end, approximately around 2:30. These are people that helped me put this course together. These are 3 amazing cloud architects that also have a good networking background, and I can't wait to introduce you to them. There's some very special people. One of them you're going to see that's going to be doing a weekly show with me starting next year. One of them has one of these fantastic blue wrenches that you've got to work with and hear from all week. And another is someone that I'm very proud of as well. So they're going to be coming on around 2:30 so you can meet these fine people. And I'll give you a secret. Well, I'll hold those names till the end because they're very, very special people, and I want you all to meet them because they did work so hard to make sure that you guys all had the best training experience. So today, when we do this, we're going to try and piece together the parts of a network. So maybe we'll look at some IP addressing. We'll look at a couple routing protocols. We'll just have some fun. So let's do it. So let me just get everything set up here on my EVE-NG server. So we're here. I'll be there pretty quickly. Properties, make sure we get the right one of these windows. CCNA, okay, should be this one. Okay, good to go. So let's bring this, let's move some of this stuff all over the place because I've got stuff coming in every different direction. Okay, so let's do this. Let's close this lab. Let's build something real. Let's add a new lab. Let's call it CCNA Fun Day. That's what we're going to do. We're going to make it a CCNA Fun Day today. Actually, everybody, while I'm waiting to set this up, type hashtag CCNA and then Fun Day right after that without the hashtag. That'll keep me busy while I'm doodling my routers. Let's add some routers. Let's say we add about 8 of them over here. We're going to have some fun with this. Maybe what we'll do is we'll build a little LAN over here. So the core of a network, let's say we do 3 of these so we don't have to configure too many things. Let's connect them. We'll have some fun over here. Let's move this up. Now let's connect this device to, let's connect this device to this device. Give us a nice core looking network over here. And then while we're at it, let's connect this device to this device. Now, what do you think, everyone? Do you think we should connect to some external entities that are not our own entities and maybe have a little bit of fun? Like internet service provider or a cloud provider, maybe? Would that be fun, everyone? CCNA Fun Day where we go out there and we connect to external entities like a cloud provider or an internet service provider. I think that'd be kind of fun. So let's do it. Let's connect to an internet service. Let's connect to an internet service provider. One internet service provider, that's not enough. Let's connect to 2 internet service provider days so we can have some fun over here. Now we'll connect to 2 ISPs. Got 2 ISPs out here on the internet. So now we're getting into some fun. Now what do we have over here? We've got an organization. Let's say it's its data center. And let's say this is the organization's data center. Let's see if we can draw a box around this somehow. I'm not Mr. Let's not try to go there. Let's not try to turn me into a person that actually understands software. Cloud architect, network architect, that's my world. So let's do this. And then let's then say, heck, while we're at it, let's add a node. Let's add a switch to connect us to a cloud provider. We'll have a switch. We're going to build the direct connection between the switch and the switch provider. And then over here, we'll have a cloud provider over here. And maybe while we're at it, maybe we'll connect to a second cloud provider. Because this is pretty standard normal networking. Let's add another switch. Let's bring this switch between our organization and the cloud provider. We'll draw a connection over here. And then we'll draw a connection over here. Okay, so now if you really look at it, what we can really have when we think about things is we've got a core of a network, we've got 2 internet connections, and we've got 2 cloud providers. What does this look like, everyone? Where do you think you might see something like this? And a high availability hybrid cloud situation where you've got your own internet connections going to the internet. You connect to AWS and Azure, for example. Modern day networking. This is what every network engineer does. I love when I hear the DevOps people say, hey, network engineering is going away. No. How can network engineering go away? You can't have a cloud without a network. So you can't have anything without a network. So when we see these kind of things, our whole point is, just go out there and enjoy yourself, have a great time, and you'll be there and you'll love it. So go out there and have some fun with it. So let's do it. So what do we think we need to do if we're building a network? And bear with me, I'm having a hard time seeing if you guys are here, so I'm just making an adjustment on what do you think we need to figure out first? What is the absolute most critical thing we need to figure out first before we even think about our routing? What do we have to think about here? If we get this one thing wrong, this one very fundamental thing wrong, everything is going to fall apart. So on the first day, I went over some stuff, or maybe the second day, and I said, this is really critical. And we did some math together, and we did some planning together. All right, in that section, what is the most critical thing that we can plan out to make this work? Sarah Ahmed, fantastic, the subnets. Angelo, fantastic, the subnets. Our IP addressing plan is the most critical thing out there. The most critical thing out there. So we're going to have to make sure that we use a good CIDR range for each remote location. So that's what we're going to do. We're going to subnet it down, and we're going to basically use this one CIDR block for one cloud provider, one CIDR block for another cloud provider. We're going to be using different CIDR blocks for everything so we can route summarize and do some cool route aggregation and have a party. And then we'll be connected to the internet. We'll create some loopbacks, and wow, we're going to have some fun. So we're going to get the addressing scheme straightened out. So let's now think about how do we optimize these addresses to make them fun. Let's have a party with this. So in our optimization to make things fun, let's say that in our organization, we use the 10.0. 10.0/16. And maybe we make this one 10.1, 10.0. Let's say we do 10.0.0.0/16 for this. Then we do a 10.1.0.0/16 for this router over here, or this cloud, and we'll do a 10.2.0.0/16. So let's set these routers up. Let's start them all up. Because they take a while to boot. Let's boot them all up and let's have some fun. System's coming up. Great chance for our Jeopardy music, but there's no Jeopardy questions, so I guess we don't do Jeopardy music. So here we go. Our systems will boot. Okay, let's watch this one. Let's watch this one come up first. So the first thing we're going to be doing today is we're going to make sure that we've got full IP connectivity between all our 3 core routers, because this is going to be the most important. If we don't have any connections, we've got nothing. So IP addressing, subnetting, fun. Let's see systems come up. We'll configure them side by side. And I will intentionally and occasionally make mistakes. And when I do so, I'm going to ask you all, what did I break? Maybe I'll make an ACL that's too tight. Maybe I'll use the wrong subnet. Maybe I'll put something into BGP and the next hop won't be available. But no matter what, it's going to be party time and we're going to have our fun. So let's do it. Wait for these systems to come up. They're a little bit slow, which is why I haven't been going to cuckoo, pressing the no on these configuration things. No, we're going to configure it manually. No, we don't believe in automatic anything because we know automatic doesn't work. While we're at it, let's go to this thing so that we can get to it when it's ready, and we can move this out of the way for right now. At least we know our systems are coming up online. So let's go to over here. So we're going to use the 10.0.0.1/16. Now, with all these things, we're going to use some wacky loopback addresses. And the reason we're going to use some wacky loopback addresses is we need something intelligent to actually inject in the situation. So let's play a little bit. So let's use the first of the 10.0 subnets for our WANs. So we'll do a config T over here. Let's give it a host name. Host name, we're going to call it R1, because otherwise we're going to get confused. After we do this, we'll type an enable password. We're going to make it Cisco so we don't forget. It was on my CCIE exam, which is why it's the most common password on the internet. No big deal. Now, after we do our enable password Cisco, we can now, so let's make sure we can log into this thing. Line VTY 0, sounds good. 0 /4. We'll do no login. We'll do password Cisco. We'll do transput input all. Now let's go over here. We're going to use the first. Now let's create a loopback int L00. That's how we're going to remember these. We're going to give everybody an address that's really simple to remember. 1.1.1.1, 255.255.255.255. No shutdown. Now, how will me guys figure out this first subnet of subnets that I could use? So if I'm going to use, and obviously we'd plan this out theoretically, but right now, let's say if we use the 10.0.0.0 subnet, we just has to use that one, and we subnetted it now. And how many IP addresses do we need for each side, each link? How many IP addresses on a WAN? And what should that slash thing be? How many addresses do I need on both sides of the wire? If I have a user here and a user here, and they're both sides of a wire, how many IP addresses do I need for one here and one here? Margin, yes, we need 2 addresses and hence a /30. So let's go to look at this interface. It's going to connect router 1 over to router 2, and it's G0/0. So interface G0/0. Let's pop an IP address on it. Let's have some fun. IP ADDR, right? 10.0.0.1. 255.255.255.252. No shutdown on this. When we get to the other side, guess what? It's going to come up. So let's have a little bit of fun over here. Let's make sure that we have config T. Let's go to the router OSPF, we'll call it 1. Let's pop in a network 1.1.1.1, 0.0.0.0. Let's pop that in the backbone. I showed you what happens when we're not using the backbone before. Let's also put the 10.0.0.0, 0.0.0.3 network in over here. And while we're at it, let's see. If we have a link from over here to over here, it has to be on a different subnet. Now, what kind of subnet could we use that would be on a different subnet? So we use 10.0.0. That's the first subnet. We have .1 and .2 on the other side, and .3 is the broadcast. So what do we think is going to be the subnet that you need to use between G0/1 and G00? Let's go configure one. Config T. Let's go to interface G0/1. One of you really smart people that are out here, tell me exactly what I need. What's the next subnet begin with? The one that's seen by the router, and then we go up one, and then we got 2 addresses. So what's my next /30 going to look like? What's my next /30? Let's see. We should have a 10.0.0. What? Oh, we've got 0, 1, and 2. 3 becomes the broadcast. So what is the next subnet? And then what becomes the next usable address? So do 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 bump 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 bump. Sadie, good. The next subnet begins with .4. And Alex, exactly. The next usable IP address is .5. Woohoo! You guys got it. So we will do .5. And then we'll do a 255.255.255.252. Good job, everybody. Let's turn on this interface. And now we should probably pop that into OSPF. Pop in a network statement so it can participate. And we're going to do 10.0.0.4, 0.0.0.3, area 0. So we're going to, now we got some routing and we got some routing up and running on this, and life's good. We'll store this by writing memory or copy running -config, startup -config if you've got an exam. But if you want to know what the pros do, we just type WR. But we all got to pass our certification exams, right? So when you take certification exams, sometimes you have to unlearn a lot of the things that you know. And that's just one of these situations here. Enable. So this is router 2, right? So let's name it that way. Config T, host name, R2. Put an enable password on it, because if not, we won't be able to reach it. Password, Cisco. Nice, easy password. Let's create a loopback address, interface loopback 0, IP, ADDR, 2.2.2.2, 255.255.255.255. It's a /32, so it's a host subnet. No shutdown. Now let's go to interface G0/0. I don't know why my autocorrect keeps adding as O. So now if this was .1 over here, this has to be .2, right? Turn this interface up. No, we've got another interface that needs to be on a different subnet. So we've already used the 10.0.0 subnet, which goes 0, 1, 2, 3. We then used the 10.0.0.4 subnet, for which case we have a .5 and a .6. Now .7 becomes the next broadcast. So what's the next subnet I'm going to use? Do 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 bum 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 bum. Well, Sadie, the subnet starts at 8, and the first usable address is .9 because we have 0 network, 1 and 2 usable, 3 broadcast, 4 network, 5 and 6 usable, 7 broadcast, 8's the next network, 9 and 10 are the next usable addresses. So now that we're on this new interface, let's go figure out this is interface G0/1, right? Now let's put that on a new subnet. IP address 190.10.0.0.9 255.255.255.252. No shot. Now let's put these interfaces let's put these interfaces into OSPF. So let's do this. Let's go to router OSPF1. Let's pop in the network for the what do you call it? The loopback. We're going to pop that in area 0. Wait till you see we're going to have some fun once we build our basic network. And then after this, we're going to do this. Let's just do 10.0.0.0. Just 255, so it's going to get a little easier with the next one I pop in. Show IP interfaces brief. Let's make sure they're all up. Okay, they're all up. So, woohoo! We just saw OSPF load. Adjacency change, which means we should be able to reach the loopback from 2. We should be able to ping 1.1.1.1 if it's good. Yep. And over here, if this is good and we've got our routing up, we should be able to ping 2.2.2.2. Woohoo! So things are working great, everybody. So now let's go to this router 3. Now, this is where we're going to get our core working. So first we'll configure this. Let's put a host name on it. Let's call it R3. Easy going, easy peasy, R3. Now, what do we do? Let's make sure we can have a password on it, an enable password, which is like a root password. So, of course, we're going to use Cisco because easy, it's fun. We're talking about Cisco, but you wouldn't use it on a real router because it's the most common password on the internet, or at least it used to be, because on our CCIA exams, they had make us use a password Cisco. Now, let's make sure we can reach, we would normally set it up for just SSH, but let's just do line VTY04. Going to make it really easy to log in. Password Cisco. Then we're going to do that transport, input, all. Now, once we get the basic routing here, this is where the fun starts. So we're going to get there. So make sure we have lots of fun with this. And we're going to troubleshoot, for example. I might pop some BGP routes, but the next hop may not be reachable, which means you may not see it in the table. So we will have fun with it. So just keep that in the back of your mind. Now, router 3. This one connects on G0 to 0 here. So interface, let's pop the loopback in first so we can identify it. We'll pop an IP address. I'm not real original, so we'll do a 3.3.3.3, 255.255.255.255. We'll do a no shutdown, even though it's usually in there. And now let's go to interface G0/0. And when we go over here, we've got G0/1. So if we do a show IP interfaces brief on this one because we forgot, and if you're like me, you've got no short-term memory whatsoever, we know that the other side of this is .1. So 0, 1, 2. Ding, 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 ding. I'm going to pop 2 here. So, and now granted, you obviously would hopefully have planned this out much better than that, but we've got a small amount of time. So we're going to go to int G0/0. Let's put an IP address on it. We're going to do 10.0.0.2, 255.255.255.255. 252. That would have been a problem. We would have, let's do a no shutdown on this one. Now remember, we also have a link to this router over here. So let's go to interface G0/1 on this interface. G0/1. G0/1 is connecting to .9. 8, which is the 0. 9 and 10 are usable. 11 is the broadcast. Next one starts at noon. Okay, guess what? Here's what we're going to do here. We're going to make this .10. IP A to DR 10.0.0.10 255.255.255.252. No shutdown. Now let's add some things to OSPF, router OSPF 1. Let's do a network statement for the loopback 3.3.3.3 0.0.0.0 area 0. So another one for the 10 subnets. You can use a bigger wildcard to speed stuff along. Let's write this to memory. Let's write this to memory. And if we did everything right, we should see 2 OSPF neighbor adjacency changes. So if we did it right, so let's see, are we going to get it? Are we going to get our neighbor adjacency changes? Is it coming? Is it coming? Is it coming? OSPF adjacency change. Okay, we got 1. We should get 2. So let's go to this router 3. Show IP OSPF neighbors. There should be more than 1. There's only 2. Why? Let's do a show IP. Told you I was going to make some mistakes today. Let's see what we got over here. Okay, this link is up. This link is up. And this link is up. So why do we have only 1 neighbor and not 2 neighbors? Let's go over here. Show IP interface brief. These are all up too. Can we ping on the opposite side? Ping 10.0.0.10. We can. Show IP OSPF neighbors. Now 2's got 2 of them. Let's see if how many 1 has. Oh, 2 has 1. So why isn't 2 forming an adjacency with 3? Now let's go over here, show IP OSPF neighbor. And again, it's just forming a relationship with 2. So router 1 is not forming a neighbor adjacency with router 3. So let's go look at this router and see maybe what we can misconfigure. What did we do? Show IP. Let's just look at the running configuration because we missed something here. Get to OSPF 1. We have the 10 network in there. We have the 1.1.0 network. So we've got both. So why isn't it there? Connect the wrong link. Let's ping across the link. This isn't good. So let's go to router 3 and see if we're on the wrong subnet or something like that. Let's go look at router 3. Router 3, oh wow. Yeah, this isn't good. What's not good about this? On router 3, we've got the, look at this. What are you guys seeing? What are you guys seeing? On router 3, is this on the right subnet? It's not. It needs to be a .6. Good job, Tosin. Good job. It needs to be a .6. So let's go here. Fix it. See, when you see these things, can we ping across the link now? Woohoo! OSPF neighbor adjacency change. So show IP OSPF neighbor. So normally speaking, you're going to type this up in Notepad or Vim or Nano, and then you're going to just cut and paste it in. But we can't cut and paste in our simulated environment. So as you should see, we should be on router 3, and we should be able to reach everything. Look at this. So we've learned the loopback via OSPF, so I'm sure we can reach it. Ping 1.1.1.1. We should be able to reach 2.2.2.2, 2.2.2.2. Okay, so guess what? We're now connected to everybody. Now, let's do some internet service provider stuff, huh? We're going to use some private IP addresses for the internet service provider, but we're going to have an internet service provider party. That's the next thing that we're going to do. So let's go over here. We're just going to start with router 1 and router 2. We're going to minimize these things. We'll get to it in a minute. Okay, so let's give this guy this router. You won't be able to see the screen. Okay, we'll give this router a minute to come up. We're going to have some fun over here. Now, because this is going to be an internet service provider router, we're going to use some public IP addresses here just to make it work. Let's configure the host name. Host name int ISPA. So this is going to be our internet service provider A. Now, of course, we'll put a password on it. Put a loopback address on this. And our loopback addresses are going to be fun. We're going to be putting a bunch of loopbacks. IP, ADDR. What we're going to do is 11.11.11.11. Let's create another loopback. Now let's create another loopback. You'll see why we're going to do this. We're going to need a fair number of these ports. We're going to want some routes. So let's make another loopback. Let's pop in an IP address on it. Okay, so now on this WAN link, we can still use our same 10.x whatever we want. So actually, let's pick a public subnet for this link because it really should be. So let's put on this router, let's say interface G0/0. Where does this work? There's O over here. Over here, let's say IP ADDR, and let's just do a 49.0.0.1 255.255.255.252. Shut down on this one. And then what we'll do is go to router 1 over here. We're going to make sure we can ping across the link. And when we do so, let's make sure we do this. Let's go to router 1. Let's go to interface T0/2 IP address. It's got to be on the opposite side of that link. So let's do a 49.0.0.2 255.255.255.252. No shutdown. Now, I want you to see this. You should know this, what's going to happen, but I want you to see it anyway. So, now this is the ISP's router, and if we do a show IP root on this, what do you see? You see this link, and you see all the loopbacks, and they all say connected. Now, can you ping the opposite side of this link? Because we have to make sure the link works. We're going to lose one no matter what from ARP, and then we're good to go. Okay, so now that we've done that on this ISP, if we go to this router, show IP interface brief, what do we not see? We can ping across the link. Let's make sure we can. Ping 49.0.0.2. .1 at the far end. We can ping it. But do we have a route for anything else? We have our OSPF routes. Do we know about 12.12.12.12 in there? No. Can we ping 12.12.12? Can't, can we? So why is it that we can't reach any routes or don't know of any routes on here? Can anybody tell me why we don't know about any of the routes in the internet service provider? And why I can't ping it? Tell me why, tell me why, tell me why. Tell me why. So if I did this, if I went into router 1 and said, config T, IP root, let's pick up one of these subnets, 12.12.12.12.12, an exact match. And I'm on router 1. So what would I have to do on router 1 to tell it to get there? What would I have to do on router 1? I would have to give it a route. What would be the next top IP address over here? What's that link on that side? What's that IP address? 49.0.0.1? Oh, whoops, sorry about that. It's got to be an exact match. Now, if I go over here and if I do a show IP route after I manually put it here, well, I got a static route to it. Now, does this router know how to get back? No, it doesn't. So let's give this one a default route that points back. Config T, IP root, 0.0.0.0, 0.0.0.0. And what's the next hop on the other end of the side? 49.0.0.2, 49.0.0.2. Will it work now? I'm going to go over here and ping 12.12.12.12. I can. Can this guy ping anything at once? Ping 3.3.3.3. I'm not. Why can't it reach 3.3.3.3? From this internet facing router. It has a default route to me, but does 3.3.3.3 know how to reach that? No, it doesn't. But if you're an ISPA, you can probably ping 1.1.1, because what happens is from here, this guy knows how to reach here, and this person knows how to reach here. But as you can see, this route over here, router 3 doesn't know about it. Now, if I did this, and I'm going to do it, and then I'm going to remove it for you. If I went to router 1 and config T, router OSPF 1, redistribute static, and I say subnets, metric, now do you think this router might be able to do it again? The LSA may not have made it there yet. CF over here, if it has the root back. Okay. See why router 3 can now reach it now? We may actually have to tell this the route over here. This router knows how to go to here, and we need to give it more routing. But I didn't want to do too much on the static routing side because I wanted to make it more fun and dynamic for you. Okay, everyone, real quick. On February 23rd, we're going to do that big BGP day where we're going to talk about BGP, how it works, design it. Then we're going to do a massive BGP lab like you guys have recommended. So sign up for it. The link is already in the chat box. Chris from my team popped it there. It'll be a fun, big networking day. I promise you that. So let's get rid of these static routes for right now because I don't want to cause any kind of complexities. Control A at the beginning of this, no redistribute static subnets. Now while we're at it, let's make sure we get rid of the static routes as well. They're going to come back to bite us if we're not careful. Get rid of that. Config T, no. We'll pop this over here, and then we'll get rid of that route on the other end too. Make sure we're over here. So let's do a show run. I think I put a default route on here. Let's get rid of it. Oh, that explains why it didn't reach back. I didn't put a default route in here. Okay, well, I thought I did. That's the wrong one. Now, is there a routing protocol out there that's used to connect to external entities like an internet service provider? What would that be called? An exterior gateway protocol that's used to connect to an external provider. Do 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 do. Bum 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 bum. Okay, everybody, what is that routing protocol that we use to connect to external entities, the ones that people almost never understand for no reason? What is that routing protocol, everybody? What is that routing protocol that's designed to use it for the internet? Tosin, exactly, it's BGP. So let's run BGP. Let's turn it on. We need to use BGP. Exactly, Leo, Reginald, Kagina. We must use Tosin. Fantastic. Myerson, exactly. We need to use eBGP, ransom, exactly, to connect to external entities. iBGP internally, eBGP externally. So let's do it. Let's have a little bit of fun. Let's make sure we do these things. So we also need to make sure somewhere along the line that we have this route in the routing table of this link. Otherwise, we're going to find ourselves in a lot of trouble. So we're going to go to router 1 over here. Now let's look at all the links we have on this interface. So we're going to do a show IP route. Now, if you notice, we've got this 49 thing here. It is not in OSPF. Now, we're going to put it in OSPF because they're not running on OSPF on the other side. Normally, what we do is we make what's called the passive interface, which tells it not to form an adjacency. But for right now, we're just going to do a router OSPF1. We're going to do a network. We're going to do the 49.0.0.0.0.0.0.3. And we can call it any area we want, but let's just call it area 0. Let's just call it area 1. It doesn't matter. Yeah, let's call it area 0. Keep life overly simplified. Now, on this router, we have to start telling the internet service provider about certain routes. So what routes do we want to tell the internet service provider about? Well, we can figure that out thereafter. I just want to show you how we're going to set this up. So now we're going to go on this internet-facing router. And on this internet-facing router, we have to be in an autonomous system. So we're going to do router, BGP, and we have to pick an autonomous system. Right now, I'm going to make it simple. 1, 2, 3, 4, 5. Pretty easy, right? What we're going to do is we're going to form a neighbor. We have to form a neighbor relationship. So we're going to tell it who is our neighbor. And the neighbor is going to be 49.0.0.2. And we're going to give it a remote. It has to connect to the remote autonomous system number, which we're given by your internet service things. So realistically speaking, we're going to tell it which remote AS. On this router, what are we going to do? Let's do this. EXIT. Let's do router BGP. Make sure we do it at the same time. 5, 6, 7, 8, 9. Now we'll do a neighbor statement over here. It'll be 49.0.0.2. Remote. It's going to be a .1. And the remote AS is going to be the other guy's side, or girl's side, whichever you want to call it. 1, 2, 3, 4, 5. Now when we do this, we should form an adjacency. Now we won't be getting anything until we do any, what do you call it? 5, 6, 7, 8, 9. Now at this point we should show IP BGP. Okay, you see it. Okay, so what you see is the neighbors up. Show IP BGP neighbors. Now what does this mean? It means we've established the TCP session between both sides of it, TCP port 179. It also means the following. It means we've established our neighbor relationship. So let's look at it this way, 49.0.0.2. So now let's start using BGP to populate some information on the ISP side. So show IP interface brief. So let's say I want to generate the loopback address. I'm going to show you how I do it. I'm going to go to config T. Let me just make sure that we are in the right. This should be 1, 2, 3, 4, 5. So let's just make sure. Show run. I want to make sure we're router BGP 1, 2, 3, 4, 5. Okay, so let's go back to this. Make sure we got it right. Now let's advertise some routes. Let's say a 1.1.1.1. We can't do this. Let's say what was the first one we used? 11.11.11.11. Okay. Okay, so what we're going to do is we're going to let these routes start to propagate over. Note, you can see it. Now, OSPF, what do we see here? We see a metric of 100, administrative distance of 110. And we also see over here that we've got this. Now, let's pretend I wanted to send an aggregate route. So let's do it. Let's do one. Actually, an aggregate address. Let's do it. Let's create a summary route for this. 11.0.0.0, and then let's give it a /16-bit mask just to show you how we can do it. Now, when we go look in this routing table, what are we going to see? Now, right now, we don't see it yet. We see 11.11.11. Do we get it yet? Don't have it yet. We'll get it. But while we're waiting for that kind of stuff, let's start adding the other ones. You can see we're starting to see a lot more subnets coming through now. We got it all through BGP. But does this ISP router over here know about anyone? Take your vote. Does the OSPF router know how to reach 2.2.2.2, 3.3.3.3, or any of these subnets, like 192.168 or 10. anything? Does it know? Does it know? Does it know? Well, let's see. Let's look at the routing table. Oh, doesn't know anything. Nothing. Nothing. So why not? Did BGP just give me the control to tell people which routes they could see and not see by what I advertised to them? And still, I don't know anything about them. Isn't that cool, everybody? I know nothing about them. So if I wanted to, I would have to start telling router 1 in BGP. So let's go to show running. Let's go over here. Let's do a show run. What kind of stuff is on here? Okay, so in OSPF, we are 5, 6, 7, 8, 9. Now that we see this, let's do a show IP route. We can't advertise a route that we don't have. So, for example, we could do a config T. We can do go to router. BGP, was it 5, 6, 7, 8, 9? 5, 6, 7, 8, 9? What do you think we have over here? Wait, we got them. Now, are we able to reach them? You may or may not. This is going to be interesting. Oops. They can. Now, look at this. Can the internet ping every single subnet that you have, though? Can it ping 10.0.0.5? Oh, it can't. Huh. It can't. Now, what else can it ping? You think it can reach the 2.2.2? How about the 3.3.3? Okay, so we advertise the routes into BGP on one side. We advertise the routes into BGP on the other side. This internet service provider has no ability to reach any of our WAN links. Why not? Why can the internet service provider reach this loopback, this loopback, and this loopback, but not, whoops, but hold on, but not any of these links in between them? They can't reach any of these links. Now, why might that be? Why might that be? Why can't we reach any of these links? Because we didn't advertise them into BGP. What did we do? We took routes from the internet, carried them back, didn't re-advertise them out. So that's how you can see we can provide reachability to what we want versus what we don't want. But let's have it. You're not going to just connect to a single service provider. That'd be insanity. You're going to connect to two. So we've already done our ISPA links. What do you think we should do next? ISPB links. So before we do this, before we do any route advertisements, if you're having fun, type hashtag CCNA and hashtag BGP. So I know you're here, you're awake, alert, and oriented. Because that way I'm not just, talking to myself in the back of the mirror. I want to know that everybody's doing great. So let me know. Keep all this stuff good. You've been doing great. Okay, I'm starting to see CCNA, BGP. Yeah, my two favorite things, BGP, cloud architecture. But I like helping people pass these kind of exams because these are the kind of certifications that are going to help you get on your way to being cloud hired. So super happy to see you guys here. Now, let's go create another internet service provider. No, we know we don't do any of these silly initial configuration, automatic, anything. We care. We know we're serious here. So let's do this. Now, mind you, the way we connected just to an internet service provider is exactly the same way we connect to a cloud provider. It's the same thing. It's all the same. We don't need to make anything complicated. So let's configure our new internet service provider. New one. So we got a new internet service provider. Let's do this. We're going to configure the terminal, right? Let's give it a name so we don't lose it. Host name. ISPB. There you go. Enabled password, right? Cisco. If we don't want people to be able to read the password, we type service password encryption, right? We did that yesterday. Now it's not readable. So, okay. So let's have a little bit of fun with this one. So let's create some loopback addresses. Int L00. We've got 20. Let's give it a better IP address. ADDR 20.20.20.20. 20.20.20.20. This one, create a couple of loopbacks. Create another one. This is much easier when you can actually cut and paste into a Word or Notepad or Vim or Nano or whatever terminal program you're using. Okay, this is all kinds of fun. Let's create another one. Back 3. Okay, let's make sure we pop in. We want to have some routes in our routing table. And then maybe we'll do some iBGP too. Although we're heading dangerously close to CCIE land on these labs, but you guys are having fun. Many of you guys are students from the Cloud Architect Career Development Program, and we know you guys are the best cloud network architects in the world. And for the rest of you, I'm super happy to have you. So let's give you some bonus materials anyway. Make sure you guys build the best careers. Okay, so let's make sure we pop these interfaces on it. Show IP interface brief. Okay, we got some loopbacks on here. Now let's go configure something over here. Config T. Let's use this G0/0, G0/0. IP. We used what? What was the last? We used 49 last time, so let's use another public subnet. Let's use 50.0.0.1, 255.255.255.252. Do a no shutdown on this one. Let's make this a router BGP. Actually, no. I'm not gonna. I'm just gonna set up the BGP, but not configure any routes. Router BGP 09876. Okay, we'll do a neighbor. What's this character on the opposite end of the line going to be? 50.0.0.2 remote AS, and that's what did we pick on this router? Oh wait, we're going to be on ours. So our remote AS is, I think I picked 5, 6, 7, 8, 9 for us, but I just want to be careful. Yeah, right. Oh. Hold on, I typed something funny here. Let's see what I typed in here, which doesn't make sense. Ah, this is .1. The other side's .2. Okay, so if you'll recall, this router over here was AS56789. And this router over here is 56789. So why is router 1, and which is part of our internal organization, and this router both in the same autonomous system? Why does our internet router connecting to Verizon and our internet router connecting to AWS, why are our two routers both in the same autonomous system? Anybody tell me that? Can somebody tell me why? No, Margin. Why we're using two internet service providers is redundancy. But why is it that we're using the same autonomous number inside of our organization? Okay, so maybe if you don't know what an autonomous system is something that's under your control. So if we are an organization, we have one autonomous system for our organization. So if we've got 10 routers that connect to 10 different internet service providers on our network, it's going to be our autonomous system. But each network themselves is going to have their own autonomous system number. If it's our network connecting to iNetwork, it's called internal BGP. If it's an external network connecting to an external network, it's called external BGP. So now you know. Now, this isn't a load balancer thing. This is a BGP thing. So, keep that in the back of your mind. Now, why, Elvis, did I make so many loopback addresses? I needed to put routes in here. And how else can I put routes on a router? I can either learn them from somebody else or I can have interfaces on the router. I can't advertise a route that I don't own. So since we're doing this, so let's break this down real quick. Let me try to show you what this looks like. Bear with me for a second. Let's go over to here. Let me bear with me. I'll create a slide to kind of show this for you in real time. And this is the danger of doing, complicated stuff in the fly like this. So this is the way an organization this is the way internet works. You got a router, you got a router, you got a router. Now, all these little devices that are inside of an organization's control are called their own autonomous system. So this is the internet. You got, so let's make sure we get rid of this. You got, bear with me. Okay, so this is an internal internet service provider. When this internet service provider connects to another internet service provider, or another internet service provider, or a cloud provider, it doesn't matter. Each one of these guys is considered their own autonomous system number. So this may be autonomous system 1, 2, 3, 4, 5. This will be autonomous system number 4, 5, 6, 7, 8. This will be autonomous system number 4, 5, 6, 7, 8, 9. It doesn't matter. But the point being is every one of these routers inside of an entity that's speaking BGP will be using its own autonomous system number. And when it connects to others, so if I have a link, and if this link goes to this, if I've got a link going from here to here, this will always be autonomous system number 1, 2, 3, 4, 5. But this ISP will still be 4, 5, 6, 7. And then if I want to connect this router over from here to here, this autonomous system will always be 1, 2, 3, 4, 5. Where over here, this will still always be 5, 6, 7, 8, 9. So as you can see, that's just the way these things work. They just work that way. And they're always going to be that way. So now when we go back to this environment over here, where we were right before, back into our lab, when you've got this, these two routers these three routers are part of our organization. So if we're going to run BGP to them, what are we going to have? The same autonomous system number. So that's all I wanted you to see. So let's go back to router 1 so we can remember that our autonomous system number is as follows. 5, 6, 7, 8, 9. That's our autonomous system number. We can't forget it. So now let's go to this let's go to this router. See what we've got over here. So let's look real carefully. On iOS v2. Let's open up this router over here so we can look exactly what we did here. So we don't forget our autonomousness of the show, IP interface brief. Well, we've got this new thing, 50.0.0.1. Is that up and running on this one? On router 2, show IP interface brief. Okay, it is not there. So do we need it there? We do. So if ISPA is using gigabit Ethernet 00, on this far end, we can see we're gigabit Ethernet 0/2. So config T. We configure these things, config T. Then which link do we use? Interface G0/0. So interface G0/2. Now we got to put that IP address in there. IP ADDR. What is it? What is it? What is it? It's 50.0.0.2. And the mask has got to be on the same subnet. See, it didn't like that. It doesn't even let you make a mistake. That's looking kind of cool, huh? So now we've got that. Now we need to make sure the interface is up. So now we should be able to go to, I think it should be router BGP 56789. We can verify. Okay, so which router is this? We don't have any BGP on this router yet. Huh, no BGP on this router yet. So let's do this. Let's configure the terminal, configure it. And what do we need to do over here? Router, BGP, and we know our autonomous system number is 56789. Six, 7, 8, 9. That's our autonomous system number. We verified that it's 56789. So now we've got a neighbor, right? What's the opposite address? 50.0.0.1. What's the remote autonomous system number? This one? If you don't know, we can find it from the show IPBGP. Let's look through it. Okay, what's this autonomous system number? 967899876. Get that wrong, we're in trouble. Let's see if we form a neighbor relationship. Did we make sure the link is up? Neighbor's up. Now, do we think we're going to have any routes from either neighbor on either side? We're not. We're going to have our OSPF stuff. No BGP routes. Why? We have nothing that we put into BGP. So let's do this. Let's go to ISPB, and that's why we created all these loopback addresses, right? How do we do it? So we could see what we have. So now let's go to config T. Let's do this on router 2 so we don't get ourselves in trouble. Let's enter that interface into OSPF, network, router, OSPF 1. Okay, so let's go on ISPB. Let's add some routes. Now let's see, we've got, let's pop in a network statement. Apologies, we can always cut and paste a little wrong. 21, 21, 21, 21. Let's do 22. 22. Bear with me a second. Now what you're going to see is going to be something interesting. And then we're going to create some iBGP. And then we're going to add some fun to this. Okay, so great question. The network statement just tells me which routes to tell BGP to tell the world about or advertise. So if we go to router 2, do we see these routes now? Okay, we now see about the 20. We see about the 21. I don't see the 22 yet. Did we misconfigure it or did it just not get over there yet? Okay, 22 is over there yet. Now, if we go to router 1, so router 2, let's go look at router 1. I want you to see this. So on router 1, we have a show IP route. When we do this, look at the routes we got from this guy's internet service provider. 11.11, 12.12, 13.13, 14.14. Now, look at router 2. Router 2, which is this one over here, has learned information via this from BGP and information about other stuff via BGP. Router 2 doesn't know about all these routes that router 1 told this one. So ISP1 told router 1 about some routes. And ISP2 also told router 2 about some routes. Why doesn't ISP1 know about, why doesn't router 1 know about the routes from ISP2? Why doesn't ISP2 know about the routes from ISP1? Why do they not know about each other? Am I missing something between my router that connects to AT&T and my router that connects to the Verizon? Am I possibly missing something? And if so, what do I need to do to get the information from router 1 to router 2 and router 2 to router 1? Well, we do have to do iBGP, which is non-transient, or which is not transitive routing margin. But do we have any BGP between router 1 and router 2? Did we make any iBGP between router 1 and router 2? And if we did not put any BGP between router 1 and router 2, how can router 2 know about router 1's routes? They can't. Not one bit. So let's do this. First thing we're going to do is we're going to get our routing perfect to make sure that everybody can reach everybody. And then maybe we'll add some iBGP and we'll have some fun. Let's make sure we advertise the same routes on router 2 that we did on router 1. And since I can't necessarily remember them, let's just run. We'll copy the same. Oops. I didn't mean to do this here. Well, that wasn't going to work. So anyway, let's just do this. Now, the reason we can advertise these routes out is they exist inside of our routing table. If they did not, we would not be able to advertise these routes out. So let's make sure from this router, we can reach all those addresses. Make sure, because we got to make sure we can reach it before we do anything else. Okay, reachability is good. eBGP is working with both internet service providers. Everybody can reach everybody. Let's just make sure over here we can reach all the routers in the ISP route. We can ping 20.20.20.20. Yeah, we can. So we should be able to do them all because we popped them all in there. So we've got good routing. Now, right now, I want you to all understand this. If this is Verizon's routes over here on the left, and this is AT&T's routes, as it stands right now, we're not taking in any of the routes from AT&T and sending them to anywhere else. And we're not taking in any of the routes from Verizon or from AT&T over here, and we're not sending it out to anybody else. But let's, for argument's sake, let's just set up some iBGP connections and watch what happens. Now, when we do this, I'm not going to set any community. I'm not going to tag any routes for no export or do anything special. We're just going to set up iBGP between these. So show IP BGP neighbors. When we do this, we're going to see who our neighbor is. We can see we've got a neighbor in this remote autonomous system. We can see the router's ID, which is typically the highest loopback address. And we can see the kind of neighbors we have, and now we're going over here. So we're in good shape. So now that we have this, show run, we're going to make sure that we show IP int. So what we know is, let's go to router 1, show IP. Okay, so now we know this. Now, what is the link between router 1 and router 2? It's GE0/0. Now, typically speaking with BGP peering sessions, what we do is we use loopback to loopback, because that way these addresses don't go down. But so let's do this. So show run. Here, config T, neighbor, router, BGP 56789. At a neighbor. Now, what's the, if we don't use the loopback, just to make life simple today, if we use G0/0, what's the IP address over here? It's going to be 10.0.0.2. So we'll do a neighbor 10.0.0.2. Now, when we do this, we have to change the remote AS. What is the remote AS? It's our same one, because it's iBGP. It's our same one. Now let's go over to this router. Router BGP 56789. Why is it the same internet autonomous system number? Why? Because it's the same device. So it's going to be in the same entity. 10.0.0.1. Remote AS. And it's going to be 56789. Let's see if we form an neighbor adjacency. Of course, we could have potentially typed in the wrong IP address. I didn't see a neighbor adjacency come up. Okay, BGP neighbor came up. Okay, so now we did. So let's look at our routing table. Show IP route. Oh, whoa. Something happened here. We didn't have this before. Now we're router 1, and look at what we got here. We've got a route learned over here via eBGP, a route learned here via eBGP. Oh, wait, we got a route over here learned via iBGP. And what can we know? The administrative distance changed from 20 eBGP, which is super believable, to iBGP over here. So because of that, that's what we're kind of dealing with. We can see but the point is we should be able to reach anybody. Ping 20.20.20.20. Oh, they don't have a route back. That's another story. We probably need to set up, but there's not a route back, which we have to put back in there. But the point is, you can see we've got the routes through this. And we very definitely need to provide routes back to all of these places. So we do a show IP BGP on here. Now, this is really important for you to look at. When you do a show IP BGP, here's what you're going to see. The first thing is the next hop. If the next hop is not reachable, meaning this over here, this next hop, the route won't be placed in the routing table. So can you ping 50.0.0.1? If not, it won't be in the routing table. That's a problem. It's a problem when your next hop is not reachable. And if your next hop is not reachable, you won't be able to reach it. So I wanted you to see that. So how would we make the next hop reachable? What would we need to do to make that next hop reachable? Well, first, where is the 50.50.50? It's not on this device. So where is the 50.50.50? Is it on this device? So let's go show run. Is 50.50.50 reachable everywhere? Is it in the routing table? Should be. You can see over here, we learned it via iBGP. Next hop means the same router. Reachable is good to go. Can we reach 50.50.50 now? If not, we have to pop it into the IGP. Oops, where's my... What just happened? Oh, didn't pop it in there yet. Not reachable. Okay, so .2 is reachable from .1. So which one is .2's over here? That was our issue. City, Mike, why is the mask .252 on R2? You mean on a WAN interface? Or do we have it somewhere else funny that you're asking me? The WAN interface is going to be a /30. And the reason the WAN interface will be a /30 is there's only 2 hosts. So that's correct. Not really sure what the question is that you guys are asking. So let's do this. Before we do any more, let's take some questions, because we've covered a lot of stuff, did lots of BGP. We've done some OSPF so far. And anytime we do BGP, of course, there's usually going to be some configuration troubleshooting, which is totally fine and fun along the way. But let's see if there's any questions. Chris, let me go find StreamYard real fast, and then see if we bring in some questions. I've been babbling away over here, having fun typing on stuff, doing some network engineering things, which I don't get to do every day. So let's see if anybody's got some questions. Who has questions? Why is the mask /252 on R2? When we have a WAN link where we only have a total of 2 potential addresses to use, we always use a /30 or a .252 on a subnet mask, because that gives us 0 for the network. 1 and 2 is usable addresses, and then 3 is the broadcast. And then the next network starts at 4, and then goes 5 and 6, and then the 7 is the broadcast. And then the next 8 one starts at 8, unless there's something else that I missed in the process. But great question there, Sadie. Excellent question. Who else has a question? What is the network statement? Okay, so that is a really good question, Martian. So when we go to OSPF and we add a network statement, we're telling OSPF any interfaces which fall within a subnet range, they're the ones that you actually use. Now in BGP, when we do a network statement, that network statement takes something else. That network statement in BGP is which networks we're choosing to advertise to the rest of the world. So the network statement inside of EIGRP, IGRP, RIP, OSPF, etc., those network statements do the following. They tell those interfaces to participate in routing. But what we're doing here is something a little different. The network statement that we're using here in BGP is saying, tell the world about these subnets that you actually have. Great question there, Marjan. Sarah Ahmed, what does the term autonomous system mean? Sarah, autonomous system means something. It means that an entity that's under a single organization's control. So, GoCloud Careers is an autonomous system. And if Cindy the cat were to start her own company, let's say Cindy the cat, and she's pretty smart. She's an escape artist, a computer technology professional. If Cindy the cat decides to start selling cat calendars, and she steals one of my cameras, and she finds her friend Noni, Abigail's cat, and they start taking cat photos of each other and make cat calendars, etc. And when they've started a business that gets so big that they need to connect to 2 different service providers. What will happen is they'll apply for an autonomous system number, and that will enable them to identify themselves when they connect to multiple internet service providers. Great question. Great question. Autonomous system means under a single person's control. So Verizon has its own autonomous system. Every business would have theirs that needs to connect to more than one ISP. If you just connect to the ISP and they give you a default route, you're not running BGP, so you don't have to worry about it. We're using their autonomous system. But when we have our own and we use BGP, we must have an autonomous system. When we connect to the same autonomous system, that's iBGP. When we connect to dissimilar systems, that's eBGP. Great question there. Elvis, I just created multiple loopbacks because I needed something to inject routes into the routing protocol. That's all it was. Angelo, this is a really great question. So when do you use iBGP? Well, you use OSPF or EIGRP or any type of IGP in our area to basically get us from point A to point B. Recalculating it. It's darn fast. Now, why do we use internal BGP? Let's say I want to take the routes from AT&T and I want to hand them to Verizon. I can't put all those routes into OSPF. And the reason is OSPF doesn't scale that way. eBGP is designed to take millions of BGP is designed to handle millions of routes. OSPF at 10,000 starts to struggle. So we're using BGP for scalability, tunability, and security. Because what would happen if we entered and we put all those subnets into an interior gateway protocol that's optimized for speed? So think of it this way: you got a race car, a Ferrari. I'm not really a sports car person. I like an SUV. I'm comfortable in it. But let's say I decided it would be fun. Cindy the cat decided she's buying a Ferrari from her cat calendar sales. And Cindy the cat says, I want to get someplace quick, Daddy. You're driving my Ferrari. So when I get into my Ferrari, it's really good at going really fast. But I can't put a lot of stuff in my Ferrari. My Ferrari is optimized for speed and maneuvering. Now, let's say I want to drive 10,000 metric tons of stuff to Philadelphia from Palm Beach, Florida. OSPF is like a Ferrari. It is really fast. You get a cut of cable, it recalculates. It's fast, but it's like a Ferrari. It's not designed to scale. It's not designed to take a lot of load. It's designed to be fast. Now, by comparison, if I hired a tractor trailer and I shoved all 10,000 metric tons in there, and then I said, stop here. We're armored so that nobody else can get in. You've got 6 Navy SEALs inside the bus, and that 6-man SEAL platoon is armed to the teeth. They're sitting behind a bulletproof barrier, and they've got machine guns behind the barrier. Now, all of a sudden, now I've got throughput. I'm carrying stuff. That's what BGP is. It gives you security. It gives you tuning, it gives you scalability, as opposed to your IGP, which is like that Ferrari. It's fast, but it doesn't scale. That's why we use BGP. Great question there, Angelo. Really, really great question. With BGP, we can make one route more cost-effective or practical than another. We can tune it. We can say, hey, go out this way. This is the best way. And this way. So imagine we've got two roads. I got a road to Chris's house and a road to Abigail's house. I talk to Chris and Chris's cat, and Chris and Cindy and Sonny, who's a Chris's cat, have lots of conversations with each other. And Cindy and Noni and Abigail's class have lots of conversations with each other. They're entrepreneurs. They're building websites. They're building books and calendars. Next thing you know, they're going to have a line of cat juice and cat food. They're having parties. So realistically speaking, we can say, hey, you know, for the red furred cats like the orange tabby, go out the left link. For tabby cats with gray fur like mine, go out the right link. We have that ability in BGP. So that's why we're using it. We can make one like more practical or cost effective by policy, by tuning, by manual administration. That's why we're using it. And that is a fantastic question, Eric Slope. I'm glad you asked it. Raphael Etuk, is there a reason why we always need to use a no-shut command? Absolutely. So when you plug in your PC to the network, it just goes on. Now, how secure do you think that is? Raphael, we start all the interfaces closed. So you plug in and nothing happens. We have to enable them for you to be able to use them. So from a security perspective, we keep our doors locked by shutting them down. And we unlock our doors when we will welcome people in. So that's why all interfaces on routers are shut down. Look at routers and firewalls as critical devices that concern about security. Look at things like your phone or your PC, which are like open invitations. Come talk. Which is why we don't use things like Bastion hosts for remote access. We use VPN concentrators because PCs, for example, are designed to be open. Unix systems too. Routers are designed to be closed until you tell them to be open. Excellent, excellent question. These are some rock solid questions, everybody. I'm loving these questions, so keep them up. If you have two ASs that are not the same, it'll be eBGP. And if your two ASs are the same, it'll be iBGP, and everything's going to be perfect. So I'm not really sure I know how to answer that question. Tosan, yes, the same people that give your IP address. I believe it's IANA that basically gives you your autonomous systems numbers. Absolutely, you have to register for one. RN, RIPE, IANA, their names change, but yes, there is definitely a body that we have to go to every single time we register for one. Haven't registered for one in a while, but definitely. Although my cat Cindy, I don't know, she's making some pretty heavy-duty plans back in the business. Is there a difference between iBGP and an IGP? Huge. Can BGP affect the IGP? So kind of what it's like is this. It's kind of like you both own a race car and a tractor trailer. And you use your race car to be your IGP to basically sell fuel quickly. And you use your tractor trailer to basically transport large amounts of goods. So we use iBGP to carry BGP routes across our network. We use, what do you call it? We use eBGP to connect to external entities. So do you want to see how we carry routes across our network? We can show you that. I'll happily show you that. Sadie, could you please elaborate on advertising one more time? Sure. This is a slide presentation tool. If I don't own this slide presentation tool, and I go into BGP and say, hey, I've got a slide presentation tool, BGP tells no one because BGP looks at my routing table and says, Mike doesn't have a routing presentation tool. So now I have a presentation tool, and I tell BGP to tell the world, I have a presentation tool. And then BGP tells the world about it. That's what we mean by advertising. So if I were to say Chris lives in the Tampa, St. Petersburg area, I would be advertising his location for the rest of the world to find Chris. If I were to say, let's reach out to Reginald Duncan that's on this call. And if I said Reginald Duncan is in my house and I posted that to Instagram, the world would know that Reginald Duncan is in my house. Now, if the internet is a connection of dissimilar networks that are all connected via BGP, and Reginald Duncan comes to my house and I put in BGP, Reginald Duncan is in my house, guess what? The world's going to reach Reginald Duncan through me. Same thing with Eva Doikja. She's over there. She's over there in Hungary right now. She's off on her own. She hasn't told anybody about it. Eva Doikja, here's a router. Let's form a BGP neighbor adjacency with each other. Eva Doikja goes there and she starts creating subnets in her network. She pops those networks in the BGP. That's called advertising. I see the route advertisement. I can say, okay, to reach Eva Doikja's things, go over there as the next hop. That's what we're talking about when we say advertise. And that's a good question. So are there any other questions? Tosin, can another IGP use instead of iBGP? No, because we can't redistribute BGP into OSPF. I mean, you can do it in a lab exam like they make you on your CCA, but if you do this for real and you take in 800,000 routes and you drop it into your OSPF, our replacements will thank us, because basically what will happen is we'll pop in 800,000 routes into OSPF. OSPF will crash, our routers will crash, and the entire network will go down. So no, we can't use, it's trying to like putting in 100,000 metric tons in a Ferrari. It's just going to crush it. It's just not built to support it. So no, we can't. But it's a good question. I'll create an iBGP environment so you can see why we're actually using it, because it's a good question. This means BGP is done for scalability and to increase security and to increase filtering. That's why we're using it. Because in OSPF, what do? We send links to every single device, and every device has to know about everything. We can't get rid of it. But with BGP, remember how I just put one statement and then other people found out about it? In OSPF, that wouldn't be possible. So we have no peace. It's not convenience. It's not speed. BGP is slow. BGP is like a big giant tractor trailer that's slow. We're using it for scalability and security because it enables us to filter routes. If I don't tell you about a route, you can't hack it. So we're using it for that reason. It's for security and scalability. We have far more tunability options in BGP than any other routing protocol. Far, far more. A bunch of nerd knobs, as we like to call them. And I've used them all and love them all. Raphael Etuk, what do you need for practicing labs for the CCNA? Well, it depends on what your goal is. If you're a cloud architect, you probably don't need to be configuring too many of these things because it's all system design. But if not, you've got three options. You can go to eBay and buy yourself a CCNA, CCNP rack. That's what I would do. I would buy those routers for about $200. I would party with them for about a month or two. Then I'd sell them on eBay for the same $200 that I bought them for. That's what I would do. Now, if you're looking for something much more robust, and your desire to build a big home lab, and you want to start working with Palo Alto firewalls and Fortinet firewalls and multiple clouds, and you want to generate traffic and test 4 vendors and just Cisco and Juniper and interoperability, you're going to use EVE-NG because all your big companies are using it. It's fantastic. And if you're looking for tree, there's like another freeware. There's like a GNS3, which works. Cisco's got like a packet tracer, which also works. The book that we're recommending, Raphael, that we mentioned that you should buy, we mentioned that everybody should buy this book. It comes with all the free labs and videos and to do it. So we just recommend that you buy the book that we suggested, the Wendell Odom book that comes with it. It's got hundreds of hours of labs, lots of videos, lots of work. And remember, Cisco made it. So that's the one we've been suggesting, and it's the one we suggest, Raphael. Good questions. Chris, were there any more before I go and show why we make the iBGP a little longer? Yes, OSPF is meant for speed. Exactly. And then, Chris, are there any others?
Was it? Well,
So for lab gear on eBay, you just have to type CCNA bundle. It's that easy. CCNA rack, and they'll be from $100 to $500. Some will have voice over IP and all kinds of cool stuff. So let's go back to this environment then, because when we go back to this, I think it's going to be clear why we're doing iBGP. So over here on router 3, enable Cisco show IP route. Look at that.
Hey, Mike,
We don't have.
You're not sharing your screen.
Thank you. Okay, so on this router right now, what do we got here? Let's have some fun. All it looks good. So we have no BGP routes. So this is pretty interesting. Now, if we go to router 1, that routing table. Wow, we got lots of routes. We got the OSPF routes. We got the BGP routes. We got all kinds of stuff. But now router 3 doesn't have any. Router 3 doesn't know about any of the routes for this from this internet service provider or this internet service provider. Router 3 has no idea. Why does router 3 not know? Because we're not running BGP on it. Because we're not running BGP on router 3, it doesn't know. So let's just have some fun with this, and I'm going to show you why. So you want to know why iBGP? Now we're going to get there. So we're going to go to router 3. And we're going to go to config T. Let's make sure we get the right autonomous system number, because we're going to get ourselves in trouble otherwise. Show IP interface brief. And now it's 56789, right? Show run. All right, let's not try and use commands that didn't exist when I did my CCIE, since I've been an architect for a lot longer than an engineer these days. Okay, so we're at 56789. So let's go to router 3, router BGP 56789. Could help. You got to be able to spell router though. So if you can't spell router, like me, well, then there's other trouble. So let's type in a neighbor. So router 3 is connected to router 1 via G00 via G01. So let's go to this router and let's see what G01 was. It's 10.0.0.5. So what's the opposite number on 10.0.0.5? It should be 10.0.0.6. So let's do this. Neighbor. It's also helpful if you can remember which window you're cutting and pasting and texting into. Neighbor. So let's make sure we get it right. This interface is we're on router 3, so we're connected to G0/1. So let's make sure we got it. So it's going to be 10.0.0.5, 10.0.0.5, remote AS, 56789. Now, while we're at it, we also need a neighbor statement that's going to get us to peer with router 2. So this is going to be G01 on router 2. So what's G01 on router 2 subnet? And this is router 2, which is G0/1. So 0/1 is 10.0.0.9. So let's do this. Let's go back over here. Now, what I've done is I've fully meshed my iBGP peers, meaning this one's connected to this one who's connected to this one. Is there a reason I did a full mesh environment on my iBGP peers? eBGP is transitive, meaning taking in your routes and letting them out. iBGP is non-transitive, meaning it comes in and it can only go one hop and it doesn't get exported. So if that's why we did it. So if we did a show IP BGP neighbors, do I have a brief option? No, we can see a neighbor 10.0.0.5, add a 10.0.9. So what do we think the routing table looks like in router 3? Not up yet. Why? Do we have BGP neighbor relationship? Yes. Are those other things being advertised? They sure are. We have a neighbor up. Are we listening anything? Are the routes the next hops? We're receiving things, but there's nothing in the routing table. Why? What's missing? Why aren't we pulling any routes over here? Anybody know what's missing? Look to some of the next hops. Are they all there? Are all the next hops reachable? No routes. Why? Is the next hop available? So let's make sure we can ping the other end. Make sure we can ping our neighbors, which we should be able to because we formed a what? TCP or UDP connection. What we've got is a neighbor, but we're not getting anything. Now, if we go to this router, let's see if it propagates somewhere else. Config T. Let's create a loopback address. Interface loopback 10. See if it propagates out. Let's put an IP out of curiosity. Address 60.60.60.60 to propagate anywhere else. Is the next hop available, perchance? What do you think? Is the next hop available? The next hop available will be placed into the routing table? If the next hop's not available, it won't be in the routing table. So how might we do that? There's a command for this. There's a Cisco command. Anybody know what that command is? I see one person does. I see one does. Does anybody know what it is? We might not be able to reach the next hop, or we might actually have to tell it. So it might not be a bad idea to go in here. And also, let's just check our routing. So let's go back to our show run. You might not be able to reach the next hop, which is most likely where we've got a problem here. So we'll do a neighbor, we'll do, and then we'll tell the neighbors to make the next hop to self. When, of course, our system is done. So Ivadoike, the trace route would be good if we were getting lost, but we don't actually have the route. So because we don't have to find the route, we have to find out whether it's the next hop or something else. Now, that's usually the next hop when you can't pop it in there. So show running config, let's look at it. And realistically speaking, what this really is I've got some subnet that's not in the routing table, and that's why this next hop isn't available. So we can try and band-aid it with the next hop self command. If not, we'll have to add some additional routes and subnets to our IGP. Nine as well. This may solve it. If not, what we have to do is we have to literally start searching. Now, I killed the BGP session by clearing it out. From the neighbor relationship again. Now we've got a next hop for this route that we just popped in there. Let's look in the routing table over here. Back here. And we're only getting our own, so let's look at this. But at least we now have access to our own. So the point is we had something that's failing more than an next hop. And what that is one of our subnets that we need is actually not here. But we're also going one hop away via iBGP, which means chances are we realistically needed to set up a route reflection. That's getting way, 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 way outside of where I wanted to take us to. But I just wanted you to see that no matter where we go, if it's a cloud provider or if it's a internet service provider, it's the same BGP we've now used for the last couple of decades. Nothing's really changed. So while we're at it, I feel like it might be a nice thing to do for example, maybe show you how when we're dealing with connections to clouds, what do they mean when they do cross connects and things like this? Like, what does that really, really mean? So what does that mean to you? I'll kind of show you. So what is it? So normally speaking, when we connect to a cloud provider, we've got to connect to them on a switch. So actually, let's do this. Let me close this. Let's actually do a generic cloud lab. So we'll add a new lab. We'll call this Cloud Direct Connections because they all work this way. This is pretty normal when you connect to a cloud provider. We're going to have two routers. I have one over here. Now let's add a switch. Let's add a node. Let's add two switches. Two. Now you see what we're actually going to build over here. So right now what we do is we're going to build a direct connection. So the way a direct connection is going to look, to get you understanding this, you're going to have your router on your end, and you have to have a router on your end, and you'll be connecting to a virtual router on the far end via the same way. Now what'll happen is you're going to get a connection to your stuff, and somewhere along the line a wire is going to need to go between your organization and their organization. So let's show you how we actually do this. So let's what do you call it? So let's say we've got a router over here. This is our router. We'll start it up. Let's start this up. Let's start this up. Let's start this up. And let's let them boot. While we're letting these devices boot, everybody hashtag CCNA. Pop it in the chat box. I know you're awake, alert, and oriented.
Got a question for you to take a look at while we're waiting. If you
okay, sure.
So it's from Martian.
Martian, I'm going to demonstrate how this works right now.
I had a feeling that was going to be the case, so that's why I wanted.
Because we're using a combination of switches and routers here. Let me get this thing set up so I can actually show you how we do this, because I wanted you guys to all truly understand this.
Yeah, I had a feeling that was the case. That's why I wanted to make sure I did it in a timely manner.
No, I think that sounds really great. I'm so glad you asked that.
So make sure you share your screen again before you get started.
I will. Just waiting for my stuff to come back up. So when we deal with the cloud providers, we're going to have a combination of layer 2 technologies and layer 3 technologies, in that we're going to be using our own routers, but we're also going to be using some switching as well, because we're going to be sending VLANs. So let's just look at how this works. No, of course, we're not going to use any of these ridiculous configuration dialogues. Okay, so now let's do this. Let's give it a host name, because I don't know about you, but I have no short-term memory, and I won't remember 3 minutes from now what I call this thing without a host name. And when you get to networks like I deal with that have 10,000 of these things, you're never going to remember any of them without a name. So give it a name. We're going to call it R1. Now what we're going to do over here, I always put a loopback on something as part of my addressing scheme. I'm not doing any fancy addressing. I'm just doing 1.1.1.1. 255.255.255.255. We only need one link over here. Now we also have to configure this link over here. So let's go to interface G0/0. The address 192.168.1.1 255.255.255.252. Okay, done. While we're at it, router BGP 1 2 3 4 5. That's going to be us. We're going to pop in a network of 1.1.1.1 mask with a 24-bit 255.255.255.255. We'll do a network 192.168.1.0 to mask 255.255.255.252. Okay, so that's done. Now we're going to get on this switch. And when the way all these things work is I connect to a direct connection location. So here we've got in this direct connection location. I forgot to share my screen, which is pretty normal. So unfortunately, let me show you what we put on this router so you can see what we did. We'll do a show running configuration. I didn't do much. Show run. See exactly what I did. I gave this router a host name. I did nothing other than add a loopback address and an Ethernet port, and all I did was told BGP to be on. I didn't pop any routes in. I did absolutely nothing over here. Now let's take this switch port over here on the switch. Enable. Now let's take, what we're going to do is we're going to configure this switch, and we're going to make this our switch, company SW, so we can see it. Now the first thing we're going to do is we're going to have to go to this interface over here, G0/0, G0/0 on the switch. Now what we have to do is we have to tell this to be in a VLAN. So what we're going to do is we're going to give it a VLAN, switch port access, VLAN, let's say 10. Now what I did is I created a VLAN and I popped that port into a VLAN. So if we actually do the show VLAN command, what you can see is we've got VLAN 1 and a VLAN 10, but we have to pop some ports into VLAN 10. So let's go back to this. Now hopefully when we do this, you can see that the port's been added to the VLAN. I don't see it, but oh, that's why. Make sure we got it right. Show VLAN. Okay, so we can do this. We can see we have VLAN 10, and we can see this port is in here. So now any traffic that's going to go from the switch, this router, to this VLAN is now tagged. Now what we need to do now is, what has to happen is, let's go to this far end device. This is going to be our device, or our virtual router on the cloud. So when this comes up, what do you think of the opposite side IP address is going to be? Let's enable this. Let's call this config T. Let's call this host name, cloud virtual router. Enable password Cisco int LOO. Let's pop an IP address on this. 2.2.2.2. So shutdown interface. What link is this going to be on here? It's going to be G0/0, G0/0, IP, ADDR. And what do we think the IP address on the far end of this is going to be? Show IP interface brief. It's going to be .1, right? So IP address is going to be 192. Whoops, on the opposite side. 192.168.1.2, 255.255.255.252. We'll do a no shutdown on this. Remember the one that's shut down on the opposite side. which we'll deal with in a second. Or and when we connect to this device, it's going to be the cloud providers, not ours. The cloud provider's autonomous system number. So if router 1 is ours, what we're going to have to do over here is we're going to have to configure a router, BGP, and we need a different one. So if we used over here 1, 2, 3, 4, 5, let's use 6, 7, 8, 9. Now over here, what will we do? We'll pop in a network statement for the 2.2.2.2 with a 32-bit mask, 255.255.255.252, 5.555. Then what we'll do is we'll pop in a network statement for the WAN, 82.168.1.0, mask 255.255.255.252. Okay, so now we have everything here. And let's make sure our ports are all enabled. Show IP int brief. Okay, so that's up. Are the ports up on both sides? Is this device up? Okay, it's not. So let's do this. Config t int g0/0. No shutdown. Okay, so now we've got over here. Let's look at what we really have. We have this router over here. It's got its IP addresses configured. This router over here has its IP address configured. Now, this router is going to have to go through this switch, and it's also going to have to come out over here. So this switch over here going to the virtual router has to be on the same VLAN. The same VLAN as we've got on the opposite side. So config t, let's call it hostname, cloud switch. Now what we have here, let's do an enable, password, we might call it Cisco. The switch is just going to be transparent. But now we should go to interface, G0/0. What do we need here? We're going to do a no shutdown on it. We're not going to put an IP address on it, but we do have to put it in the VLAN. So we should do switch port, mode, VLAN. We should probably tell it access. Actually, it should be switch port. I think it's access. Access. VLAN, because we use VLAN 10 on the other side. So let's make sure we do switch port mode access. So VLAN, let's make sure we did it right. Okay, so we can see we've got a VLAN 10 over here. Now, if we make a connection between here and here, we've got two options. We can add that port right to VLAN 10, or we could try making a trunk port and trunking multiple VLANs. What do you guys think we should do? Make a trunk port, or just make it in the standard VLAN? Well, let's make a trunk port first and see what happens. Let's go to the switch. Let's go to the link in between them. All right, so the link in between 1 and 2, config T. I haven't made a trunk port in 20 years Because I'm a layer 3 person, but let's do it. It'll be fun. So let's make a switch port. So let's see with a link int G0/1. I think we should do switch port trunk. I think it's encapsulation. .1Q. Let's see over here. VLAN 10, we've got some. Okay, I hope I actually did this correctly because it's been a little while. Okay, so now let's do a show run because we're going to do the same thing on the opposite end. Let's go to switch 3. That should be the cloud switch. And what are we doing right now? We were connected to here, and this device was connected to here, but we need to run a cable from here to here. That's called a cross connect. So we buy an Express Connect on Azure, Direct Connect on AWS, Direct Interconnection. It's all the same thing. What are we doing? We're buying a link from here to here. And then they're going to run a wire from here to here, which is the same thing that we're doing over here. We're going to do this. Now, I haven't configured a trunk. We may have to pop it in the same VLAN to be on the VLAN, but whatever the case is, we're going to get it to work in some way, shape, or form today. So let's have some fun with this. We're over here. We've got our cloud switch. Now this should be switch 2, which is on our end. Let's make sure we can go through the same thing, make sure we're in the same environment. So cloud switch, it's going to be what over here? It's getting interface int G0/1. Let's make sure it's the same place. It's G0/1. So while we're here, G0/1, let's get to here. Let's do switch port trunk encapsulation .1Q. Then let's make sure over here what we have is a switch port mode trunk. If this doesn't work, we'll pop it in the same VLAN. I haven't configured VLANs in a long time. Okay, so we've got 2 ports that are up on both sides. Now, if we go from one side to the other over here, what do we have? Show IP int brave. Can we reach across the side? No, we got something wrong. And it's related to our trunk point configuration. Just check and verify our configuration while we're at it. Make sure everything's up. Make sure we can reach ourselves. We can reach ourselves, but we can't reach over the other side, which means we've got a VLAN mismatch. Because if we were all on the same VLAN, we'd be able to talk to each other. Here you can see mismatch, mismatch, mismatch. How are we going to fix this? Well, for one thing, we can make sure that our ports on both sides are on the same VLAN. So let's do it this, a show run. Turn this into a standard wire. Okay, so we've done our half of the cable over here. Nope, look at that. We've got a spanning tree blocking state. Why? We've got a .1 QBPTU on a non-trunk port. That's not supposed to happen. So look at it. It's blocking the port. It's looking at it and saying, hey, woohoo, big problems. VLAN's gone on the wrong places, all kinds of stuff that we don't like. Native VLAN mismatch, all kinds of ugly stuff. So let's go fix it on this switch. Let's go look at the running configure this one. Media speed, media speed. Okay, well, we're on the wrong device. Cloud switch is where we wanted to do the show run. Cross config T. Int G0/1. No. Switch mode trunk. I'll get rid of that. No. And all of a sudden, those messages are going to go away. Hopefully. Gone away. Now let's make it an access VLAN. Now let's make it access. Now let's see if we can ping across the link. So if we do a show VLAN, we should have both sets of ports in that VLAN. G01, G02. Now if we do the same thing on this one, we should have the same thing. Okay, we got both ports. So can we ping on the other link now? We should be able to. We should be able to. I'm not sure why we can't right now. Make sure all our VLANs are the same. And this happens when you do this stuff live. This should be up and running in every stretch of the imagination. Because if this has got the right ports in both VLANs, make sure both are there. And this one has 0101. Wrong place. I'm not sure why we're not getting that. Well, under these auspices, You do a write memory, and you do a reboot. Because everything we just did here should have worked by every stretch of the imagination. So let's do this. We're getting into that 230 range. Let that system reboot itself. Let's answer some questions to close out the week. And then when I want to bring in on our very special guests. So let's do this, Chris. Let's bring in some questions while we let that stuff sort itself out. These are the questions I'll reboot it. It should come back live because we've got a wire between two cases. But whenever you're playing with tech, you experience these things. So read 5 minutes of documentation to save 5 hours. But seriously, when you go and configure these things long term, you're going to find all kinds of things which work. And then you're going to find out that doing the thing that should work doesn't work, and then you need to tune it based upon an iOS variation or a bug. But in any case, we're dealing with pseudo devices and pseudo wires and pseudo connections. Every once in a while, it's fun. So, Chris, let's bring in some questions from the audience. Let's close out the week strong, and then I really want you to bring in, Chris. I want you to bring in Lam and eBGP after that, and I want to make sure we get what do you call it, Alonzo here as well. For a direct connection, if they are not close to the POP, they connect to it the way they went anywhere else, Angelo. So I can buy a direct connection between my house and Palm Beach and eBGP's house in Hungary. It doesn't matter how close they are. We would just use the WAN connection. So if what you're asking could be what is edge computing, so here's the thing: we can run the computing in our data center, we can run the computing in the cloud, we can run the computing in our data center, and some midway point to the cloud called the edge, like a point of presence. We can do it anywhere we want. So if the company is not close to the point of presence, they've got a wide area connection to the point of presence. That's all. Higher latency, that's the issue. And that's really where we get ourselves in trouble. When we deal with the cloud and we deal with these 1,500-mile cables, there's latency. So that's the point of doing edge computing, is to try and get around that latency in those unique specific use cases like that. Was that what I forgot? Switchport access VLAN 10 on the second switch? I'm pretty sure I popped it there, though. I will check just to make sure, but I'm pretty sure I had it in the running configuration. Show run. Let me check there, Tosin, because I've been known to forget certain things. So on the second switch, I have switchport access VLAN 10 and switchport mode access, and I should have that on both switches because, like I said, it's configured the way it should be. But let me just check. On both of them, we have switchport access VLAN 10 and switchport mode access. But, it's a heck of a great idea there, Tosin. I was wondering why it shouldn't make sense, because that's exactly what I have in there as well. Chris, okay, Sadie, what does the network engineer do to set up a direct connect?
They ask, is this what the network engineer does?
Oh, Sadie, no, this is not what a network engineer does. This is just simple network admin, simple, super basic sysadmin work. What a network engineer does is they determine, what do the routes need to look like? How do you tune BGP? Are we prepending ASs? Are we changing the rate? Are we setting a community, matching a community? We're using a route map, a distribute list. They might be planning some of the IP addressing. So no, and a network engineer is going to do the heavy duty stuff. This stuff, that kind of cut and paste the configuration, is junior admin work. So that's a good question. So Sadie, an admin or an administrator just configure stuff, which is the stuff that I'm doing. As you can see, I'm not a configurer because I'm an architect. So the admins do the basic configuration. The network engineers do a lot of the thinking and, okay, if I tune this protocol here, if I tune this, if I tune this, if I tune this, and those engineers get really, really, really smart in the weeds. But the engineers are going to be focused on one area. Maybe he's focusing on the BGP, the IGP, the tuning. They're going to be zoomed in. And then Sadie, the network architect like me, takes a big step back and we start to say, whoa, companies got some challenges that need to be solved. What are their business pain points? What are their legal goals? What are their challenges? What kind of technology solution can I craft? And that technology might include new workflows, new voice, new video, new anything. And then the network architect thinks about the networking technologies that are going to make it work. Are they routers? Are they switches? Are they clouds? What is it? So that's the job of an architect. So an architect design, engineer, really smart, do all the thinking, admin, minor configuration, hands-on implementation. Good question, though. Isn't direct connection involve an ISP? No, it involves a service provider who may also be an ISP, but they're very different. An internet service provider means, Sadie, is that you're going to the internet. And then through the internet, that's what an internet service provider does. A private line is you buying a wire. So this is the wire that you're buying, not the internet connection. And why do we have to use this? Because the internet is the connection of routers across different autonomous systems. Once I send your traffic to the internet, there's no guarantee that it needs to get there. I'm connected to AT&T. Once I leave AT&T and hit Verizon and hit Vodafone and then hit AT&T and then centrally, I could be 10 internet service providers away before I get to my destination. And no internet service provider is guaranteed to deliver my traffic. And they don't guarantee me any performance or speed. So when we use a direct connection, no, we are dealing with a service provider who may also do internet service provider services, but that we're not buying internet service, not even close. We're buying a wire between them, Sadie. And that's the difference between a VPN and a direct connection. VPNs would, typically speaking, go through the internet. Direct connections, private lines, the wire that you're purchasing. Angelo, great. Eva Doike, I hope we can find you over there so the world can see how wonderful you are, but it's up to you if you're not ready.
So we've got everybody if we're ready.
Let's bring everybody on. I want everybody to see the fantastic people that have helped put this together for the community.
Me, just me, all by myself. I'm just kidding.
Chris has been a big help too, obviously. Lyman, good to see you. Alonzo and Eva Doike. So let me introduce everyone here. Everyone in this group is someone extremely special. I call Alonzo my brother because we speak at 10 o'clock at night over things that are totally unrelated to these things. Letting all of you know, starting in 2 weeks when I get back from my vacation, there's going to be a Mike and Alonzo show. We're going to be talking about current events, fun stuff, and networking, fun stuff, and cloud. Alonzo's actually heading up our cloud engineering program, so you're going to see a lot more of Alonzo coming forward. Now, Lyman is an old school CCNP. He's been working in networking for a long time. He's got some cool cat clothes around because he knows we love cats around here. Lyman is an amazing cloud architect. I'm going to say this again. Lyman is an exceptionally good cloud architect. He's helped us with our books. He's helped us with our content here. Lyman is a cloud architect. For anybody that needs a great cloud architect, Lyman is your guy. I mean, he's fantastic. Know him, respect him. He's been with me for months, and I'm very grateful that he helped. Now, Eva Doike is here. I can't even begin to say anything but great things about Eva Doike. I wouldn't even know where to begin. I have so many wonderful things to say from the first time she and I spoke when she was in England, and she was telling me about all these amazing languages that she speaks. She helped draw so many graphics. She helps research with everything, and she's been a blue wrench. So, Eva Doike, you're too humble to even be here. So thank you for showing up. Thank you for being here. The world needs to know what an incredible kind of cloud architect you are. Network engineer, network architect. You've done so many great things out there, Eva Doike.
Thank you so much. Thank you for this possibility, Mike.
So,
I'm really lucky to say it. Sorry for interrupting. I just wanted to compliment my colleagues because It is the first time that I find myself in a situation where actually everyone in the team is participating with a great dedication, great seriousness, effort. So there hasn't been a moment that someone hasn't done their share of tasks, and no one complain. Everyone helps one another. So thank you very much for that possibility, and I love you folks. Thank you so much for everything.
And I love every last one of you that are there. You and I, we're all very close friends. I got to tell you, not only are these amazing people helping out here, but most of them have also been working with our Cloud Heroes Africa project, where we've got 50 volunteers in sub-Saharan Africa, getting people through AWS certification. So these are really, really special. Alonzo and I have been working behind the scenes pretty much every day for 6 months now on a project. Literally speaking, the calls that Alonzo and I have are nonstop. If there's ever anything that's been drawn that looks good, professionally speaking, like on a website or something, it's probably because Alonzo fixed it for me. And if you ever and if you know me and you know my versions of napkin sketches, here's a picture on my iPhone. Can you make this look good? Alonzo is a pro. He does so many things to help me with that. So what do you guys want to say to the community? You guys are amazing cloud architecture, amazing network engineers. You've got a big background. What kind of guidance can you give others to build their best career?
Well, if I may, first of all, Mike, thanks as always. You created a phenomenal platform for everyone, whether they're new to cloud or whether they're very experienced, a voice for everyone to come together, learn about the cloud agnostically, be able to compare notes, be able to meet like-minded people, and it's just a phenomenal thing. So what I can say is, originally I pioneered cloud learning and trying to do it all on my own, trying to look at different resources and everything else, and I really came to an impasse of how much I can learn. Everything was more focused on how to pass the exam versus how to thrive in a cloud environment, specifically a business cloud environment. And Mike just laid all the groundwork out. What I learned exponentially from him in 6, 7 months when I started, it took me over a year to learn by myself. So I give you kudos. I just celebrate your name. And Chris, I love working with Chris. Chris is awesome. He's just behind the scenes. You guys don't know how much work he puts in, the patience, the ability to keep all the plates spinning, and being able to do all that is a monumental task. And he does this by himself. And we also have people that help, but ultimately he's the one from morning to night answering the calls, helping establish all the connections, problem solving, issues, and everything else. So kudos to Chris for that. And now I want to start with Adokia. I'm going to start with her. She does not
Thank you.
like to be talked about. She doesn't want the kudos. So I'm going to do it for her. And she's awesome. She's positive. She's intelligent. She's quick witted. She's able to
Thank
not
you.
only identify problems, but she's also has a solution to go along with it. Oftentimes people have, well, I have a problem or we have a problem. So what do you want to do about it? I don't know. But Adokia already has a solution. Like, okay, we
Yes.
have a problem, but I have solution 1, 2, maybe even 3 that we can provide as a means to get things done. So please give Adokia a shout out. Please get on Slack, say thank you.
Thank you
Please
so much,
just
Alonso.
emphasize that she's just an awesome person. So kudos to you, Adokia.
Yeah,
Thank you so
I'm gonna
much.
piggyback on that just with two words. Actually, just one word. Persistent.
Yeah.
I mean, she's persistent,
You know what I'm talking about, right?
which is great. You
Yeah.
have to be persistent, and so that's all I got to say about that.
Thank you very
Yeah.
much, Alonso. That's really a touching message, and thank you, Chris. I really don't know what to say because I haven't been treated so well in a long time, so that's a bit too much for me.
Soak it in, girlfriend. Soak it
Yeah,
in.
Yeah,
it's
seriously. Chris
no,
feels that way.
thank you
I
so
feel
much.
that way. Alonzo does. I know Lyman does. I know every student I have does. I know
Yeah.
people come to me and they're like, Eva Doikia makes the world such a family. And people are working with you in 3 different continents, and they love it. They all tell me how wonderful you are. So thank you.
Thank you. I'm happy I can contribute, and I can help anyone as much as I can and as much as it's possible. I'm always happy to provide content and help and guidance and just, I don't know, regular talks between friends. So we are in this together, folks.
Yeah. And
That's the
also, I
key.
want
We're all in
to,
it together.
yeah,
And Lamin, I'm watching him. He's doing Cloud Heroes Africa with in Cameroon with us right now. He's making content with me. I'm always running something past Lamin. So I got to tell you, I wanted to make sure the world knew your names. You guys are doing way above and more than other people that are doing it as their careers, and you're doing it just to help people out. So please, I wanted the world to know that. And of course, we all know how I feel about Chris. Chris takes phone calls from me at 11 o'clock at night. Hey, Chris, I had this wild idea. Can it work? And wakes up in the morning with 42 ideas from hyperactive Mike, to which like, hey, this is a great idea, Mike. Yeah, this is great. Mike, I don't think this is the best of ideas. And we all need that person that checks us. So, Chris also makes sure that my students are successful, meaning his students too. Chris makes sure that we respond to everything we need to, that everything works. So all in all, this company is half Chris. Got to say lots of great things about Chris. Even though we've got other employees and lots of people, Chris does a lot to make this successful, and we know that.
I got to say,
Okay,
it was a pleasure working with you as well. Working on these projects, I want to give you kudos as well. Just always there to lend a helping hand. Your positive, quick responses, just a joy to work with. So what we put together and what we helped Mike put together has just been a very awesome experience because of this team. So I just say again, anyone on the Slack channel, if you know anyone who is not a part of the GCA community, get them involved, because if they are interested in cloud, this is the place to go. This is the people to hang out with. This is the experience that they have to have for themselves. And I don't say this, I mean, this is not paid promotion. This is my own personal experience. So I want to be able to just do that as a disclaimer that it's been one of the best decisions of my life. And anybody with cloud or interest in cloud, jump in and you will learn exponentially, and it'll be life changing. So thanks again, Laman, also for that.
yeah, yes.
And also, I can only
I
agree
just
with
want
you.
to share
Yes.
this experience that I had. Thank you all. I did my CCNA back in 2010. So, and after doing my CCNA, when I started working in the industry, I was lecturing CCNA. But then the way I was doing it is just edit normal um, normal PowerPoint presentations, and we just do the presentations. I never had the experience of creating like the materials like we did in when we were doing this when we were creating these presentations, these materials. This was a great experience for me. So from now on, I have learned a lot from Elodro, Ivo, and everybody. And Chris was amazing as well. And Mike, we couldn't say much. So and with the networking experience that I had of recently, I think January to December, I did some certifications on cloud, and I want. I don't know how important the people who are following this CCNA, how whether they know how important this is, but this is very very important because the CCNA is the background of the IT, is the backbone. So if you have this background, you will be if you have this background, you'll be able to do any like the cloud comes easy because I did like 6 certifications in 2 months. And if you look at it, it looks like it's impossible. But it is simply because of the background that I had. That was the reason why I was able to do this. And apart from that, I was also involved in like the book authoring. All those are learning processes. Other projects were there that we were also doing, building the cloud on our own. So there is a lot that like Mike would say, like you train like an Olympian. So if you if you if you are definitely training like an Olympian, it will be easy for you to definitely achieve. So and I'm so grateful to be part of this team. And Ivo, thank you so much for coming. And thank you, Chris, for everything, and thank you, Mike, for having our back, taking us through this thing. Thank you so much. And
I'm just so happy
and
to.
our quarterback, Alonso, thanks a lot.
You're welcome.
Yeah.
Thank you for
Thank you.
this possibility, Mike. You really give us a chance to have a better life, literally.
That's
Be
the
it as a
whole
cloud
goal.
architect, anything.
You know, when I started in tech, I came from medicine, so I was a bit of an oddball. And it was that oddball thing that really helped me, because what did I learn in medicine? How to ask people the right questions in a non-judgmental sort of way. And what was my best skill as an architect? Asking people questions, because let's face it, people bring in really senior architects because either they've made a really bad mistake and they need to fix it, and you can't make somebody feel bad. You got to be able to look at it, get access to all the information, take it all in, and then come up with a solution. Or they're calling an architect for the following reason: they want to improve their business, and they know that you can help them. So for me, it's all about, solve customer problems. So whether we're teaching our students how to be the architect of their career, whether we're teaching a patient how to eat the right diet, exercise, and take care of themselves, or whether we're designing the cloud solution to improve a company's business, what are we doing? We're asking questions, we're evaluating the solution, we're making an assessment, and we're building a plan. Apply that plan to your life. Network engineering, cloud engineering, network architecture, cloud architecture, medicine, business. It doesn't matter. It's all really the same thing.
I want to thank all of y'all for the work that y'all put into this. I don't know. I've shown this. I've shown this several times over the past 2 weeks, but
There's 2 volumes.
There's 2 volumes to this. This is literally like 1,800 pages worth of content that these people right here helped us make sure that we got the relevant information to cover with you. Because
so they all went through the official course. And we tried, like I mentioned in the first day, we tried to use the Cisco official timing so you could go back to it. Now, having said that, these wonderful folks went through the request for comments. They went through Cisco documentation. They went through Juniper documentation. And they went through these books. So when we do content, it's not just coming from a book. But we like the Cisco Press books, and we used it in that order. So guess what? You can buy that book. You can do all those labs, watch ours and theirs, and poof, you'll be certified, and you'll be knowledgeable too. Good seeing you, Network Bra. Sharon, wonderful to have you. Marjan, thank you so much. Sarah Ahmed, yes, Chris is amazing. Tosin, thank you so much. Earl Owens, thank you so much. Mohammed, shukran. Marjan, thank you so much. We're super grateful to have you here. I'll work with that too. Amen. CCNA is the groundwork. I love it. Marjan, GCA family. Yes, that's actually really important before we go to the next one. My students will tell you they're a family. Whether it's Eva Doikia working with Abigail across the ocean, and those two do all kinds of cool projects, or Alonzo working with Joe over at AWS, who was one of my students before. They're all working together and they're all helping each other. So it's a family. And that's really important to me. Yeah. Really important to me.
And now I answered this next one in the chat box, but I figured I'd let you address it as well.
Eric, here's the thing, and Alonzo will tell you, and Laman and Ibudaica will tell you, the shortest distance between 2 points is a straight line. The average cloud architect earns $600 a day. A good one will easily learn $1,200 or $1,500 or $1,800 a day. The sooner you get to my program, the sooner you graduate. So if you wait 2 months to do the CCNA, when you start, it's going to take you just as much time because remember that what we're teaching right now is technical. The job of the architect is much more business, leadership, executive communication. So there's so much to learn just beyond the technical. So if you could do the CCNA now and then come back to us in 2 months, And if it takes you 4 months to get through, it'll take you the same 4 months, 2 months from now versus later. We're kind of like a fire hose. We come at you with everything. We come at you with the network, the leadership, the communications, the cloud. And by doing it this way, each piece layers on top of the other pieces and it makes it easy. So when you go to college and you get your MBA, you're taking an accounting class and a finance class at the same time and a presentation class. That's the way we do ours. So the best thing to do is to take ours now, and then that'll make everything else silly easy. That's why Laman could pass 6 certification exams in a month, because it was easy, because he knew it. That's why I could do the Google Professional Cloud Architect exam in 2 days. Because when you know the materials, these exams become simple. And in our internal courses, Eric, we get a lot deeper.
Yeah, and to follow up on that, it's not just a one size fits all course.
Yes.
So the biggest part of the program is your personal development plan.
Yes.
You with our input come up with your development plan, and CCNA may be part of that development plan. It may not be. Based on your experience, based on your background, you may not need to worry about CCNA, but you'll get the knowledge of CCNA just by taking part in the program. So your development plan may be security focused. So you actually do preparation for a security exam as part of your training. So that's the thing about the program. The program is not one size fits all. The first 3 sections of our program are all about you figuring out what you're going to do and putting your plan together. That's for you. And then you following your plan. And then sticking to that plan is the next most important part. Making sure that you stick to that plan. So that's the thing. It's there's not that's why we say that there's not any prerequisites, because that would just be a standard SAT, minimum score to get into college. That doesn't mean anything for those non-Americans. I don't know what the equivalent of a SAT is, but anyway, bad example there.
Yeah, but the point is it's not one size fits all. It can't be one size fits all, because Laman's got a good network background.
Right. So
Laman is different.
We wouldn't tell Laman to worry about CCNA certification because he's already
got it. But you got Alonzo, who's got extremely good leadership and program management skills beyond anyone else. So when you got that skill and that asset, you train Alonzo differently. You put him in a position where he's going to be coordinating, managing, and designing the larger building project, because he's already got a specialty strength. He's already got something that separates him from the rest. Eva Doik is a scientist. I mean, she's a rock-solid scientist. I used to be a scientist. I got used to basically taking the complex and making it CEO ready. That's what I love to do. But if I need something detailed, Eva Doik loves it. And we need those detailed scientists for certain projects. So the key is, we all have innate gifts. I like to say they're our superpower, but we all have something special. For me, I like to communicate. I like to present. That's my thing. That's how I built my career in presentations and white papers. But that's me. But my wife is Miss Analytical. She can do calculus in her head. I'm not joking. So trying to get her to play my game of presentations would be silly when she's got an IQ of 170. She learned Spanish in 2 weeks because her translators couldn't understand her thoughts. And she can do calculus in her head. For her, she plays the analytical game because that's her strength. So the real key is, that's why we don't have anything focused. We have a career development program on the first day, because I want everybody to use their best strength. That's how you win. You use what's good to you. Chris is so darn organized and analytical. He can find patterns that I can't even imagine. And does. And says, Mike, look at the data. I built an entire career on gut. I literally could walk into a room with 500 people in there and read the people, because I practiced medicine and I pretty much got an extra degree in psychology, which we don't really talk about because it was a big hobby in sociology. So undergraduate, I did an extra 60 credits in psychology and sociology. So I'm used to reading people, and I used to take reading people lessons. But whatever the case is, thank you so much, Tosin. What a nice thing to say. Raphael, thank you so much. Frank, thank you so much. Jermaine, Team GCI, I love it. Roman, what a cool name. I'm assuming you're Russian with that name. Mark, thank you all. Danica, thank you so much for all the work behind the scenes. Yes, thank you for everybody that did all this work behind the scenes. I promise you, to make 2,000 slides with those kind of graphics was not easy. Finney, thank you so much. Is the CCNA is the same as the CCNA voice? No, they're different. Cisco's got a CCNA for networking, and they've got a CCNA for voice, and I think they even have one for security too. Thanks so much. You're more than welcome. The thing for us is, I'd love to start with inspiration, because inspiration inspires dreams. Dreams inspire plans, and plans inspire success. Network Brock, you work as a network engineer doing mostly layer 2, and you're already CCNA certified. How would you go? So Network Brock, first thing I would do is I would take all that layer 2 stuff and pretty much realize we don't do any more of it, and it all becomes layer 3 stuff. So I would master your IGPs, I would master BGP, I would master MPLS, I would master software-defined networking, I would master QoS, etc., etc. Then I would master virtualization. Then I would master containers. I would learn all about storage. I would learn all about load balancers. I would learn about IDS, IPS systems and firewalls and VPN concentrators. And when I mean learn about them, I mean a couple of thousand pages of knowledge on each one will cover you there. And then Network Brow, I got to tell you, none of that, while that's all the technical piece to become a cloud architect, it's not going to get anybody there without the business piece. So you must know how to do ROI modeling. You must know how to speak differently to the CEO, the CFO, the CIO, the CTO. Absolutely critical. You must be able to to be able to show the customer that if they buy your $1 billion solution, you'll be delivering $2 to $3 billion of business value through ROI modeling. You're going to have to show that you've got enough business acumen to read a financial statement, read a balance sheet, and be able to craft technology solutions to go solve business problems. You'll need to be getting good at presenting upwards of groups of 5,000 people, because I promise you as a cloud architect, you're going to be presenting constantly. And you need to learn how to write like an executive, because you're going to be writing for executives. So pretty much that's the information to do. So we've got a cloud architect career development program that takes that into about 500 hours. And, we're proud that we can summarize all that content into about 500 hours of training, because that's the minimum we can do it. And in that 500 hours, we've got to cross between CCI level BGP and CCNP level networking and heavy duty data center and Linux and everywhere in between. So we can do it. We do it all the time. It's not something that's super easy to do on your own, but you can do it if you want. Just spend a tremendous amount of time on our channel. Watch lots and lots of videos and read all the required recommended things we say.
So
Tom Orpheus over there in the Netherlands, it's good to see you. Just in case you understand me, Yasu Abdallah, thank you so much.
So do we have anything else that we want to do to close out the boot camp?
I think everyone should have a wonderful, wonderful weekend. Personally, I'll be a little scarce for the next week. My team has told me I have to take a vacation.
Yes.
They have said that, Mike, you've been working 120 plus hours a week for the last year straight. You haven't taken a single day off, except when you had COVID, and you took 2 days off and continued work with COVID for 6 weeks straight. So
and
my
you
team
did not do that voluntarily.
Oh, well, I mean, I guess nobody can tell the CEO they have to go to work, but I have students that depended upon me, and I have students that need to get hired. And like Monday night, 3 people called me, and since then more people called me. So I got to get my students hired. So I'll try to fight through COVID if that's what it takes to get my students hired. But you know what? It's been a year. I'm going to take off a week. Boy, when we come back, there's some cool stuff our students are going to be experiencing.
Enjoy the time off.
Yeah.
Have a wonderful weekend, everybody.
Take care,
Bye.
everyone.
Thank you, everybody.
Thank you all. Thank everybody that participated. Take care. One more time, hashtag CCNA, and one more time, hashtag Cloud Hired. That way we got all kinds of cool trails that I can see when I go watch back the videos. It's going to make me feel good that you guys were all here and you guys all paid attention. So thank you so much. I look forward to seeing you on another video very soon. My team has lots of videos that they're going to be posting in my absence next week.
Bye, everybody.
Take care, everyone.